Settle down, sit back, relax, and put your phone on silent mode. Thank you. And the first presentation of this day is online through the web. So this will be exciting and interesting because somebody from the different continent is scheduled her time just because of us. So I appreciate your presence and I request you all, please settle down. We are about to proceed for the first presentation of this day. And once again, Ministry of Electronics and Information Technology welcoming each one of you to workshop on MEITY NSF Joint Research Collaboration 2023. Thank you very much, ladies and gentlemen, for taking out time from your schedule and joining us here. It means a lot to us. Now I request all the delegates, all the esteemed speakers, and all the respected researchers in the house, kindly take your seat, sit back, relax. We are about to proceed for the first presentation of this day. So the first presentation is for the topic Semiconductor and Cybersecurity. Speaker is Yunsi Fei from Northeastern University, USA. She will be joining us shortly. Yunsi Fei is currently a professor of electrical and computer engineering and associate dean for faculty affairs of College of Engineering at Northeastern University. She directs the Northeastern University Energy Efficient Secure System Laboratory. She received her BS and MS degree in electronic engineering from Tsinghua University, China in 1997 and 1999 respectively, and her PhD degree in electrical engineering from Princeton University in 2004. Her recent research focuses on hardware-oriented security and trust, side channel attack analysis, protection and evaluation, deep learning security and secure computer architect. So ladies and gentlemen, she will be here in a while. I request each one of you, please help me to welcome Yunsi Fei all the way from US.
Thank you. Can you hear me? Hello, can you hear me?
Definitely, ma'am. Good morning from India.
Okay, thank you. It's my 12 a.m. So anyway, I figured out the time. 12 a.m. November 3rd. Nice to meet everyone. Let me should I share my screen? Okay, let's see. Can you see my screen now? Okay, should I start?
Yes, please, ma'am. We are able to see the screen. You can proceed with the presentation. And I request you all, can you just put your hands together to welcome ma'am on board? Thank you.
Thank you. Before I start, I have to say that when I was in Princeton, 1999 to 2004, my advisor, he was from India, Professor Neeraj Jha. And recently I hosted a couple of MEITY delegations right here in Northeastern, just met a couple of people. So anyway, good to see you all. So today I want to share some of my recent work, physical side channel for hardware security. And it has an interesting two sides, double-edged sword, can be a foe, can be a friend. And this is our recent work, and this is a collaboration workshop between NSF and MEITY, and this work has received very generous support from US National Science Foundation. Okay, so power consumption, electromagnetic, illumination timing, and light and sound, all sorts of physical parameters. And side channel analysis has successfully cracked many crypto systems over the past 2 decades. And then over the past 5 years, as like a deep neural network has revolutionized many application domains in our life, DNN also has become a very lucrative target of side channel attack because the confidentiality and the privacy can be significantly breached. And here is not the secret key, but there are all sorts of like IP of the DNN, like hyperparameters, like a kernel size, kernel value, and also the weights, the parameter. So recently, with the support of National Science Foundation, I have really investigated side channel in DNN security. So most of the time, it has been utilized as a very powerful tool to breach the security of deep neural network. So we have this project that has 3 thrusts, SpyNet, which is basically the side channel attack to breach the confidentiality. So we use cache to get a structure and a hyperparameter, floating point, timing information to retrieve the parameters. But there's a limitation, and so far, our implementation, this prior work, only target software implementation, like on microcontroller, on CPU, but not really on hardware platforms. We also did some kind of a fault injection attack that's called the disrupt net, and that's really to compromise integrity. And for this type of attack, we target these FPGA accelerators or GPUs. And finally, like say, how do we protect confidentiality, integrity, and robustness of DNN model? That's the SafeNet. So with this prior work, there are still 2 questions we're asking. One remaining challenge is, like say, despite this prior work on software implementation, can side channel analysis can really break this state-of-the-art commercial DNN accelerator, which are hardware, and what kind of side channel would work? That's one question. So this is really utilizing side channel to break the security. But another question is, like say, is there any good side, flip side of side channel? How can we actually use it to further enhance the DNN system security? So we got some kind of answer to this question, and I'm going to present these 2 work. So the first work is the side channel assist reverse engineering of encrypted DNN hardware accelerator, which is a commercial IP. And based on the reverse engineering result, we also really launched several IP stealing attack, basically to discover the entire model. And this work is going to appear soon next year in the IEEE Symposium on Security and Privacy. So first, the FPGA DNN accelerator really has gained popularity over the past couple of years. It's a very good choice for inference on the edge or even in the cloud. Among them, AMD Xilinx Deep Learning Processor Unit, DPU, is the most popular one, which is a programmable engine for a convolutional neural network. It has very high efficiency. If we compare this AMD Xilinx DPU on FPGA versus the NVIDIA Titan GPU, you can see that for the same network, for the same technology node, they have similar performance, but the FPGA Xilinx DPU has much lower power consumption, much more efficient, energy efficient. And also it can achieve very high throughput and low latency because it's the model running on accelerator is quantized model. So the parameters are just a 1-byte integer instead of like a floating point. And also the development flow is very user-friendly. So accelerator is available as a soft IP core, just like CPU. And we have this entire ecosystem with compiler, with deployer to be compatible with this development tool like a PyTorch, TensorFlow. So basically the user can actually sort of like write a program and the DNN model will be automatically deployed on the DPU accelerator. Okay, that's the target. And then what's our tool? What's our hammer here? For power EM side channel, this is a very basics. So basic idea is that these physical parameters, power consumption or EM emanation, is actually dependent on what the system is executing the operations and what data they're operating on. So with this notion, then there are two different types of side channel EM or power analysis. I will use this interchangeably, either power or EM, they're similar. So the SEMA is basically one single trace, and on the time, it actually can leak this coarse-grained operation information. For example, like the typical RSA cipher algorithm, there are many key bits and therefore many iterations for the key bits. Every iteration, it either does squaring or squaring and multiplication, depending on the key bit. Okay, and you can see clearly that the EM or power profile for squaring operation and the multiplication operation are very different. So you can basically read the key bit directly from the power profile. That's the SEMA. And the correlation EM analysis basically is based on the data dependency. And it can therefore reach by observing the power or EM consumption, you can retrieve the secret data, and it can be the cipher key, or for DNN, it can be the weight. And you need many traces and using correlation across them. So this CEMA is based on some power model. I gave here, and the power model is like, say, for instantaneous power consumption for one power point. It has two parts. One is this, the latter part is a noise with just some standard deviation, Gaussian distribution. And it also has a deterministically part, epsilon and V. So epsilon is the unit power consumption, like every 1 bit switching, how much power. And V is a so-called very important synec function. And that's the one that associate the power EM with your data, with your operation. And the data here, for example, for our DNN typical MAC, multiplication and accumulation, I is the input, and W would be the unknown weight that the attacker tries to retrieve. And the F function can be either Hamming weight or Hamming distance. So with this power model, if we connect many power traces, okay, so we don't know the W, we have to guess. And only the correct W value would really give the highest correlation between the predicted V value and the measured power value. That's the CEMA. Okay, and here the weight is simple, it's just 1 byte, so the choice wouldn't be that many. And you can see on the right side, basically the correct weight W value would stand out to give the highest correlation among many power traces. Okay, so this is the basics. Then if we want to apply side channel attack, like an EM attack on DNA accelerator to get the parameters, to get the weights, what are the challenge? So on one hand, the victim DNA accelerator typically is it has this proprietary implementation. All the soft IP, they're actually encrypted. We don't see much details. But on the other hand, the side channel attack actually requires a pretty white box view of the victim, including what kind of operations are running on them, what's the hardware architecture, and what's the data flow, how this scheduling. So very precise timing so that we can build the aforementioned power model that has the select function and it is associated with the input and secret. Another challenge is that DNA accelerator, the reason for it to have the high efficiency is actually it has a lot of parallel design. So some operation and a lot of other operations. And this actually presents a challenge for our side channel, because for side channel, we need this reasonable so-called signal to noise ratio. The previous power model, the epsilon is this single bit switching as a signal, but we have this noise, which is this standard deviation. And then if you have a highly parallel design, there are many operations that actually contribute into the noise. So these are the challenge. And furthermore, before for cipher, for AES, for RSA, this crypto algorithm, people have used this select function as Hamming weight. So for Hamming weight, you just can like say what's the current data, which works. But unfortunately, this Hamming weight model doesn't work for DNN, because DNN, the typical operation is multiplication, and multiplication doesn't have this so-called high line linearity. So basically, the same weights, they will result in the same Hamming weight, and therefore you cannot differentiate which one is the correct one. So all in all, we have to go with the Hamming distance model. But for Hamming distance model, is if there's a register, it's really like say, what's the switching, what's the old value, what's the new value. So the switching happens. That means that we really have to figure out very detailed, precise scheduling. Like what are the operations really going cycle by cycle, and what will be the updating of the data so that we can have the Hamming distance. Anyway, so this work we present using EM side channel to help us reverse engineer this commercial DNA accelerator. It has two parts. One is the software scheduling, the data flow, how operations really being scheduled one by one, cycle by cycle. And meanwhile, also what's the hardware architecture, what's the hardware structure, what are the computation components, and how these DNA neurons and operators like MECs are mapped onto our hardware components. So based on this reverse engineering result, we can actually enable quite several attacks to fully recover DNA IP. This is the AMD Xilinx DPU. So on the right side is the development flow. So basically very much like a software. People write some model, like a DNA model, and then can automatically translate, kind of compiled to some binary file, and also some bitstream file, because this is FPGA and ARM processor SoC. So it has both the binary and the bitstream to configure FPGA. And the left side is the real deployment flow. So we have this CPU for the software part, and then we have the DPU, which is the pre-configured deep learning accelerator. And then we have a scheduler to really scheduling this kind of instruction by instruction, operation by operation onto this computation array. Okay, so we have this device under test is a Xilinx DPU running on this development board. And on the right side, you can see this is the board, and then we have this some EM probe with a preamplifier to pick up the EM signal. And this is a very high speed, high sampling rate oscilloscope to show the EM traces. And for reverse engineering the DPU, including the software scheduling and also hardware architecture, we employ three different analysis. One is a simple EM analysis, just one trace, try to figure out some information. And another one is a statistical test. And finally, we also analyze the schematic to get at the hardware. Okay, so first for the software scheduling, reverse engineering, we really try to figure out the data flow and the scheduling, and we have this divide and conquer, just like say for a model, how does it fit onto your hardware? Okay, so for a model, we know that because of data dependency, it actually, the accelerator has to work layer by layer because they have this sequential feeding order. So we have the second level as a layer, and then many times you have limited this computation and storage resource. So layers may be still too big to fit these resources. So layer has to be divided into segments. Okay, and finally, what exactly happens in a segment? Okay, how this data input and kernel are loaded and computed onto an individual segment. So we have this multi-level. Just give a simple example, like say, this is a two convolutional layer and one dense layer, and doing this digits recognition. And this is our power trace, and we can clearly see that convolutional layer probably for this part, then second convolutional layer, and then dense layer. Okay, and then you can also see this is our triggering signal using some bus signal as a trigger signal. And you can see that for one layer, it actually even divides into multiple segments because of the limitation of the computation and the storage resource. Okay, so with that, then we look into segment, say, what's the capacity of a segment due to the computation capacity. So we take some method, like say we basically vary a lot of parameters for the DNA workload. For example, like say change the input, the feature size, the weight. If it's an image, change the weight, change the height. This is convolutional neural net will also change the kernel size, the weight and height, and also vary a number of input channel, output channel, just figure out, like say, what happens in each segment, what's the computation capacity. And with that, this is just an experimental method. With that, we found, like say, the computation array, which is the major engine, can take 10 input channels and 10 output channels simultaneously. And each time, it actually takes 8 rows of input pixel. So I think the details doesn't matter much, but it's really the methodology, the method we employ. So this is just from just a single trace. We can recover the workload of each segment, but that's what we can get from the SEMA. It cannot help us recover more fine-grained information, like say, what's the channel concurrency, and also what's the processing order of this input and kernel. Okay, so with that, we employ the second tool, which is this t-test. So t-test is a statistical test that determines if 2 data sets have the same average value. And then this is basically the mean of one data set difference versus the standard deviation or variance, and also the number of traces. So we do this, we use this tool, and then we set 2 data sets. One is, like say, for example, the input image complete black, everyone is 0. And then the second data set has some specific non-zero inputs. Okay, so we run these 2 input image data sets and connect the 2 set of power trace, and then calculate the t-test for each time point across these 2 traces. So if the test shows some difference, okay, this is t value, then it means that, okay, for this non-zero input value, the system is actually processing that now, so that you can see the difference between non-zero and 0 input value. Okay, so basically from here, from this t-test, we can actually recover what's the processing order, how these inputs are fed into the computation array. How does this kernel parameters fed into the computation array? Okay, so again, the results doesn't matter. For example, like say for input, we find this column major. We actually take input pictures column by column, but for kernel order is row major. We take this kernel in like a row by row. Okay, so that's a second. So by now we use this SEMA and t-test to get fairly good idea about the scheduling. And then what are the architectures that support all this operation? So we look into this DPU hardware architecture schematic. AMD Xilinx actually allows the schematic view, but is encrypted. So we don't see the inside, and the name is also obfuscated, only the connection and the bit width, they are still showing. Okay, so with that, we can build a lot of library components and then basically kind of do some pattern matching and ascertain what's the functionality of this block according to the bit width, according to the connectivity. And with that, after that, we have some idea about the components architecture, and then we'll recover the workload and deduce the data path. Okay, so this is our result. For the DPU, we find like it has very regular architecture with a lot of MAC. So each of these green box is a MAC tile doing multiplication and accumulation. And then this gray tile is so-called only accumulation. And it has this regular row and column, but idea is that, okay, the reason is that it can support 10 input channels. Every channel will be for 1 column. And then 2 output channels take 1 row, and they are output in a pipelining fashion or like alternating fashion. Okay, so this is what we have recovered. We fully recovered the spatial structure, and then we look into the individual tile, like the accumulated tile, MAC tile, and say really what's the composition. Like say basically this is a MAC tile with 4 DSP. Okay, so eventually we can build a DPU simulator to really simulate for every single DSP in every single MAC, what's the input is taking, what's the weight kernel is taking. So it's a very detailed, precise scheduling. So with this, we can now pick some register in the ACT tile and build the power model for it. And from the power model, we can retrieve the weights. Okay, so this is our enabled parameter recovery attack. Okay, so we successfully, I just showed the result, we can successfully recover. For example, this is one weight, this is the correct weight, and other gray curves are wrong weight. Okay, so basically this is a distinguisher. The correct weight stands out. This is one weight, and then we get another weight. Okay, so just some idea. We can do this for each layer. For the first layer, we sort of peel the onion ring. We get the weight one by one, and then once the first layer is done, we can proceed to the second layer. Just taking the second layer as if it's a first layer. If we have known the first layer parameters and set the input. Okay, so conclusion is we reverse engineer a commercial AMD Zenix DPU, which is the state of art. And we also demonstrate the generality. We also even apply to another academic open source version accelerator. It also works. Basically, this is cause for caution, like say, okay, nothing can prevent us from reverse engineering, even encrypted, even without documentation, we can still get a lot of details. And furthermore, with the reverse engineering result, we can launch many attacks on the DNA accelerator to recover parameters and hyperparameters. Okay, so that's the first part. I only have 5 minutes for my second part, but I really just want to give an idea about the flip side, how to utilize side channel for security instead of for security breach. So this is a work called EM Shepherd, detecting adversary samples via side channel leakage. And this was published in this July ACCS and got the Order of Distinguished Paper Award. So adversarial attack, people are already very familiar. It's a cipher attack where some small and many times unrecognizable noise are added onto the input image so that it can fool a machine learning model to some incorrect result. For example, the stop sign with some noise can give like a yield speed limit sign. There are many adversary example detection methods, mostly software, but many of them require users' input to be known, like an image to be known, or the model's intermediate outputs, like all this intermediate feature map, the neural activation. So therefore, there's some privacy concern. You need an input, you need a lot of instrumentation to the model to get the internal details. So we're wondering, can side channel comes to play to the rescue, because side channel can capture all these detailed operations and data. Okay, so basically we don't need to instrument the model to get this neural activation or feature map. We can, everything should be included in the side channel EM tree or power trees. So therefore we propose using side channel information as the fingerprint of model execution. And we can distinguish the model's abnormal execution due to the adversary example and the normal behavior for correct classes. And this is a motivational example. Okay, so we find, like, say, okay, so there's a model, we did connect the EM traces and put into some kind of embedding. And we can see that for different classes, this is classifying 10 classes. We can see that for different classes, the embeddings are located each other for the same class. So basically, we can build classifier on top of EM traces, and then you can actually differentiate different classes. That's a motivational example. So the overview of EM Shepherd is like, say, we have a victim classifier, but it may be under the attack of adversary example. So we want to build some detector, and in the training phase, we only, because we don't know what would be the adversary example, so we only have data set of benign normal examples, like say everything is right. So we connect the EM trace. Okay, this is the regular execution of the model. Okay, cat is really a cat. And we connect the EM trace, and then we do some processing. And because the EM trace, we know that we can actually use the use them for classification. So we build a classifier on that. And then the classification result, we put that into some anomaly detector. Okay, so the training phase, we only have the normal data and the EM traces. And at the runtime, okay, there's a dog with noise, but the model misclassified that as cat. Okay, so we connect the EM trace, and then we go through this detector. Again, there's some processor, classifier, and anomaly detector, and we may give the different, say this is not a true cat. What you have is actually adversarial example. Then you should reject that because that's the misclassification. So that's our flow. And so we have the 3-step. So first, EM trace, we have seen that EM trace can be very long and with a lot of segments. Okay, so naturally, EM trace is already divided into segments due to the DPU computation capacity and the scheduling. So for each segment, we actually do some short time Fourier transform. So the idea is that basically it become an image. So instead of a time series trace, we convert that to an image like this. The X is the time and the Y is the frequency. So it has both time domain and frequency domain information. And also image is naturally more compatible with CNN. And also we can do some filtering. So the image, even the noise is lower compared to the original time series. So the second, okay, we already talked about, like, say, the EM trace we can use for classification. So for one trace, there are many segments. And then we build a classifier for each segment because we know the true class, okay? And then from classifier, it gets lodges. So basically, for one trace, if it has many segments, we build that many classifier. And the lodges output out among this 10 class, okay, everyone is 10, we connect the nodges and then we concatenate all the nodges from all the classifiers, and this will become representative EM, like from our EM trace. This will represent for the current true cat class. This is representation, and for the next, this shoe, this will be the true representation. So finally, we use this unsupervised auto distribution autoencoder. So the idea is that based on the true classes, this notches vector, we go through some autoencoder and then train them, and then basically it's kind of reconstruct the notches and the difference, the noise, the error between the output and the input notches should be very small if it's a true class. And at the runtime, if we get a adversarial example, we'll go through this process and then and then put it to this autoencoder for the adversarial example. Their notches, this error may be much higher than what we set as a threshold for our true class. So due to time limitation, I just can only give this rough idea, but all our work is not based on simulation. So this is experimental setup, is a real, the previous Xenix GPU here also as our target. And we connect EM trace and, training the EM Shepherd detector, and we run many different models. And the adversarial tag will also pick the most popular state-of-the-art attack, different types of adversarial attack. I'm going to skip the result, but just want to show you finally, just give you some flavor, like say, how to detect the adversarial example. So on this VAE loss, you can see that the Belay sample is a true cat class. They have very low, small error, but then the adversarial example, like the dog with noise, to be misclassified as cat, the EM trace, when we connect it and go through this detector, it can show much higher error. So when we set the threshold, we can actually easily detect for this side. That's the adversarial example. Okay, so finally for this, so it showcased that the side channel information contain a lot of semantic of the different class and can be used for detecting adversarial example. So the advantage is that this actually is as good as state-of-art software detection method, but yet it doesn't require any model input, it doesn't require intermediate feature map, only needs the side channel. But that's also the drawback. You can see that setting up the oscilloscope and connecting EM trace is a little bit cumbersome, it's a little bit expensive. The data storage and the processing takes some computation power. And also the entire EM Shepherd as a detector may not be running at the like keeping up with the model. It cannot be like real-time detection. So future detection, we feel like, say again, side channel contains so much information, and there are many things we can do with it. So we can further adapt it to defend other attacks like Trojan attacks, data poison, backdoor attacks, all on DNA model. Or we can also again flip to the full side. Okay, further use side channel can also even for strengthening some attack. Okay, that's all I want to share with people. Any question?
That's a wonderful talk, and I personally wanted to appreciate Dr. NSF because it's past midnight there in the United States, and she really took time to explain all these things. And also, on the separate note, that it is exactly at the interface of semiconductors and cybersecurity. As you see, the basic research and also the advanced applications and so on. So I really would like to thank you, Dr. Fay. I know it's past midnight for you, and thanks for your time and availability on behalf of this MEITY NSF Research Collaboration team, and also on my personal behalf. Thank you again. And now I will open it up for discussion and questions. Well, if no questions for her, then again, I would like to thank you, Dr. Fay. And in case if there are questions later on, and if you want to approach her by email and so forth, her information is available, and she is very willing to explain things that you need, sort of explanations or what kind of experiments going on, more details and so forth. And by the way, she is the recipient of NSF Career Award as well. So interacting with her may be beneficial in the area of taking semiconductors to the cybersecurity, et cetera, et cetera. With that, I'll just hand over to this lady to take over.
Thank you, everyone. Bye.
Thank you very much, ma'am. A round of appreciation, ladies and gentlemen.
Thank you.
Thank you very much, ma'am, for being here. Thank you. So here, let's proceed further with our next session. The topic is next generation communication, technologies, networks, and systems. In this session, we have 4 presentations, but before that, I request our moderator, Shri S.K. Marwa, GC/R&D in CC and BT, MEITY, please help me to welcome Mr. S.K. Marwa on dais. Mr. S.K. Marwa, presently Group Coordinator, Scientist G, Ministry of Electronics and Information Technology, is an Electronics and Communication Engineer and belongs to the batch 1989 batch of the Indian Engineering Service. In his working experience of over 32 years in the Government of India, Mr. S.K. Marwa has handled policy matters pertaining to the electronics and information technology industry, and has been closely involved in the formulation of several schemes and incentives of the facilitating the growth of the electronics and IT industry in the country, including national policies on electronics, PLI, and SPECS, as well as program for development of semiconductors and display manufacturing ecosystem in India. He is presently the group coordinator for R&D in communications, Converge and Broadband Technology at MEITY and CTO of the India Semiconductor Mission. He continues to support the electronics hardware and semiconductors group activities at MEITY. May I request you all, please help me to welcome Mr. S.K. Marwa, our moderator for this session, on board. So now we have, as I said earlier, we have our 4 presentations. Please help me to welcome for the first presentation, that is Vyas Sekhar sir, Carnegie Mellon University, US. Please help me to welcome Mr. Vyas Sekhar on stage. Unlocking the data-driven innovation in the next generation networking with synthetic data. The topic would be for him. Sir, I request Mr. S.K. Marwa sir to take over from here. Thank you, sir.
So, good morning, everyone. Can I invite on stage the 4 distinguished speakers? 3 distinguished speakers are there with us. So, Dr. Ravi Gandhi. Yeah, please come on stage. Mr. V.K. Roy, Department of Telecommunications. I think he's here to reach. He's on the way. Okay. And Professor Kiran Kuchi, please come on stage. So good morning, everyone, and welcome to the 4th session of the workshop on next generation communication technologies, networks, and systems. In this session, we are honored to have with us 4 very distinguished speakers. Professor Vyas Sekhar from Carnegie Mellon University, who will speak on a very interesting topic, unlocking data-driven innovation in next generation networking with synthetic data. He is the Tan Family Professor of Electrical and Computer Engineering in the ECE department at CMU. His work is broadly in the intersection of networks, systems, and security, and has been recognized with numerous awards. Professor Vyas Sekhar has joined us virtually. So, are we able to have him?
Hello.
Welcome, Professor.
Morning. Can you hear me? Can you see my slides?
Yes, we can see your slides. And
okay.
The floor is yours, Professor.
Okay. Thank you very much, sir. And thank you very much, everyone, for coming to my talk and giving me the opportunity to share some of our research. So I'm from Carnegie Mellon. This is joint work with my colleague, Julia Fanti, and our PhD students, Zinan and Yucheng. A lot of this work was funded through various National Science Foundation programs, including a recent NSF RINGS project, and before that, a Convergence Acceleration Award. So thank you to NSF for supporting this innovative work. So I'll start with like a personal story, right? So I started in graduate school long ago in 2003. I started working in computer networking and computer security. And I've had this problem where as a researcher, I have come up with a cool idea or a new algorithm or a new approach. And what happens there is that anytime I come up with a new approach, I need some data set or real world data in networking or cybersecurity to validate my research. But unfortunately, this data is proprietary with some companies. Some ISP, telecommunications, or other kinds of security engineers have this data, but they cannot give it to me. So this is a pain point for a lot of academics, and I'm sure a lot of academics in the room and the researchers in the room can sort of feel this pain that a lot of academic research today and industrial research today is not reproducible because the data sets that people have cannot be shared with other researchers or other companies. So this is a bad outcome for a lot of research. These research is not reproducible because the data is locked away. And a lot of collaborative opportunities between industry and academia, or between academia and academia, or even between industries goes untapped because data sets need to be locked away because of privacy or compliance reasons. And this turns out to be not just a problem for academics like me, but it turns out to be a problem in industry as well. We've actually had conversations with a lot of industry practitioners, and what they tell us is they have the same problem, where they are collecting a lot of data, but different teams in their organization, the data science team, or the test and response team, or the sales teams, cannot access the production data or the private data that is being collected due to privacy and compliance reasons. And this is a problem throughout the product lifecycle for a number of industry practitioners across the telecom industry. So they can't build innovative products, or even if they do it, they can't test it, or when the customer reports a problem, they cannot replicate it in their labs and so on. So this is a universal problem where as we have more and more of these like privacy and security policies and compliance policies and retention policies, the lack of access to data is hampering innovation. Our focus is specifically on data sets that pertain to a number of like telecom, networking, and next generation networking use cases. You can think of data logs that we collect in security, what kind of clicks or events users do. You can think of things like measurements of network quality, how many packets, what is the video player quality, different kinds of behavioral analytics, or other kinds of Internet of Things, which is taking off, data collecting sensor measurements and so on. So I call these as what I call them as like session journey data, where you're modeling the time evolution of different kinds of data sets. So each session or user or network flow has different kinds of attributes we want to measure, like for example, which location, what kind of device you had, what kind of show you were watching. And we have measurements of the quality, the number of bytes you sent, the temperature that you collected, and so on. So informally, we see this pattern of session journey data appearing in many, many domains, including many aspects of networking, security, network monitoring, fraud monitoring, fintech, cellular, and so on and so forth. It's very, very universal. And this kind of session journey data that a lot of practitioners collect is driving critical operations today across the board. So when we talk to practitioners in the networking and cyber industry, they say this kind of data is critical for us to understand our workload, do predictive modeling of the data to provision new resources, evaluate new kinds of algorithms or models or forecasting techniques that they develop, as well as use the data to improve the security and resilience of the networks. So the world is going data-driven. This is universal, very true for networking. And this kind of session analytics is increasingly critical. But the access to the data is hampering that life cycle and that innovation and that reproducibility. So we've been working for a while on this project, which I call Data Fuel. And the high-level idea here is, can we generate high-fidelity, privacy-preserving synthetic data, right? So it's not the same as the real data set that you had, but we're able to create sort of a carbon copy or a privacy-preserving clone or a copy of the data that we can share with your downstream AI, ML, security workflows, such that it's privacy-preserving. It captures the essence of the data that you originally had, and it is sort of flexible to support all these different downstream tasks for machine learning, predictive analytics, structural characterization, and so on. Okay, so this is a high-level vision that we've been working towards. This is not a new problem. This is a very old problem that everybody in the telecom industry and everybody in the cybersecurity industry has faced for a very long time. Indeed, the idea of like synthetic data is not new. So if you sort of look around the room and talk to any practitioner, I know there's people from CDAC, there's people from the Ministry of Telecom. Everybody has at some point tried to write their own network traffic simulator or different kind of traffic generator or workload generator. The problem with this classical approaches for synthetic data is they require a significant amount of human expertise, right? Some domain expert has to have a deep understanding of the characteristics of the data, the statistical properties, then go develop custom simulators, custom mathematical models before they can solve this problem. Now, the sort of the holy grail, the ideal world will be one universal framework that can generate this kind of synthetic data with little to no human expertise, right? And this has been sort of the elusive goal for a lot of us in the networking world, in the cyber world, as well as other worlds in like in fintech, in healthcare, and so on. Now, why am I here today? The why I'm here today is to actually talk about a new way of thinking about this problem using the promise of what is called deep generative models. So you probably heard of like deep learning, deep fakes, and all this other sort of technology where we know that large neural network models or deep models are able to capture these kinds of high dimensional complex relationships and data sets and produce new data sets. Now, the most visible example has been in the case of like images, right? I can give a deep neural net a data set of faces, and now it produces new kinds of celebrity faces you've not seen before. And again, you've heard of things like deep fakes, you've heard of things like DALI, all these other techniques at their core are deep generative models that are able to capture the essence of what a face is, right? Nobody told this model a face has two eyes, a nose, some hair, some ears, and where they should be, but it has somehow magically learned these structural relationships automatically. And the beauty of these deep generative models is that they're able to learn these structural characteristics automatically from the data with little to no human expertise. And that's really what got us excited, right? So I'm actually a practitioner from the networking security side of the world. So what got me excited was this development around, I would say 2014, 2015, this idea of deep generative models, their ability to capture these sort of structural characteristics of the data set. And we are able to now produce hyper-realistic data sets, hyper-realistic images across various domains. And that's how we got started into this. And we took a particular approach called GANs, or generative adversarial networks. Now, the word adversarial here refers to not so much a security adversary in the way that the previous talk mentioned, but really it's an adversarial in the way the training itself works. So a GAN has two components, a generator component and a discriminator component. And you can think of these two as adversaries fighting each other. The generator produces an image, and the discriminator's job is to say, hey, this is real or this is fake. And by iterating between the generator and discriminator, the GAN model is able to converge to a very, very good replica or a statistical capture of the original data set. So now this is very, very popularly used in the image world, in the text world. You probably use things like ChatGPT. They're all part of this technique. But the key challenge is, how do we take this and apply it to data sets that arise in a networking or a cyber context, which is the focus of our work. So I'll briefly talk about two pieces of research here, both funded under different National Science Foundation grants. A piece of work called Doppelganger and a work called NetShare that takes Doppelganger and applies it to like the kinds of network logs that we see in telecom networks. Okay, so Doppelganger is a basic building block for time series generation. So time series data or the session data appears in many, many domains. And what we saw that directly taking some of the algorithms that worked in the image world and applying them to networking or system-based data sets do not work very well. So we actually developed one of the first models that works and applies GANs to time series data generation. So here's an example of the kinds of properties you might care about in the context of time series. So say, imagine you're a next generation network operator and you're trying to model, say, page views or the total traffic coming to your site, and there are natural diurnal or periodic patterns in the data set. So the graph here shows a real trace, and looking at the autocorrelation, which is a signal measurement that will peak whenever there is periodicity in the original data set. Okay, so here is a data set from Wikipedia, and we see this autocorrelation in the real data set is like this orange line has this nice pattern, but off-the-shelf machine learning techniques are unable to capture those kinds of techniques. Okay, so you have a weekly peak every 7 days, you have an annual peak. But if you take off-the-shelf machine learning, it's not able to capture these kinds of subtle structural patterns in the data set. And there are many other such phenomena that off-the-shelf machine learning was unable to capture. So we came up with this new architecture called Doppelganger, which introduced a few fundamental innovations in how we should generate time series data. So this figure on here on the slide shows the architecture of Doppelganger. The first key idea was to decouple what we call metadata from the measurements. So think of metadata are things like user attributes or packet header data, and the measurements are the time series of measurements and sensor updates I'm getting. And we observed that these two are very different types of structures, and it makes sense to decouple them. The second part is we realized that these off-the-shelf techniques could not capture long-term correlations or did not deal well with high variability in the data. So we had to introduce some other architectural innovations, like the notion of batching in RNNs, the use of auxiliary discriminators to capture some of these things. Again, I won't bore you with the details of this. You can sort of maybe refer you to the paper. But these were some of the foundational innovations that led to the practical approach of showing the feasibility for deep generative models for time series for the first time. And Doppelganger, the approach has been widely used in industry across many other industry sectors. A number of startups in the fintech world have taken it on. A number of these new data-driven AI startups like Gretel and YData have also adopted Doppelganger as one of the core techniques for using it in their data generation workflows. So we open sourced it, which is actually one of the nice things we do as part of NSF grants is we actually open source a lot of the code algorithms and models that other people in industry and other academics can reproduce and build on them. Now, with Doppelganger, we showed that we can actually get much improved fidelity for a number of canonical metrics that we care about when measuring the structure of data sets. We also looked at other kinds of structural properties like correlation between attributes, the correlations between the metadata and the measurements, the temporal properties, again, all sorts of various statistical properties you can think about. We showed that Doppelganger can accurately mimic the structure of the real data, right? So if you're a practitioner and you want to share time series data with your colleague or a collaborator or a vendor, you can now have confidence that it actually accurately mimics the structure of your original data set. Now, this is Doppelganger. So this was like a building block specifically applied to different kinds of time series data. But in practice, if you think about telecom data sets, they are more than just time series. They also have these things like IP addresses. They have things like web addresses, URLs, packet traces, flow traces, and so on. So the next step we took was, okay, here are the practical traces that appear in networks. And you can replace IP headers and traces with cellular network traces or other kinds of network traces you might find, and the same problems arise. So we took Doppelganger as a building block and said, how do we now take this idea and show it for practical settings in the telecom world, where we have things like packet headers, traces, and flow traces, and so on. So we developed some new advances to network trace generation in this paper called NetShare, which appeared at the ACM SIGCOMM conference last year, where we used new formulations to formulate packet trace generation as a time series problem, developed some custom encodings to make learning scalable, custom ideas to using ideas like fine-tuning to improve the scalability of the learning, as well as improving the privacy trade-offs between privacy and fidelity by using some public data sets. So privacy is an open problem in this space, but we actually had a practical way of balancing both privacy and fidelity by using a little amount of like public data in this case. Now, here's an end-to-end flow of like what NetShare looked like, where we take an existing data set, we kind of chunk it into smaller data sets to make the machine learning tractable. We use a time series GAN, in this case, Doppelganger as a basic building block, and then we reconstruct the trace after the fact. So, and the nice thing about this architecture, it allows you to do both privacy preserving learning, as well as scale up the learning by running a lot of the training in parallel across a cluster of machines. Again, machine learning takes a lot of time, takes GPUs, takes a lot of clusters. So this architecture is also amenable to those kinds of like parallelization optimizations. So we've evaluated NetShare on a number of statistical properties. Again, looking at new ways of measuring the fidelity of data, and it achieves significantly better performance in the number of baselines. And beyond statistic, one thing that we've heard from a lot of practitioners, both in research and in industry, is they often not just care about statistical properties, but they have some kind of downstream algorithms or tasks they care about in machine learning for detecting anomalies or detecting applications. And they ask us, hey, how well does the synthetic data do on those downstream tasks? So to that end, we've actually shown that using the synthetic data from something like Netshare is able to preserve these downstream tasks as well. We've done this for traffic prediction, for fingerprinting, for forecasting, and a number of other things. Now, beyond these two basic building blocks, there's again a number of other efforts ongoing as part of this vision of making synthetic data a reality for next generation networks. One of the common concerns we see is that synthetic data is not just for the common case, but also for anomalous or rare samples. So we've developed new techniques to generate rare samples. Imagine there is an attack, or there is an anomaly, or some new kind of outage that happens. How do we generate some of the rare samples automatically? Privacy is a big concern, right? Especially when you're doing things like data sharing. There are these new regulations with GDPR. I'm sure every other country has similar kinds of legislations. How do we balance privacy versus fidelity in synthetic data generation? And there's also some foundational advances in making the core machine learning models better as well. This is a lot of cool work to be done in this space. We are just scratching the surface. And there's a lot of interesting open challenges and opportunities for both collaborations with academics in other areas, as well as industry academia collaboration. For example, trying out other kinds of data sets, protocols, other kinds of deployments that you have. We've only scratched the surface in the kinds of downstream applications that people care about. There are other things in IoT like predictive maintenance, anomaly detection, network testing, network fuzzing. There is also other value of synthetic data. For example, how do you build better machine learning models in training detection systems? How do you replay to reproduce problems you've seen in the wild? As well as sort of thinking about what are new kinds of privacy protection mechanisms in the context of network traces and network sharing. Again, it's a very rich space, very active opportunities for research, both collaborations within and outside of academia, and very interesting problem space to go after. So let me sort of conclude here and sort of open the floor for questions. Again, thanks again for giving me the opportunity to present some of this early stage research and some of the results. Again, I would like to sort of say that this is actually a 20-year-old journey for me. From the beginning, I started in grad school. The lack of data sets was a big problem. It continues to be a problem. And now we finally have an opportunity to tackle this fundamental pain point by leveraging this opportunity of deep generative models. So we can now, for the first time, generate synthetic data via deep generative models to unshackle or unlock these collaborative opportunities that have gone untapped so far. So our project, the umbrella project is called Data Fuel, is one of the first practical applications of deep generative models for networking and security and systems use cases, looking at the kinds of data sets that are relevant to industry and academia. And we've shown some of these early results that it's robust across a number of different data sets, domains, and downstream tasks. And as I said, a very rich problem space. There's a lot of ongoing work that we are doing. Other researchers are doing, building off of our open source ideas as well, in making them more scalable, more richer use cases, better models, and so on. And would love the opportunity to collaborate, learn more about your use cases or applications. And again, there's links to the project and the open source repository. And feel free to reach out to me if you have any questions, concerns, or any other opportunities for collaboration. Thank you again for giving me the opportunity, and I'm happy to take questions.
Sir Vikas Sekhar, that was a very interesting talk. So now the floor is open for a few questions and answers. Yes, please.
Thank you, Vyas. Thank you for the nice presentation. Now I have two questions regarding number one, how you check the validity of the data set that you generated through simulations or any other mathematical model. And second question, let's suppose you have very small number of observations. Let's suppose in mechanical testing of non-destructive testing. So we cannot generate large amount of data. We have only 20 or more than, let's suppose 30 data points. So how do we can generate the data and we can use for machine learning models?
Great questions, by the way. And these are all questions that we have tackled, we have wrestled with for a very long time. Let me start with the first question. So how do we check the validity of the generated data? So again, there is no one short answer. I think you have to use a combination of statistical properties. So we've developed a number of like statistical metrics, looking at correlations, distributional measures, time series measures, different kinds of statistical properties, as well as a library of downstream tasks, right? Say I'm building new prediction algorithms, machine learning algorithms. You can plug that in to validate the fidelity. So there is no one magical KPI or performance index that you can say. It depends a lot on the domain, but we can give you a library of metrics or other kinds of queries you can write to check the validity. Now to your second point, that's a great question. Again, this is deep learning models do need a significant amount of data before they produce some useful results. If you only have 20 samples, you probably cannot run a deep learning model on it. But what you can do is potentially that if those are the rare samples, then you might be able to use things like the rare GAN to amplify them along with the public data set. So one of the things we can do is mix and combine data sets from multiple observation points or multiple people to create a larger corpus and mix both private and public data. But if you only had 20 data sets globally, you probably cannot use a deep learning model because it will just memorize those 20 samples and it will not produce anything new or interesting at that point. So, and one of the things we are looking at right now is imagine you want to combine data sets from multiple vantage points and multiple people to amplify the benefits, right? Imagine there is a collaborative initiative where a number of participants come together to share data sets. So that might help address some of the concerns with data sparsity you mentioned.
Okay, I'll request the participants to please introduce yourself before asking the question.
Good morning, sir. It was a very interesting and insightful talk. Myself, Dr. Muralidhar from CDAC, Bangalore. We are working the network traffic classification and anomaly detection area. In the current challenge, what we are facing is that you are exactly pointed out getting the real data set. In the traffic classification area, most of the network traffics are encrypted now. So how we can generate the specific application traffic? For example, same application may be using multiple protocol in the current scenario, and generating those type of real application traffic, how effective in this current synthetic traffic it will be useful. And second question is the anomaly detection area. The applications are very intelligent nowadays. They are understanding the real network first, then they are behaving differently. So how we can generate this type of specific application traffic for anomaly detection?
Great questions, Dr. Muralidhar. I think these are all great questions to think about. To the first question about like encrypted traffic. Now, one of the nice things we do is actually we don't look at the payloads. So we are mostly generating data traces at the header level. So if there are, for example, the sequence of bytes, the sequence of packets, the packet lengths have a particular structure in the encrypted data for different applications, we have shown that our synthetic data can capture that. Now, that said, for the specific applications you're thinking about, we need to try it out. And again, we're happy to help you try it out and see whether it satisfies the properties you care about. Now, to the second question you said about anomaly detection, how applications are like the client applications are getting more smarter. That's again a great point, which is why we envision the way people are going to use synthetic data or machine learning is not going to be just one time, but it has to be a continuous process, right? Because the applications are changing, the workload is changing. Like every day or every hour, you will keep running these synthetic data algorithms, check how well your anomaly detection is doing, and then you look at maybe amplifying some of the rare cases where your detection algorithm is failing to see how maybe an application is evading it to build a more robust model. And in fact, we have seen a bunch of cases where we are able to improve the detection classifier by generating more rare samples or generating some of the samples that is not seen before. So that also might be an interesting synergy with the use case you mentioned. But great questions. Again, these are all the kinds of like downstream tasks that we know that people are doing on top of ML and synthetic data.
Any more questions? Yes,
Hello.
please.
Sir, Dr. Umesh Gupta this side from Banat University. Sir, my question is, as we already know that GAN is used like deep learning network, as you already told that. So, sir, is machine learning is obsolete for the further applications? Because right now we are dealing with lot many data. So, like, what are the classical algorithms in the machine learning for support vector machines or decision tree or random forest? So, like, is there the obsolete for GAN models? Can you elaborate?
Okay, good question, Dr. Umesh Gupta. So I would say again, so there are two kinds of machine learning models, right? So the kinds of things you mentioned, like SVM, decision tree, those are more like classical regression or classification type algorithms. Those don't work for generative models because generative models typically need to capture much higher dimensional structure. It's like saying you cannot build a GPT or a chat GPT with just an SVM or a decision tree. It needs to capture things like sequences and histories and so on. So that's where you need richer models. Again, GANs being one of them. There are other emerging models like transformers, diffusion models that are also being used, and we are exploring them as well. Now, to your question, is classical ML dead or not useful? Now, I would suggest that maybe for specifically for generative models, I don't see I don't see the value of those kinds of models yet. But the downstream tasks that we do, for example, like traffic anomaly detection or traffic classification, those still use fairly good, smaller, compact models or more explainable algorithms like SVM and decision tree. So I still see a place for them in the overall workflow, that the downstream task, what anomaly detection, those things you do will still have to use some explainable AI, because you would probably not run an operations with just a black box ML. That is something a human operator needs to understand and explain. So when it comes to explainable AI and use it in an end-to-end workflow, those kinds of classical algorithms will still be there. But on the generation side, it seems that the deep models have a significant advantage over those classical models.
Thank you.
We'll take one more last question, please.
Thank you, sir. So thank you for taking this question or this topic as such. Being from an AI community, I know everybody's sweet pain point is this only. So we are working on a digital twin ecosystem wherein not only single LLM, the cluster of LLM is expected to deliver the things, and the data on to get those trained is like the crucial point. The point I would like to understand or want to highlight, which is partially you discussed already, is like how we can justify or clarify the biasness when it comes to generation of data, right? If I'm going for behavior analysis of prediction for driving pattern, say for example, so driving pattern generated for US and driving pattern generated for India would have completely different aspect. And the target that we are looking for is a one-click solution to generate data, right? A framework or solution. So, what is your take on that?
Great question, sir. I think this ML has not a one-click solution. ML is often like an iterative, refined process. So one of the things we've done a lot is actually that we find that you may have to do things like conditional generation, that the patterns in India and the patterns in US are different. So you might actually have an ensemble of models for different kinds, or like conditional generation for those different kinds of like settings. So you may actually have to create some kind of like a mixture model or a conditional model for different settings. I think it might be hard to have like one universal model that does all of them. And to your question about bias and sort of training bias and so on, this is exactly where synthetic data can help a lot, is that we can use the synthetic data to simulate new kinds of scenarios I've not seen before. So one of the things, for example, to use an image example, suppose you only seen people wearing dark brown glasses or black glasses, but suddenly you want to have people who also detect people who are wearing like purple or orange glasses, right? Now you can use synthetic data to generate those kinds of scenarios and see whether your face recognition or glass detection algorithm still works by using synthetic data. So synthetic data can actually be used to generate new scenarios or conditions while still being realistic to stress test some of the algorithms that you're developing downstream. Now, to your first question, will there be like a single one-click generative model that will capture everything? Again, that's a great effort to work towards. I think we're all working towards that. So we are not there yet. My suspicion is that it will still require some data scientists, some data engineering to work together with the tools that we are developing to customize it for your particular use case with some domain understanding. And that's the current state of the art on how these are used in practice.
Thank you.
Thank you, Professor, for answering those probing questions and a very interesting talk. So thank you so much. So we will move on to our next speaker, Dr. Ravi Gandhi, President and Chief Public Policy and Regulatory Officer, Reliance Jio, who will speak on the topic of next generation communication technologies and 6G. Dr. Gandhi is an expert in public policy and regulatory affairs. His career spans over 3 decades with diverse experience in the telecommunications industry. Before joining the private sector, he has been part of the Indian Telecommunications Service and has served the Department of Telecommunications, Government of India in various roles. Welcome, Dr. Gandhi.
Thank you, sir. Can you put my presentation, please? Sir. Thank you. Thank you to my co-panelists here. So I would, instead of talking hardcore technology and research, probably I would be talking on the deployment of technology more and in which direction the new technologies in communication sector are going and where we see us in next 10 years or 15 years. So before I go to the next generation technologies, where we are, where India is, and what is contribution of my company, which is Reliance Jio, into that. So Reliance Jio launched its services in 2016, the complete greenfield 4G project. And before Reliance launched the services, India had around 174 million broadband connection, and today we have 833 million broadband connection. Out of that, 443 million connections are provided by Jio. On the wireline side, if you see, we have totally 36 million wireline connection, and 10 million are with Jio. So almost 70% of the broadband connections growth in last 7 years has been done by Jio. What other things which has changed is the data prices used to be around 250 to 300 per GB, which has now come down below 10 rupees, around 8 rupees. The average usage per subscriber used to be around 250 MB per month, and which is industry average is now 17.36 GB the last quarters, and Jio's data subscriber use is around 26.6 GB per subscriber. Voice minutes have increased from 366 to 946. Jio's is more than 1000. Digital penetration, which we say the wireless or plus wireline broadband connection, which as I said, 833 million, out of that 443 million are Jio. At Jio, we have 99% population coverage with over 6 lakh villages which have been covered. 97% of the rail route has been covered, 96% of the state highways have been covered, 94% of the national highways have been covered. We have installed more than 4.4 million radios for 4G and over 1 million radios for 5G in last 1 year since the time it was launched, and over 400,000 Wi-Fi access points which have been commissioned in our network. So overall, as a snapshot, if you see where we stand, we have approximately 1 million kilometer of optical fiber which has been released, over 1 million 5G cells, as I said earlier, 4.4 million 4G cells, 443 million customers, generating over 11 exabyte monthly data, 15 billion voice minutes per day, over 26 GB of data per month, 1000 minutes, greater than 6 hours of usage. Jio alone has installed over 85% of the 5G cells which have been installed in the country in last 1 year. And we have covered more than 8,000 towns. This is a completely standalone network, 5G standalone network. So how the 5G transition has happened in last couple of years. So it started with the successful spectrum auction in which 700 megahertz, 3.5 megahertz, 26 gigahertz, which is also called millimeter wave, was auctioned, and 51236 megahertz total spectrum was allocated to various operators. Honorable Prime Minister launched the services on 1st of October 2022 during the IMC, and then the rest is the history. Country has achieved the fastest rollout across anywhere in the world. Jio has put its own indigenous 5G stack, so end-to-end its own technology. The complete stack is developed by Jio engineers, our R&D teams. The quality of service, India used to be around 119 rank, international rank on broadband index. In last 1 year, we have moved from 119 to 47, an improvement by 72%, 72 rank. And India has now put 100 5G use case lab, which was announced by Honorable Prime Minister during the IMC this year. How this transition is happening? So what we have done is, all radios are software defined, whether it is small cell or G-Node B, including MIMO. It's a future ready network. Product portfolio is completely aligned with 3GPP standards. Proprietary Geo OSS BSS, as I said, more than 100 type of radios node that are integrated with our core network. Cloud native network handling 100% of the 5G traffic. AI ML driven complete network monitoring performance is all automated using AI and ML tools. And the complete network is Open RAN compliant. What other things are happening? So when we discuss about terrestrial 4G, 5G, immediately in our mind comes is the satellite communication also. So there are 3 kinds of satellite constellations. So geostationary orbit satellites, which is known to us. These are the satellites which are at around 36,000 kilometers from the Earth, which appears to be stationary from the Earth because they are moving at the same revolution speed as of Earth. And typical latency is around 500 milliseconds with those, and major operators being SCS, Intelsat, etc. Then is the medium Earth orbit, which are the satellites which are placed at 8,000 kilometers from the Earth, and latency is typically around 150 milliseconds. Lifespan typically is 10 to 15 years of the satellite, and major operator is O3B. Geo has tied up with O3B, and we have all the rights of O3B in India. So we call it Geo Satellite Communication Services. We have already demonstrated these services, MEO-based services during the IMC this year, which happened last month. Then are the low Earth orbit satellites, which are typically 400 to 2000 kilometers at the height. Latency is around 35 milliseconds. And major operator would be SpaceX, Telesat, OneWeb, Amazon, etc. So this is how this whole space is going to span out in the next generation of, I would say, telecom technologies. So what are the benefits of the satellite technology? It provides you, or what are the requirements basically? You require high capacity, low latency, low cost. That's very important because the GSO satellites were extremely costly. Of the bandwidth on the GSO was extremely costly. Typically, you need to pay around 5 lakh rupees to get 1 Mbps of connection, which from an affordability point of view was very costly, but these newer technologies would, I'm sure, will bring down the cost substantially. Efficient, flexible use of spectrum, these new technology supports that. Reliable services, which would help in getting the ubiquitous coverage across land, air, sea, etc. Backhaul to terrestrial, so it's back all the terrestrial networks which have to be installed in the remotest corner, in the forest areas, and the areas which are inhabited, mountainous areas, etc., where you can't lay fiber or it's extremely costly to connect it with microwave, etc. There you can use it as backhaul. Ultra high definition multimedia content distribution. Today it's difficult because the DTH operators or the DTH network does not have that kind of capacity. Disaster management and other strategic services. So on the architecture side, if you see, we used to have typically the high throughput GSO satellite. Then we have to have higher power broadcast satellite to provide UHD kind of a services. Flexible architecture is another thing which would actually help in users to utilize their own mobile same device, because it's in a telecom network, it is not only the network provider who installs and provides the services. The user also need to contribute into it by the way of having the right device or right customer premise equipment so that you can communicate with the network. So from that perspective, it is very, very crucial that when we plan the network architecture, you have to keep the user devices in mind. LEO-MEO based satellite constellation, as I spoke. So how do we see the future networks look like? There would be typically a user in the diagram, if you see, who communicates with the radio BTS, which is installed on ground, which we typically call terrestrial network, 3G, 4G, 5G, whatever, and a satellite wireless. So the user is talking to both the networks parallelly, simultaneously, and picks up the best network which is available. So one would say that how that is possible or how that would happen, because the standards itself has started converging this kind of network architecture. So here if you see release 17 of 3GPP, it has already incorporated the satellite-based access, whether it is satellite component in 5G architecture or unmanned aerial systems, IoT, etc. So how this would help is that you have a common network which has common standards, and only the delivery mechanism is changing, whether it is via terrestrial radio or via satellite radio. So user moving from one place to the other place would not even know that when he is transiting between the small cell to macro cell to satellite cell, and we have a unified network, and that would help in achieving the objectives of even the 6G, which I'll show in the subsequent slides. So how the transition is happening from, say, 4G to 6G, which also is called IMT 2030. I will not completely speak about 6G because I think Mr. Vikara is going to speak on that. So on the diagram on the left, if you see, the middle graph shows the 4G and the outer circle shows 5G. So on all dimensions, whether it is mobility, which has moved from 300 approximately to 500 km per hour, or latency has moved from 10 millisecond to 1 millisecond, spectrum efficiency from 1 to 3x, or user experience in terms of 10 Mbps to 100 Mbps, peak data rate, etc. So this is how 4G has moved towards 5G. And when we move towards 6G, there has to be an improvement on all these parameters, but there are, in addition to those parameters, there are additional things which would encompass 6G as standards, which includes coverage, ubiquitous coverage. I think that's a contribution from Government of India to include as part of standards, that the ubiquitous coverage should be part of 6G standards. And the moment we say ubiquitous coverage, obviously the satellite becomes the part and parcel of the network architecture. Sensing related capabilities, which would be the new, which would be coming in 6G. AI related capabilities, of course, these are a part of 5G, but will get enhanced in 6G. Sustainability is another element which has been added. So power consumption especially is very, very high in telecom networks. So sustainability has been kept at the core of 6G standards and 6G development. And we would see that a lot of initiatives around green power, etc., would be going into a renewable power, reduced power going into 6G equipment. And many other things. In this slide, I would like to show the earlier in up to 5G, we used to call EMBB, Enhanced Mobile Broadband, which would be now immersive communication. Mobile massive machine-to-machine communication, MMTC, will become massive communication. URLLC, which is ultra reliable low latency communication, will become HRLLC, which is hyper reliable and low latency communication. The other elements, as I spoke, which would get into it is ubiquitous connectivity, of course, integrated AI and communication, integrated sensing. So a lot of work is happening on integrated sensing in this direction. Use cases for 6G would be, a large part of it would be same as 5G, because 5G use cases have yet to pick up, while a lot of discussion has happened in past many years. But and the network have been installed, but the use cases are still to pick up. And of course, the major use cases would be around remote healthcare, autonomous vehicle, which all you guys need to start developing and working on that. Smart environment, smart infrastructure, space connectivity, which I spoke, unmanned aerial vehicles, which is drones, etc. Holographic transportation is a new thing which has been added into 6G, which was not part of a use case in 5G. Industrial automation, of course, has been lot has been talked about it, Industry 4.0, etc. But industry has to now start adopting 5G and then, of course, 6G. IRS empowered sensors, etc. So what telcos or the communication industry does is to build the highways, to build the network, to build the roads, etc., communication roads. But the users have to now start using it. They have to build use cases around it and start using, so as the overall economic benefit to the industry and the social sector are seen by the people. What are the key enablers for 5G, 6G, both for terrestrial and SATCOM? Obviously, all the policies need to be investment friendly. Continuous investment is required in this. As Geo itself, we have done investment of more than 5 lakh crore in the network. Probably 6G would need a similar kind of investment. There, the monetization, etc., are obviously the challenge and will remain challenge in India. Spectrum, adequate and timely allocation. So adequate, of course, we have seen from 4G to 5G, while spectral density, spectral efficiency increases by 3 times, but the requirement increases by 10 times. So obviously then you require more spectrum. The same would happen in 6G. So while you achieve the efficiency by 2-3 times, but requirement goes 10 to 20 times. So that also requires more spectrum. So that's how this may not be spectrum requirement is not linear to the bandwidth requirement, but it cannot be zero. It is substantial. Right away, the government need to change policies, even if it requires constitutional amendment, to ensure that the network which is to be installed, every agency, every local body, every state government, all other bodies are aligned and provide the enabling infrastructure so that the networks can be rolled out in a fast manner, because technology is changing very, very fast. So we cannot have a situation where by the time you roll out the network, it becomes obsolete. Indigenous 5G, 6G stack. In 5G, Geo has indigenous stack. We assume that by the time we reach to 6G, all companies will have 6G stack end to end, and we should be seen as a major supplier of the 6G technology from India. Make in India, achieving self-reliant 5G, 6G technology ecosystem, it is extremely important from the security point of view also. And of course, the driving adoption, as I spoke, handset, CP, even if these need to be subsidized, but unless we have the CPs and handsets which are capable of these technologies, the adoption will not happen. So these are few recommendations which I think would be government need to consider and work. Everyone in the industry need to work towards that for adoption of 6G ahead of the other countries. In 5G, we were, I think, lagging by 2-3 years, but in 6G, we should not miss that bus. Thank you very much, sir.
Thank you, Dr. Gandhi. We can take a few questions. Okay, you can have a few questions.
Yeah, hello. So I'm Dr. Das from Ministry of Electronics and IT. I'm scientist in R&D Electronics Group. I was wondering if Geo has any interest in 6G or 5G platforms for on-chip photonics, specifically for data processing or including functionality for transceivers.
I may not have the answer of this. Why? I'll get back to you.
Okay, thank you.
Hello. Sir, you have been mentioning that for 5G use cases has not been developed in the way it should have been. So any specific reason around the 5G use cases not been well developed, and any specific 5G use cases that you're looking out for where development is currently? We are aware of the lab that Geo has for the 5G development, but what is the reason that it has not evolved in the manner that it should have been?
So I said 5G use case has not picked up yet. Maybe developed in lab and developed at the factory level, but these actually need to go on ground and adopted by the users. For example, remote health. If the remote health is to be adopted, there has to be infrastructure at the places where the hospitals need to adopt it, the dispensaries need to adopt it. There has to be the whole lot of awareness around it, that how it can be used. So that's where probably I think communities and government role starts in, and telcos role ends, because once we have installed the network, probably telcos are not expected to get into all the use cases, is what I said. So like Industry 4.0, the industry has to actually modify, amend or replace the machinery which is compatible and which can be remotely controlled, or use 5G as technology for automation, etc. So unless industry does that, only telcos cannot do it, is what I want to say.
Sir, my name is Radesh. I am from CMET. There was a mention in your talk that most of the 5G infrastructure is created by your own scientists. I just want to know that what kind of systems are being installed. Is it massive MIMO antennas? That's one question. And which frequency you are operating? It's sub 6 gigahertz or millimeter wave, 26 gigahertz?
It is massive MIMO. And we have developed 32 by 32, 4 by 4, etc. Many variants of it, small cell 2, G0B. And these have been developed on 700 megahertz, 3.3 gigahertz, which is the anchor band for 5G, 3.3 to 3.7 C band. And we are also working on millimeter wave.
How about the materials? Are you importing the materials for massive MIMO for fabricating the antennas?
These are being manufactured in India. a large part of it. Of course, we are importing the completely built unit also from the leading manufacturer. It's not that completely it is, radio part is a mix of the import as well as domestic. Core is completely ours.
Thank you.
So one question is like, whatever R&D Geo is doing, is it completely indigenous, and is it being done in association with some academia and any other R&D institutions? Like clearly asking like any kind of possibilities or the way which Geo is doing with academic institutions kind of R&Ds.
We at present, I think most of the R&D is in-house by Geo, but we work with academia, with many, I think, academic institutions. Like we have set up few labs. We work with them, but to say that it's completely and everything is being done by academia, the answer would be no. But I think we have started working with them.
Okay, thank you, Dr. Gandhi.
Yeah,
for
one other question.
Okay, one last question.
Yeah, sorry. Yeah. So you mentioned that in 5G there is a substantial increase in spectrum efficiency, and the latency also goes from 10 milliseconds to 1 millisecond. Have you done some measurements on your own network to see whether you are close to achieving those targets, or how far you are? What are the numbers like at this point?
So I think when I presented, those were the standards, basically moving from 10 milliseconds.
Yeah, those are the standards. But I'm saying that many people have observed that the real world deployments have not achieved anywhere near those desired objectives. So that's why I wondered whether you have done any study of your network, now that it's a very large network.
So when you compare between 4G and 5G, there has been substantial improvement in latency, but are we around 1 millisecond? The answer would be no, because that would, once you install your LLC on millimeter wave, etc., then probably will reach near to that. At present, the network which has been installed on C-band, C-band will not take you there. And secondly, the network, the way it is installed, how many hops of backhaul you have, etc., etc. So basically, the standards are for the technology, but when you actually install the network, you may not actually reach to those standards.
Thanks, thanks. I got your point. One follow-up question. You pointed about the use case issue, because of course that is very important even from your revenue perspective, that unless you have new interesting use cases, the ability to generate revenue from the huge investment you have made in 5G is not there. So I was wondering, I understand, of course, it's not your responsibility, but it may be helpful if industry, like you yourself, the academia and target audiences, like you said, healthcare. So maybe we at least do a pilot project with the Ministry of Health to demonstrate the use of 5G. MEITY can support it, hopefully, but even here R&D activity that we are trying to do here could be around these things like this, or similarly in other scenarios, whether it is connected car kind of scenarios. If you're going to use 5G for remote driving of vehicles or this thing, at least if a demonstration project can be done, that can move the arrow in terms of eventually getting to use cases that are widely deployed. So that was just a suggestion.
I fully agree with you. In fact, we demonstrated a large number of use cases. If you had visited IMC, which happened last week, we are working with a large number of startups to develop use cases and the enterprises. We have like at IIT Hyderabad, we have installed the private network, 5G private network, etc. So that way, both with the enterprises, both with the community, etc., we are working. We are because we know it is our bread and butter, so we have to work. Thank you.
Thank you, Professor Huzul Saran, and thank you, Dr. Gandhi. Now our next speaker is my colleague at the Department of Telecommunications, Government of India, Mr. Vijay Kumar Roy, Deputy Director General, Standards, R&D and Innovation, who will speak on the topic of 6G standard development activities in India. He is an Indian Telecommunication Officer of the 1995 batch. As Indian Delegation Head in standardization activities, Mr. Roy contributed significantly and played a key role in strategic planning, team building, and consistent engagement in technical and diplomatic multilateral discussions in ITU. He has also contributed significantly in drafting the Bharat 6G vision document. Welcome, Mr. Rao.
This is your?
Good morning. Thank you very much, Mr. Marwa, for my introduction, and thank you very much for inviting me for this important discussion. We all understand what is standardization. It's nothing but a framework of agreements for all stakeholders to ensure, what is to ensure? To have a best performing system, products, application according to the set guidelines. What is motivation or what is intention behind that? To maximize compatibility, to maximize interoperability, safety, security, resilience, repeatability, many more. And who participates in the standardization? All stakeholders, academia, industry, users, operators, government, everyone. And for that, normally we start with a vision framework document. And before that, I would like to discuss about our experience in 5G. The development of 5G started in, I think we all know that in ITU it is called INT 2020. The unique journey of wireless communication takes place 10 years of time. So it started in 2010. But what is role of India? India started participating in 5G from the beginning. It was experience. And one of the standard 5GI, Mr. Kiran Kuchi is here, all together, many people combined, they contributed very significantly in 5G. And 5G was also a I2 accepted standard, although finally it merged with 3GPP, and we had a good experience of standardization in 5G by developing 5GI. That was the first time. Now that experience gave us a lot of strength. We identified our gaps. What should be done for 6G? 6G journey started in 2020. So our Department of Telecommunication, started Technology Innovation Group and created 6 task force. That all those 6 task force provided inputs, and we created a vision document which was unveiled by Honorable Prime Minister, March 2023. Not only the vision document was unveiled, at the same time, ITU Area Office and Innovation Center was also inaugurated by Honorable Prime Minister. See the synergy. At the same time, 2 test labs, 6G test lab was also announced on 6G, terahertz testbed and advanced optical communication testbed. So we started early, before the ITU IMT 2030 framework vision document finalization, adoption. So our vision document was created before that. So morning shows the day. Now we are ready with our own vision document, our own unique requirements. If we don't have our own, if we don't understand what is our requirement, how can we contribute in international SDOs? That is the basic, I think, step, and that has been done by unveiling of Bharat 6G vision document. We all understand, vision document provides us guidance and direction. And if it is global vision document, that is guidance and direction for all global stakeholders. After that, R&D initiatives, R&D works, everything started, 3GPP specification development that starts, and finally approval and deployment goes on. So this is the starting point, and we are fully organized, synergized this time with all stakeholders. All are participating: academia, industry, startups, innovators. I was just listening that 5G return on investment is very poor, but we must understand 5G is not only for the individual centric, it is for vertical centric. Awareness creation is most important. Our Department of Telecommunication in recent IMC, we roped in, although we wrote to 26 ministries, but participation was from 16 ministries. They started showing what use case they have by hackathon doing that, what use cases are important for their, like mines, their usage, customized usage. Now ministries, different verticals, they are knowing. So possibility is there. There is, we say in 5G, no killer application, but I say there might be lot of killer application. Only thing is that awareness creation, the role of government we are doing, and from industry also, this is expected. This was a very good question. Now, I will talk about what is happening in ITU 6G externalization. First of all, for formulation of any vision document, there is need of motivation and societal consideration. There is a working group, working party 5D for in ITUR. There this vision document, finally the discussion goes on in that. In working party 5D, we contributed for one of the user scenario that is called ubiquitous connectivity, because we thought that our requirement is different from other developed countries. Still we have the digital divide. Developed country never talked about coverage. Coverage was never talked about in ITU. They were opposing that, why coverage? This is a deployment scenario. But all African countries, friendly countries, they supported us by lot of discussion, motivation, and finally they supported us. So now ubiquitous connectivity is a user scenario in 6G. And certainly inclusivity and ubiquitous connectivity are one of the societal consideration in 6G. These are the societal and motivation for 6G. In IMT 2030 framework, inclusivity, digital inclusion, inclusion of every unconnected, ubiquitous connectivity, security and resilience, that is always there, that should be there. It should be interoperable, interworking, it should support service continuity with non-terrestrial network, non-IMT networks, or existing IMT network. So interworking is also part of that. We all understand what is sustainability. It should satisfy the circular economy principle. The system should satisfy the circular economy principle. At the same time, it should be energy efficient. It should support innovation. These are the societal and motivational considerations. At the same time, what are the user and application trends? This were discussed during the WP 5D meeting and finally in the study group 5 meeting of ITUR. R stands for the radio communication. In 6G, there should be the ubiquitous intelligence, ubiquitous computing, immersive multimedia and multisensory interactions. Network should act as a sensor, digital twin, a smart industrial application. I have written ubiquitous connectivity and sustainability in bold because this was the contribution from India. Interoperability is also one of the capability which was the contribution from India. We also discussed about what are the technological trends. This happens normally in every generation of the development of any generation of wireless communication technology. What are the societal consideration? What is the motivation? What is the user trends? What is the technology trends? So technology trend is emerging technology trends and enablers. What are the enablers? What are the technology to enhance the radio interface? Technology enables to enhance the radio network. Studies on technical feasibility of spectrum is very important, and spectrum harmonization to the extent possible. We all understand that no frequency, single frequency range satisfy all the criteria required to deploy IMT system, and same is applicable in IMT 2030. There must be differences in deployment and timings of the mobile data growth in different countries. This is a very normal thing. So it is envisaged that IMT 2030, similar to previous IMT system, would be used as a variety of deployment, research and development into enhanced coexistence and spectrum sharing approaches, including technical aspect, will continue. Already, Mr. Gandhi has talked about the user scenario, but again, I just want to point out that earlier it was the pentagon, not hexagon. So, aggressive attitude of India managed to convert this pentagon to hexagon. World, they were agreed on, no, ubiquitous connectivity should not be there. This was in so many discussions, but finally we achieved that. So ubiquitous connectivity is one of the user scenario which is contribution from India. This is first time in the history of any wireless technology development IMT system. And three capabilities, associated capabilities related to the ubiquitous connectivity and otherwise also. Coverage. Now coverage is a capability. People were opposing, different countries were opposing that coverage should not be the capability. But our target was to have enhanced coverage. There should not be any difference between the financial opportunity, job opportunities, or any opportunity between rural and urban India or any developing countries. There should be equal opportunity, no digital divide. So coverage is very important, enhanced coverage to have minimum broadband speed to provide all required services in the rural India also. Interoperability, because vendor diversity, innovation, these all are can be helped by interoperability, open RAM sort of things, and other capability you just see, reliability, latency. These are the enhanced capability from IMT 2020. So this is for IMT 2030, but enhanced capability and new capabilities of IMT 2030 are coverage, sensing related capabilities, where network will act as a sensor, AI related capability, sustainability, interoperability, and positioning, precision positioning. Okay, so I will be faster. So this is the timeline. So we have achieved our contribution has been accepted in the framework and requirement. So technical performance requirement will be discussed in next meeting, and after that standard development will happen, a standard enhancement will happen. At the same time, system deployment will also happen by 2030. Just I would like to talk about Bharat 6G alliance also, because that was announced So what is the vision of Bharat 6G? Bharat 6G document that shows design, develop and deploy 6G network technology that provide ubiquitous, intelligent and secure connectivity, but high quality living experience for the world, not for the India only, for the world. This is the vision statement of Bharat 6G vision document, which has been unveiled by Honorable Prime Minister. What is the objective of 6G mission? Facilitate. This vision has certain mission. Facilitate and finance research and development, design and development of 6G technology by Indian startups, companies, research bodies, universities. Enable India to become a leading global supplier of IP. Final target is 10% of the IP of the total 6G should be from India. That target has been given by Honorable Minister of Communication. So we have two phases of the 6G mission. Phase 1 starts from 2023 to 2025. It is divided into two parts, 23-24 and 24-25. Phase 2 starts from 26 and to 2030. And final target is IP creation. We should be, finally, revenue should be our target. We should have our own IP. We should not be follower. There is Apex Council for Bharat 6G mission. It will be chaired by Honorable Minister, and these are the members, Vice Chair members. This Bharat 6G Alliance is there. The purpose of this alliance is an alliance of domestic industry, academia, national research institutions, and standard organizations facilitated by government to help grow 5G advance, 6G IPs, and essential patents from India. Again, target is IP only. Design and build Indian 5G advanced products and solution to help build consortia of Indian startup and companies, build coalition with like-minded 6G global alliance. Just in the G20 in sidelight engagement, Honorable Prime Minister signed a memorandum of understanding with NextG Alliance of US. So one of the, I think, action is already taken place. Two test beds are planned. Already I have talked about advanced optical communication test bed and 60 terahertz test bed. And this is the timeline in Bharat 6G vision. So this is all about standardization activities in India. I think India, as per the vision statement, designed, developed and deployment, certainly we will be leader. This is the, I think, our target, and certainly we will achieve it. Thank you very much.
Thank you, Mr. Roy. I think we can take a couple of questions from the audience. So in the interest of time, we'll take maximum of 2 questions. Please give the mic there. Please introduce yourself and then ask the question. Anybody, I think you raised your hand? No, you're not able to hear? Okay. No, we have invited the audience to ask questions, couple of questions we can take. If there are no questions, we proceed with the next speaker. Okay, please.
What are the frequency band specified for this 6G? Is there any?
One meeting is going to be held in WRC 23. So I think our target is to have maximum frequency, but harmonization of frequency is also target. That will be decided in WRC 23, which will certainly, I think in next month it will happen in Dubai. So target is beyond 6 gigahertz also. And even for next WRC agenda item 7 to 15, that can also be considered. So this is under discussion. No finalization is there till now.
Thank you.
And even terahertz is under consideration. Terahertz testbed is already launched. Funding has been done. So certainly terahertz will be one of the frequency range for 6G.
Okay, thank you, Mr. Roy. So now coming to our last speaker, Professor Kiran Kuchi, IIT Hyderabad, who will speak on the topic Candidate Technologies to Meet IMT 2030 Requirements. Professor Kuchi is also the founder of a company, Visig Networks Private Limited, which focuses on advanced 5G technology. He is a key member of the Telecommunication Standards Development Society of India, TSDSI, and Bharat 6G Alliance, leading efforts to develop 6G standards in India at the 3GPP and ITU. Professor Kuchi works closely with the Government of India to shape the country's 6G plans. Professor Kuchi.
Good morning. Thank you, Marvaji. First of all, I want to acknowledge support given to IIT Hyderabad by two ministries, specifically Ministry of IT and also Department of Telecommunications. Especially MEITY has supported wireless research in India for more than a decade, and the results are showing up in the form of our contributions to various standards bodies. Likewise, DOT has funded various IITs and other academic institutions in the form of developing test beds. So all this knowledge has proven to be very useful when we contribute to IMT 2030 vision requirements and also certain candidate technologies that I'll talk about. This is a picture taken at the recent IT Working Party 5D meeting. You can see some of us, two of us present here in the front row, and also there is a person sitting next to Mr. V.K. Roy from FCC. We had 14 rounds of negotiations with him before ubiquitous connectivity is accepted as a usage scenario in the famous diagram that people are referring to, which is this. So this was a pentagon, this structure, before it became hexagon. It's just not about a pentagon or hexagon. These are deep implications for the development of these next generation technologies. One point I want to refer to is that ubiquitous connectivity is something that became a usage scenario of 6G, primarily because of the push by India. And ubiquitous connectivity, as per ITU definition, refers to terrestrial communications. However, you see this small rider in the vision document published by ITU, interworking with other networks such as satellites are also addressed. So it's through interworking that ubiquitous connectivity will be realized, but the radio performance requirements are developed only for terrestrial communications. And also for the first time, ITU has introduced a scientific definition for something called coverage, which was absent in almost starting from 2G to 4G. Coverage was never a capability of IMT network. There was a lot of resistance for various reasons, but now coverage has been captured. So this goes a long way in addressing the performance of the next generation networks by measuring the coverage. Yeah, it's a very interesting development at ITU. So today I will, since given the paucity of time, I will talk about two candidate technologies. And the goal of this study that I am going to refer to is to see how IMT 2030 capabilities that are published by ITU, this diagram, there are already certain range of values indicated by ITU, whether it is coverage or spectrum efficiency or latency. The range of values have been published as research targets for researchers all around the world. But however, one has to have a view on how to achieve these values using technology. So I'll talk about two candidate technologies. I'll take no more than 10 minutes from here. One of the important considerations in any new G is a waveform. I think 4G was the first standard that moved to OFDM from single carrier technologies, which were present in both 2G and 3G. And 5G has not done a dramatic change in terms of the waveform selection for understandable reasons. The kind of investment that went into OFDM development, both at base stations, handsets, there's a lot of investment made, so they have been retained. But however, there is a desire to achieve a higher level of performance in 6G, whether it is in terms of efficiency, energy efficiency, or power efficiency, latency, that requires a departure from OFDM. But however, you don't want to deviate from OFDM. There is a push and pull here. So we present a particular approach on how to leverage OFDM and still attain these goals. So what are the goals? The waveform that you transmit, that conveys information from transmitter to receiver, most of the energy should be radiated from the transmitter to convey the bits. That is to say that you don't want to dissipate the expended energy as heat. So today in OFDM systems, the efficiency of the transmitter is less than 30%, which is abysmally low because of the deficiencies of the characteristics of the OFDM waveform. So if you can find a way to reach 100% efficiency, there's nothing like it, especially as you move towards higher frequencies where the efficiency of the PA is not going to be very, very high. So one of the candidate technologies we considered is to use the OFDM as is. In the rightmost block here, it is OFDM, the familiar block diagram using IFFT, cyclic prefix, subcarrier mapping module. Then there is a module that we created on the left-hand side. It's actually TDMA. It doesn't look like TDMA, but it is indeed TDMA. So we have information time multiplexed within so-called one OFDM symbol. And then there is some processing done in the middle box, which is the new element that we introduce. The net result is that you use OFDM circuits, you see FFTs, IFFTs, DFTs here, but the benefits of single carrier transmissions are retained. This is a new approach. We have studied this extensively, and it seems like a good candidate for next generation systems. One of the major benefits of this approach is that whatever information you want to transmit, you can transmit as a single shot transmission. That is, if you want to transmit information in 10 microseconds or 100 microseconds, this is possible to do so using time domain multiplexing of reference signals, control signals, data transmission. However, you will still stick to the familiar framework of OFDM. So this allows us to realize hyper low latency, which is one of the targets of 6G, and also reach close to 100% power amplifier efficiency. So it's a hybrid scheme between TDMA and OFDM realized as a one-shot transmission. The second candidate technology that I would like to refer to is use of large number of antenna elements. This becomes inevitable mainly because 5G is now deployed in mid-band 3 to 4 gigahertz and also in 28 gigahertz. But there is no more golden piece of spectrum available in the lower bands, or even in, one has to move away from little above mid-band, which now we're looking at 6 gigahertz, 7 gigahertz and above. That's going to be quite a challenge for radio communication system design engineers. How do you get the link budgets? So there is no magic here except to use large number of antenna elements, increase the directivity of transmission from base station to the mobile phone and vice versa. So we did some experiment. This is a system that has been under development for more than 10 years. But now we have moved this to an extreme scenario where we use a large number of antenna elements, and we did some measurements through this particular test bed doing multi-user MIMO transmission. What is shown here is a 30-degree cell. So we have reduced the so-called sectorization from 120 degrees to 30 degrees, and we achieved multi-user MIMO up to 8 users. Shown here is these little dots there on the building here. So what it means is that if you use 30-degree cell sites using very high directivity antennas, and you pull them all these 30-degree cells into multiple cells and apply even a bigger MIMO among them, you can achieve potentially 100 bits per second per hertz. So we did some analysis through simulation, and it turns out that you can achieve 116 bits per second per hertz, as opposed to what is today as a reference 25 bits per second per hertz. That's the average spectrum efficiency achieved in 5G as an ITU target. So in principle, you can achieve 4 to 5 fold improvement in spectrum efficiency, but on a on a lower side, at least 3-fold increase is possible. But this all comes with a great expense in terms of antennas, hardware, radios, ADCs, DACs. A lot of research needs to be done. These are very early results, but what we see is that there is room for improvement in terms of spectrum efficiencies. And if you want to trade with spectrum efficiency with coverage, that's quite possible. And the trade comes in terms of beating the path loss. So we did some analysis. So using 85 dBm EIRP, effective radiated power, using a particular antenna panel, we see that in around 6 to 7 gigahertz frequency range, it's possible to achieve about 100 meters coverage. I'm sorry, here it's more than 100 meters coverage in indoor scenario. But this is in the downlink direction where the power is plentifully available at the base station. But when it comes to reverse direction, handset to base station, you can get directivity at the receiving end, but not at the phone. So that's going to be a major challenge, and it's very hard. It's going to be more and more difficult as we move forward into high frequency bands, using a single cell to get the adequate coverage. That calls for a different type of topology called integrated access backhaul. Use multiple bands and build kind of a sort of a relays. This is also something that I saw mentioned by Reliance Jio. This is going to be a very important feature going forward. Use multiple frequency bands and build sort of relay type systems. I'm not talking about amplify and forward type of relays, but full-fledged relays, and multiple hops. This seems inevitable as we move towards higher frequencies. So I would like to conclude two particular proposals I have mentioned here. One is a new type of waveform for power efficiency and low latency, use of large number of antenna elements to beat the path loss, and basically multi-hop type of relaying, which is anyway a known concept, but it will have to be used differently in the next generation systems. I'll stop here. And there was a mention of non-terrestrial, and I do agree with the views expressed by Reliance Jio. We've been looking at implementing satellite and terrestrial in the same device. This is for narrowband communications. We have done this in one of the projects in IIT. This is, hopefully will become commercial very soon. This is very exciting, interesting direction. Use the same baseband and protocol stack to serve both terrestrial and SATCOM. The differences will be in how you realize the antenna and RF modules. This is a very interesting research direction. I'll stop here. Thank you very much.
We can take one or two questions from the audience. So if there are none, we can conclude. Okay. Yeah. Dr. Atish.
So the idea here is not to do either analog or digital beamforming to begin with, but combine a large number of antenna elements, create narrow beams. So the experiment we did, it's 30 degrees in azimuth and 30 degrees in elevation. So think of it as a sector with 30 degrees footprint. So then we use it as a building block, and we use multiple of them to cover 360 degrees. So it's a different way of doing it. So today, just to give you the analogy, today there are 3 sectors, but they act as independent cells. But here, one sector is 30 degrees, and then we pull a bunch of them in azimuth and elevation, and then do a bigger MIMO on top of it. But the base unit is 30 degrees.
Yeah. How you are addressing the mutual coupling? Like, that is one of the problems perhaps you can encounter, right?
I can't really answer that right now, but we can take it offline. Yeah.
Right. Thank you.
Thank you.
If there are no more questions, I'll just summarize this particular session. So we had this very interesting talks from our 4 speakers. The first one was from Professor Vyas, Carnegie Mellon University, who covered that lack of access to realistic and diverse data from multiple deployments hampers innovation. And the result today is poor products, lack of transparency, wasted efforts in debugging and regulation, and impossibility to share insights across locations. So CMU has been leading research on demonstrating the feasibility of using synthetic data, using deep generative models to address these pain points for various tasks. By synthesizing domain-specific insights with recent advances in machine learning and privacy, design choices are being identified to tackle these challenges. Professor Sekar presented the key results from their work at CMU. The next talk was by Dr. Ravi Gandhi regarding next generation communication networks and how Geo has pioneered the digital revolution in India and transition towards the next generation 5G services, as well as the role of SATCOM in next generation technologies and the transition of India towards 6G IMT 2030. The third talk was from Mr. V.K. Roy, DDG DOT. He covered 6G standardization activities and the work at ITU, the Bharat 6G mission, Bharat 6G Alliance, and the 2 6G test beds which have been sanctioned by the Government of India. And our last speaker, Professor Kiran Kuchi, covered candidate technologies to meet IMT 2030 requirements. So he covered 2 technologies, orthogonal time frequency division multiplexing, OTFDM, as well as new MIMO scheme, S-MIMO. So with that, we conclude this session, and thank you all for your patient hearing and active participation. Thank you once again.
Thank you very much, sir, for the wonderful moderation. I will take a moment to appreciate this very interesting, at the same time, very engaging and relevant topics. Can we just appreciate all our panelists and our moderator? Thank you very much, sir. Now may I request S.K. Marva, sir, to felicitate with a token of gratitude to our panelists. May I request Ravi Gandhi, President, Reliance Jio. So please come forward. I request S.K. Marva, sir, please felicitate with the token of gratitude. Now may I request V.K. Roy, please come forward, and I request S.K. Marva, sir, please felicitate with the token of gratitude. Now may I request Mr. Kiran Kuchi, IIT Hyderabad. Sir, please come forward. I request, sir, please felicitate with the token of gratitude. Now may I request Sunita ma'am, please come on stage in order to felicitate S.K. Marva, sir, with token of gratitude and respect. And let's have a group picture together, gentlemen. What a beautiful start of this morning, ladies and gentlemen. Thank you so much for the patient hearing. I request please come forward for the group picture. Ma'am, please join us. Thank you very much. So ladies and gentlemen, before we proceed to our next panel discussion, we will proceed for a very short tea break. Please proceed for the tea break and make sure in next 10-12 minutes you will be back to the hall. Thank you. And next panel discussion is an interesting panel discussion. The title is International Collaborations, Opportunities and Challenges. So I hope to see you all in next 10-12 minutes. Thank you, sir. The topic is international collaborations, opportunities, and challenges. May I request our moderators to please take over, and I request each one of you please help me to welcome our moderators on stage. Mr. Huzur Saran, Computer Science and Engineering, Indian Institute of Technology, Delhi, Wireless Networks, Systems and Network Security, Network Performance Analysis, Algorithms. Mr. Huzur Saran. Please help me to welcome sir on stage. Now may I please request Mr. Sajal K. Das, IEEE Fellow, Computer Science, Missouri University of Science and Technology, USA, Mobile and Pervasive and Edge Computing, Cyber Security, CPS and IoT, Sensor and UAV. Please help me to welcome our moderators, Mr. Huzur and Mr. Sajal on board. And I request each one of you, please take your seat, sit back, relax. I request to our distinguished speakers and moderators to please take over. And please, ladies and gentlemen, help me to welcome this most awaited panel discussion of the day. Please help me to welcome with some round of applause, everybody.
Page of the slide. Can you please put up the slides, please? The panel slides. Thank you. So welcome everybody to the panel discussion. This topic today is how do you build collaboration, how does international collaboration help? And I think Sajal can kick it off. Next slide, please. I think already both of us. So just to give background, MEITY and NSF, this is not the first time they are collaborating. Back in 2011, and me and Sajal were part of the effort back then, there was a activity called Pervasive Communication and Computing Collaboration, PC3 for short, where a focused collaborative workshop was held, again here in IIT Delhi at that time in Delhi, under which 6, I think, projects got funded, and 3-4 years those projects were also did very well. So I'm just highlighting that to point, and me and Sajal happen to be involved in that, so there is some continuity. Mr. Baveja was there, who was here yesterday also, and that just highlights that these things, there is value in it and there is continuity. Of course, now with the formal ministerial level MOU, hopefully this will be a continued effort every year. Go on, Sachin, you can. Okay. So the point is, what kind of models can there be for this? This is just from that time we had a similar panel discussion almost 12 years ago on how to build models and mechanisms for successful international collaboration. I am looking a little younger there, and so is Sajal. And we had very good participation from Gerard Parr, and not that it is directly relevant, but Gerard Parr is also leading a big effort. Only last week or 2 weeks ago, he held a conference in India-UK collaboration. Again, Ministry of IT is involved with that. So this is something that Indian government is pursuing with major countries all over the world, and we have had good success with that. Next. I'll take over.
So with that in mind, I think what Dr. Huzur Saran mentioned, that there is a continuation. Can you hear me well? Okay, good. And of course, that was the previous one, and we all looked much younger, about 10 years ago, 12 years ago. So we have a distinguished set of 4 panelists for today. And the title is International Collaboration, Opportunities and Challenges. And I'll introduce very briefly the panelists over here. The first panelist on my right side at the very end is Dr. Suchi Guha. You may have heard her talking about her research yesterday on the semiconductor. I'll not read everything over there. So she's a professor of physics in the Department of Physics and Astronomy at the University of Missouri, Columbia. And she has been doing a lot of international collaboration with IISc, with Brazil, with South Africa, if I may say. So I think we're very fortunate to have her. Our next panelist is Nirmala Roy. He is a professor of computer science at the University of Maryland, Baltimore County. He works in IoT sensors, wireless mobile networks, machine learning, and connected health. He has established collaboration with IIT Kharagpur, IIT Jodhpur, and some of the students from there are exchanging visits with him. He also organized this year in June in Washington, DC area, an NSF DST workshop, because they got some funding, co-funding from the TIH from India side. Our third panelist is Ms. Sunita Verma from MEITY, and she has been very active, as you can see from yesterday. She has been a group coordinator for electronics and IT under MEITY, and she is very much engaged in policy formulation, building teams, collaborations, and all this kind of stuff. And she also leads or has led the National Supercomputing Mission in India, as well as the Chiefs to Startup Program and National Language Technology Mission. This particular panel will not be on a particular topic. It will be in a broader sense of how to establish collaboration, how to be successful, what are the algorithms, if there is any, what are the matchmaking process, and that kind of stuff. And our last but not the least panelist is Mr. Premjit Lal from DOT, Department of Telecommunication. And he has been very, very active, as you can see, in many different activities in terms of not bilateral, multilateral, as well as international collaboration. Has been an ITU, International Telecommunications Unit Counselor, and he has been actually on the IEEE board of standardizations of different telecommunications activity, and also is part of the vice chairman of the Asia Pacific community. So with that introduction to all the panelists, so let us give a big applause to the panelists for their participation. So we'll talk a little bit on the format of the panel. And I know that I'm standing between you and the lunch, but we'll make sure that you get enough food for thought. And if the actual lunchtime is cut down, that should be okay, because food for thought will actually supplement your appetite there. So what we have done, we have formulated a few questionnaires for the panelists, and we have shared with them, but we asked them to give a very brief presentation on each of the questions, and we'll actually go to the questionnaires, so that we have enough time for the audience to ask questions, because this is the time to ask the right kind of questions, because we have government representation, we have academic representation, that how to be successful in this US-India or MEITY, NSF collaboration, how to go about that, right? So this is just one slide I have, that we should all keep in mind that collaboration is a very organic, symbiotic process. It does not happen overnight. We have to cultivate it. We have to have the right kind of mindset. We have to leave behind our ego. We have to accept everybody as an equal partner. That's the way the collaboration will happen. So this particular picture basically says that if we ask the question, what is there for me in terms of collaboration, that will not be sustainable collaboration for a long time. So question would be that, can I contribute tangibly in the technical domain, scientific domain, innovation domain, so that I am indispensable to the team? So what I'm saying, when you build the team, let us keep that in mind. We all know it, but we are just reinforcing that we have to have that mindset. Trust. We have to have good communication among the collaborators from both ends, right? Within the country, outside the country, and all this, right? So with that in mind, so the opportunities are huge, because it could be collaboration, long-term sustainable collaboration in terms of education, research, technology, innovation, cutting-edge ideas, right? So we should actually keep that in mind. So with that, so let me ask the first question. So myself and my co-moderator, Dr. Hujir Sharan, will actually alternate the questions. So you'll see the questions on the screen, and the panelists are aware of the questions, so that they have their thought process put together. Our first question along this line is, For research collaboration with international partners, what are the potential benefits and opportunities? Many of you know exactly what it should be. Are there challenges, particularly when you talk about India-US collaboration? Right? With that in mind, I have actually put together the order of the speaking of the panelists, but everybody has just 1 minute to touch upon these questions so that we can actually limit it, right? So, Suchi, I think you are the first person to pick up. Everybody has a microphone, you can pick it up. And we'll be very brutal if you don't mention the time.
Just cut me off, right? Thank you. So I guess you already said that, any research collaboration at all levels, I mean, that is the most important for progress of science and technology. And for the international partners, I think we have seen several examples yesterday in this workshop itself that it adds another dimension, right? Because the problems that are in India are very different from the problems, and we heard about the autonomous vehicle, for instance. So I think the international dimension really adds a more holistic picture to the progress. And I can give you an example. If I'm thinking about solar cells, I may think about commercial applications to put these flexible solar cells in a backpack or fabric, but the more pressing problems here may be to come up with a solution where you're pumping, you have a solar cell for a pump, which needs to be for irrigation purposes. So just looking at the same problem from various angles, I think is a much better way of doing science and technology. What was the second part? Challenges. I'll just mention one quick challenge, and that I think is between exchange of short-term visitors, and specifically from visitors from India who want to come for, let's say, 3 months, which could be students, postdoctoral fellows. Visa problems are a challenge. I'll leave it there.
Good.
Okay. Yeah, so I agree with Dr. Guha what she has said, that international dimension could add new momentum to our research. So whatever we develop, whatever algorithms, techniques are always constrained. We are developing in our lab environment, in a specific environment, in specific context. Now consider the international partners context, like the India context. How do we scale our techniques? How do we make those algorithms more adaptable, more resilient, robust, and they can work across multiple environments? That is only possible through this international collaboration, because we will have a different set of challenges and different set of environment, different set of data sets, and different set of artifacts which we have to incorporate within our proposed method and technique, which could bring new dimension to your novel contribution. Now the next question, are there challenges? There are various challenges, administrative challenges and research challenges as well. I'll just give you one example on the research side. It's the data sets. Like, how do you collect the data sets? How do you share the data sets? I mostly work on smart and connected health. I have the IRB approval in Baltimore area from the University of Maryland, Baltimore County. But can I share the data sets with my partner at IIT Jodhpur, IIT Kharagpur? It's a challenge. They have their own data sets. Can they share their data sets with us? So these are the specific challenges in terms of the intellectual merit.
Very good. Sunita.
Yeah, thank you. I think you have both pointed out very pertinent question. I'll try to answer in 1 minute. So the potential benefit that I see, or the opportunities through this collaboration, is that both the sides getting a perspective of the research which is happening in both the worlds. So generally researchers tend to be in silos, and this opportunity will be an eye-opener for both the sides. And especially developing and developed countries, how they are there. We are there, we make, in India more of frugal solutions. So working with lesser funds and taking more deliverables out of it has some benefit that I see. Sharing of infrastructure, expertise development, making innovative solutions with industry participation is some benefit that I really see from both the sides. And also industry getting insight into how the researchers can actually translate the technology for the market. So that also benefit for the Indian industry is a potential benefit that I see. Then the challenges are there, too many of them that we look at. First is, yes, the data sharing will be one of the major challenges. Second is IPR sharing. Third that I see is that in this specific collaboration, we are looking at the MEITY is looking at applied research, and NSF has at present under the scheme that we are working with is more on the, I'll not say fundamental, but more towards the basic research. So gelling the two to come out with an innovative solution for the market is something that I'll see that the project proposals have to be formulated in such a way would be major challenge, and I'm sure we'll be able to overcome that. Thank you.
Thank you. Whenever any collaboration is done, it has to be beneficial for both the parties, then only it's successful. So we have to see what is there in this collaboration, what are the opportunities for US and Indian side separately. US is having a ecosystem of innovation, academia, startup, and through that it is having the lead in the cutting edge technology. So for challenge or opportunity for US is how to maintain that cutting edge. India is traditionally a big consumer market in which we are consuming the technology, and generally we are importing the technology. If we see 70 to 80 billion dollar of import is there every year in electronics. So how we can leverage our strength in skills, incoming new startup system, and how can we replicate US kind of system and come up with new innovation and research coming up in collaboration with the US side, that is a benefit for us. So if we can together come together and we can work as a complementary organizations and we can co-create better innovation by the skills, the frugality in technology which we are achieving in India. So these are the complementaries I see in this kind of collaboration, and both have great opportunity and chances of success are quite high. When it comes to the challenges are there, but it's not unsurmountable. It could be, as other panelists also pointed out, data privacy protection, IPR could be the issues. There could be some cultural differences between both the sides. Legally, there could be issues in realizing the potential of those research. So these are some of the challenges we see in this kind of collaboration, and it has to be there, but it is all surmountable, and I think it can be beneficial for both the sides, US and India. Thank you.
Thank you all the panelists for maintaining good timing. So Huzur, you go to the next one.
So can you share with us some experience you have in collaborating with international researchers, particularly with India, but also with other developing countries? Can you share the nature of the collaboration, and what were some of the positive attributes and some difficulties you experienced? We'll start with Nirmal here.
Okay, thank you. So yes, I have been collaborating actually, and I think our collaboration has started in 2018 through a Spark scheme. Many of you might be familiar with the Spark project, which was initiated by the Indian government, and we started collaborating with IIT Kharagpur, and then we have done some joint work mostly in the smart health application area, and then there was some initiative from the NSF. There was a DCL, DR co-regulator, to supplement your existing NSF project. So we started working on that based on that collaboration, and I am collaborating with multiple entities in India, but I have only 1 minute, so I will be very brief on that. And then a positive attribute and some difficulty you experienced. So positive attribute is that Indian team are always very motivated, hardworking, and they can meaningfully contribute on your project. And some of the difficulty we faced, like generally it is hard to synchronize everyone's schedule sometime, but you have to be very regular in setting up all the meeting, maybe weekly or bi-weekly we have to meet. We all are pretty busy. Our schedule is pretty hectic, but you have to honor everyone's time and regularly meet and get the update from the students. That way you can make significant progress. Yes, I'll stop here. Yeah, thanks.
Okay, thank you. So there was an Indo-Dutch collaboration in 2013, and under that, in the phase 1 of the collaboration, there were around 5 projects which were taken up in the area of big data and IoT. And at present, there are 3 more projects which are going on, and all the 3 have industry contribution also. So one is for head and neck cancer detection, and the second one is on the pipe leakages, so which is with Shell as an industry contributor. Then the third one is on the opportunity. Third one I can't remember. So all these 3 projects have industry participation, and the industry, okay, so third one was for the e-commerce value chain with Flipkart. So all the 3 industries got to get the problem statement being developed by the collaborators and get the solution and also work with them. So that was one benefit that they had, working with the researchers very closely and also getting the requirements met through the program. And also there was sharing of the infrastructure, the knowledge and the expertise development from both the sides, understanding the socio-economic also, and also the scientific culture of both the countries was something that was really shared and appreciated. The difficulty that we had experienced, and we are seeing that we don't do that again, is that there was a mismatch in the time of approval of the 2 projects from 2 sides, because each one of them have different process of approvals. So the dates did not match. So we are trying to see that this time when we have this MEITY NSF collaboration, we are in sync so that we have the same timing of matching. And then yes, data sharing was one other major challenge, because that there was a clinical trials and medical information had to be shared. So there was a major challenge in that. So I think those type of things need to be sorted out at the initial stage when the proposals are being formulated, so that the clarity of the engagement and how to take care of these experience and difficulties has to be actually chalked out with the clear roles and responsibilities.
Mr. Lal? Thank you. Yes, so I'm not really into very hardcore kind of collaboration with the international researchers as such, but I have a wide experience in multilateral and bilateral forums where we are meeting a lot of researchers. We are having ITU meetings, and how during the standardizations, various negotiations, consensus making, and how on each and every different kind of aspects which are coming from the researchers, how to reconcile those differences and come up on the consensus based methodology. These are some of the collaborations we are having, and recently we are coming up with UKRI, UK based organizations, similar kind of joint collaboration is being done by the UKRI in India on behalf of UK, which is being done in case of NSF by US side. So I am deeply associated with coming up or formulating those processes and internally how to make the joint collaboration successful, what are the various parameters, how to benchmark it, how to review it. So these are very complex issues when it is between different cultures, different kind of upbringing. But we learn during this process from each other how good we can do and how we can make these collaborations successful. successful. Difficulty could be these processes are slightly time consuming, sometime process oriented, while research is very free flowing kind of without any hierarchy, and you don't require a lot of processes in terms of approvals, time consuming approval or processes. So that are some of the difficulties we should remove for the researchers. That's my understanding as a policymaker. We should not be standing in between their research work and the processes which we are following. Thank you.
So my first collaboration, I think it was almost 15 years ago, the NSF had this program which was called International Research and Education in Engineering. So it was a supplemental grant that I had to my existing grant, and this was a collaboration with the Indian Institute of Science. And there was a synthetic chemist, he's one of the world experts, and he contacted me. So this was perfect because, you know, we are making devices, but we always need these raw materials. So that's what really got us started, and that's been a very, very fruitful collaboration. I also did a research leave after that at IISc. And since it's also other countries, the NSF also used to have this other program which was called CNIC, catalyzing new international collaboration, and I had that with Brazil, which has also been, you know, over the last 20 years, we've been, maybe not 20, 15 years, that collaboration has been going on. So I have to thank NSF for these supplemental awards. In terms of, let me see, what was the other one? Some of the challenges that I faced, and again, you know, the US is very large, right? The Midwest is very, very different where I am compared to the East and the West Coast. And I could not actually get one of my students to come to Bangalore. We had the funding, and he was just very hesitant. You know, so that was one thing, but the other thing, again, the nature of my work is, you know, I work in the lab, so we need exchange, we need student-faculty exchange, and there were also issues of the person, you know, from Bangalore, we couldn't get a visa, so that has been a challenge in terms of actual exchange of personnel. Yeah.
So let's move to the next question. I would appreciate if the panelists, be brief as best as possible, as much as possible. So our next question is the MEITY call states. Actually, we have been talking since yesterday in different breakout sessions as well. NSF has one focus in like basic and applied research, but fundamental advancement of science, whereas from the MEITY side, the industry collaborations are encouraged, not mandatory, but encouraged and appreciated. So with this in mind, so because we have two government agencies over here, MEITY and DOT, the questions are for them, Sunita and Premjit, that how will the industry benefit from this? The industry also has to see that they have a benefit for this type of collaboration. Or are there selected industries that MEITY is recommending that, oh, you should collaborate with such and such? Or it could be a large company versus a small company. Anything that you can highlight and as briefly as possible. Thank you.
Yes, so the immediate benefit, so MEITY has been supporting funding with industry partnership from a long time, and where we have in cash and kind contribution from industry. So industries does see the benefit because their R&D risk is covered through the government funding. That is the first benefit that they get. So if they have any idea, they can get it done through an academia without actually incurring any risk on that. And they get to work with the academia for the R&D. So that is very big benefit for the industry, and that is why participating in our programs. And support is more than 10 or sometimes 20% in cash also contribution. We have big number of COE, Center of Excellence, in different emerging and critical technologies like additive manufacturing, e-waste management, then IoTs, then also for sensors. So all these have given us good results with the industry, and 2D graphene is the latest one. So, and we don't expect any industry to be selected by us. So it is the academia which has to choose the industry, relevant industry, because the comfort level, the expertise, complementing one another's vision and outcomes is what they both have to agree on, along with the IPR and the licensing and the technology sharing has to be done by them.
Thank you.
So.
Thank you. If we see the benefit for the industry are huge, because if we see the Indian industry, it is very few industries are putting up a lot of money in R&D. So R&D is very much required when you have to move the value chain, if you have to move the high this thing margin products or high end of the products or niche products. Then this kind of research and innovation, if this is coming through the collaboration which we are envisaging now, could benefit industry in the sunrise sector, especially in IT and telecom. These are the sector, or semiconductor or electronic manufacturing, where traditionally India, except IT, has been a lot of importer of technology. So if we can generate the technology and the industry can come up with the new product and services based on the research, it will be very, very beneficial. And the last few years, when a startup program has been started, it has been quite successful, and a lot of mushrooming of startup is the testimony to this kind of research which is coming in Indian landscape and benefiting all the industry at large. As far as the what kind of industry we want to select, then being in telecom sector, I can say that is still almost 50 billion kind of import is being done in telecom sector. So we should have thrust on electronic manufacturing, telecom and ICT cutting edge product, where research can really add to value to the Indian industry through the partnership with the academic institute. That's all. Thank you.
So I just forgot one important benefit that industry gets is, and we have seen it also, is that when the researchers, they work on some problem statement, industry generally tries to pull them back, when they want to commercialize the technology. So, so they get very good trained manpower also from these projects.
So following up on the previous question, so when you bring in industry and partners from the US and India, the issue of intellectual property can sometimes become a bottleneck. Different countries have different rules about it. How do you do joint sharing of IP? What are the kind of challenges with that, and what are the potential legal obstacles on that? So Shuchi, you can
I don't have the right answer, but this came up even in the breakout session yesterday, and something which was mentioned is perhaps when you're writing the proposal, it'll be good to have a MOU between the two universities, and that could, I think, solve a lot of these issues later on. So that was one thing that was brought up. I think that's where I'll stop.
Just to add, I think MOU, when you're writing a proposal, MOU, getting an MOU done through two universities can take a lot of time. But definitely, if the project gets funded before you get really started on it, I think both the NSF and MEITY expect you to have some agreement between the two parties, which can be approved by your respective university. Mr. Lal?
Yeah, it's very important. Before going into the joint research, we have terms and condition of joint IP filing well in advance. Then it could be useful for the future when we are filing this thing IP across countries, because this is geography based IP filing. And you have to file in different countries. Obviously there will be issues. You'll have to prioritize some of the geographies where you want to file these IPs. And in India, there is a lot of hand holding by DIPP and different ministries for the startups in terms of waiving off a lot of fees and other things. Awareness is being created, because IP was something which is very important, but was not thought so in India since last 10-15 years. That kind of realization on sensitization has been there, that it has to be done. There are a lot of legal implications in filing in different geographies we have to understand. So it is very important that government as a facilitator should create the environment or create the awareness about various IP issues which can come up in different geographies.
So to follow up on it, Sunita ji, in the context of this thing, if there is IP to be filed, there will be costs also. To file the IP, there is a lot of charges normally, right? If you especially are going to do US patent, India patent, the charges can be very heavy. Would there be additional support by the funding agencies for
Yes,
that?
right. So under our R&D program, we already have this provision that any support which is given for research, so MEITY bears the cost of that IP, maybe it national or at the global level. So both international and for any countries, even PCTs, anything. So those charges are borne by MEITY, so there is no issue on filing of IPs. So alternatively, they can build into the cost of the proposal, or it can be separately also taken up by MEITY when they say that the research has been done under a MEITY supported project.
So IP is a good problem to have, right? You have an innovation, and innovation has an impact and potential. That's a very good problem, and then I'm sure that both the agencies as well as the researchers, universities will resolve the issue. Okay, so our next question is how to, so this also came out in our breakout session, because there are lots of younger faculty who may not have collaborated with outside India. So question, how do you find your partners? So the question is actually in a computational term, what we are saying, is there any matchmaking algorithm that you can follow? Are there a list of the people that, let's say, MEITY or DST have, so that people can see, oh, these are the people and these are the kind of potential research areas that you can partner with, right? And question would be specifically for Nimal and Suchi, that you went through this process, you had collaborations. So how did you really find? You mentioned some of those things, be brief and just mention something.
Right. So this is a very good question, but there is no matchmaking algorithm or software tool which you can use to find your collaborator. So one idea I can give you, like if you are serving on the technical program committee of a conference, you can find out who are the US professors. They are also serving in the technical program committee of the same conference. So there is definitely some common interest, and that's why the US collaborators and the Indian collaborators, they are both going to the same conference, right? So in that way, you could find out your collaborator. That hasn't happened to me, but later on, when I checked, I found out that both my collaborator and I serve on the same technical program committee of IEEE Pervasive Computing and Communication Conference. So that's one of the magic toolkit you could use to find your collaborators. You can also go through NSF Active Awards. There is a NSF website. You can search who has active research awards in your areas of research. And then you can personally write to them, you can contact them, and then you can try to find out if there are mutual or common research interests. In my case, how did I find the collaborators? Basically, I paid a visit to one of the Indian Institute of Technology back in 2013, not having in mind that I will have this US DST opportunity or US MEITY opportunity or NSF supplement DCI. I didn't know about that, but when I paid the visit, I went to meet a very senior professor, and he was not a collaborator on any of my project. But later on, he recommended that these are the faculty in Nirmalo you could collaborate. And I started the collaboration. That doesn't mean I have continued the collaboration with the same faculty. The other faculty, then they came into the process. So it has to happen in an organic way. So that's what I would call.
Sure.
Yeah.
I think you've really answered everything here. So again, with collaborations, I think it has to be complementary, and this is what I look for. Because let's say if I'm doing devices, I need the raw material, I need other expertise, and so one thing is if it's complementary, then it's much more organic. And I completely agree with Nirmala when he said that you meet your collaborators at conferences. That's the best place to sort of see what people are doing. I think those are really, and again, I don't know if there's any other magic bullet here, but yeah. So
I think the mindset, willing to collaborate, is the key, right? And what I have noticed that I think we discussed in the breakout session yesterday in the communication networking, that don't wait for the call to come for funding. Start collaboration. When you have the collaboration, then a byproduct of that is a proposal. Because you're already collaborating, you have the chemistry, you have the trust building, right? Whenever the call comes, you just take advantage of that. I think most of the collaborations which will be successful will be on that, not like, okay, there's a call, this is a workshop, and I start tomorrow. Because that's too late by the time you start, right? So that's good part. Okay, good. Who's it?
So what is the formula for successful international collaboration? Sort of, since you have been, both of you, many of you have been collaborating in or guiding collaboration in the case of the ministry, you can suggest some key points to look out for to make it successful.
And we are doing a round robin. We are in computer science, right? Our algorithm is a round robin. So you can see that sometimes you go this way, sometimes the other way.
Thank you. So I don't know the formula, but I can just
I thought you don't buy the formula that is big bazaar.
I wish I could. But I think there are a few of the parameters which should be kept in the international collaborations. One is the teamwork and the respect for each other's works, and understanding each other's requirement and going with the consensus making process. We should negotiate well with each other, and as a team we should work. We should not work in silos, or we should forego our egos in some time. We don't agree, then also we should be going extra mile to reconcile some of the issues or differences if they are coming. Then these are some of the things which come to my mind, that is universal kind of truth in any of the collaboration applies to the international collaboration too. Thank you.
Very briefly, each one, then you'll have more opportunity in the QA session to add additional thoughts.
So yeah, so there is no specific formula, but I feel that getting the deliverables done and the satisfaction of both sides of researchers that they have contributed in the actual innovation of technology, and also reaching the goals is something where in true sense there is exchange of knowledge. So that is one of the success criteria that I feel is there. So sharing in terms of knowledge, in terms of infrastructure, in terms of expertise. And so my advice, I think, or wisdom would be, that the project proposal should be very clear. The more the clarity, the clarity of the implementation would also be there, even monitoring clarity will be there, and it will also have more chances of selection. So where the clarity is there regarding the roles and responsibilities, the IPRs, the sharing, any other challenges, milestones. So I think so the better will be the chances for the proposal to be selected, and also the success indicators for that collaboration will be also clearly chalked out.
I'm just going to echo what Sunita and Premjit said. So I think the main thing is it has to be a partnership between equals, and respecting each other's disciplines is, I think, key to any fruitful collaboration.
Yes, I agree with all my fellow panelists that you have to be respectful and you have to honor the partnership with your collaborator, and definitely there is no specific formula for doing that. Since I did this exercise, I can share some of my experience briefly. Basically, you have to be persistent and consistent, and you have to have patience. You can't expect that you'll get the next ACM transaction or IEEE transaction paper next week. So you have to wait, and you have to continue this collaboration with your international collaborators, and you will see the results. It may take some time. And also regarding sharing the wisdom, like don't think about all the happiness and prosperity is there on the other side of the river. it's always like mutual. They have their own challenges, you have their own challenges. They might not have a student or a postdoc to work on your project, but if you have your student and postdoc, engage them in the research, even if they don't have the resources at that time. They might come up with the resources, students and postdoc, and they could help you later on to continue your research collaboration.
Very good. So if I can summarize, and then we'll open up for the Q&A for the audience. I think they're talking about the trust, sharing of the information, and approach and attitude to collaborate, right? So I think the formula would be that keep your ego in the closet. Think equal partner and be very open, communicate, discuss, results will follow. Just follow Gita sloka, right? Karmonedhi karestu ma phaleshu kadashana. That means you do your work, results will come. Whether it's a grant or exchange of visits or a paper or whatever. With that in mind, I think we started late, so I hope that we can take some more time because it should not be a one-way monologue from the podium to the audience. Now from the audience, you can ask any questions that you may have to the panelists. Hard question, semi-hard question, easy question, whatever you would like. Yeah. And are there any microphone for the audience? Otherwise, you can share one of the microphones from here. Yeah. Thank you. And please do ask your questions because we want all of you to be successful. I'm saying on behalf of a research community, I'm sure on behalf of the funding agencies, they also want successful, high-quality proposals and people to be engaged. Okay. I think there's a question right over here, right? Did you have a question, Prakashji? Okay, I saw. Yes, please.
Yogesh Simon, Engineers of Science. Maybe there's an easy question. How big should be the collaboration? Because the funding, like Sunitha said, Indian faculty can make the money go longer, right? So you can very well have maybe even 3 or 4 faculty on the Indian side, while the funding on the NSF side might barely be enough for one PhD student, right? So do you have any experience in terms of parity? And complementary skills is definitely helpful, but should it be 3, 4, 5 faculty who come together?
So this should be a question for the panelists as well as for the agency, and Mahan is there on behalf of NSF as well. You can also chime in.
Yes, so we have no restriction on the number of faculty who can join or the number of institutions which can join. It can be in collaboration also. So, but the restriction of the outlay is there of 5 crore from here and 600,000 from the US side. And there is, also there are different heads under which the budget can be requested. So it can be for consumables, for capital, for manpower, travel. Travel, of course, you have to factor in the travel to US side and to and fro for both the sides. So that should be part of the proposal. So, yeah.
Other questions, please. This is your last opportunity to ask questions to the agencies who are sitting in the panel and the audience. Yes, I think there's some other question there.
Hello, I'm Sneha Thombre from Cummins Engineering College, Pune. This is a very interesting session and I'm intending to write a proposal. So what you said is very nice. We have to have goals, clarity of implementation, then success indicators. But this is a research project. So if something comes new in between, or if something changes during the research, that's very a possibility. So how it is taken as? That's what I wanted to understand.
I think that is, see, you will be having an industry collaboration also. It does happen that during the course of the project, the research that you are doing, the path that you want to take, you feel that it is not the correct one, you have to take an alternative. So that is part of R&D research, and it will be taken on, there will be reviewers who look at it whether it is justified or not.
Suchi and Himalu, I think.
And so I agree with Madam Sunita, what she said. So research is an evolving process. Definitely you are going to define your research aim, research objective in the proposal. But as time progresses, there might be changes, and that can come from the administrative point of view, that can come from the research point of view, right? From both sides, those challenges you have to tackle within your research, how you are going to incorporate those changes. And those changes can be basically linked with your existing proposed objective, and that can add new value to your innovation actually. So it's research, and I can basically give the example of NSF. For example, for NSF, as you advance your research, you bring new challenges, they generally like it. They don't want to see that your research is confined in a closed room. They want to see that it should advance, it should go beyond something where you are bringing multiple research questions and trying to address the same fundamental research objective which you have defined in your proposal.
I would just like to add to what Nirmala said, and at least with the NSF, you write progress reports every year. And if there is something which you had proposed, it's somehow things are just not working and you have to take another direction, you can do that and you can talk to the program manager. It's actually not frowned upon. On the other hand, it's encouraged. So there are mechanisms of, doing that with your project report and saying that, yeah.
Same is for MEITY also.
Yeah.
Yes.
So in the ministry also, we have this mechanism of what is called every project has a project monitoring committee chaired by some faculty from some other who's an expert in that area. So if you have a sensible idea and you find that there are certain bottlenecks and you want to adjust in a certain way, the committee can recommend, and MEITY is happy to accept. Yes. So I think that flexibility is there in both sides.
I think it's a very good question. Most of the breakthroughs happen when you take a diversion. That means when you proposed, you have certain idea. As you progress 1 year, 2 years, you have new ideas, right? And the pivoting the idea actually leads to new type of innovations, right? As long as, I think what some of the panelists mentioned, you can connect the dots. For example, you're doing something is completely different, maybe not that much relevant, but if it is a breakthrough, then everybody will appreciate that. Okay? Other questions, please.
Yeah, good morning, sir. This is Dinanath Gupta from CTEC Mumbai. And before this, I was in private engineering colleges of Greater Noida. I am a doctorate from Jamia Millia Islamia. So what I faced that many of the professors and students are fearing, they have an unknown fear of failure when it comes to international collaboration. So I just asked to the panelists that how to deal with that fear. We are not, come forward to write a proposal. And also, one more thing, do we will have a session to write these proposals, international proposals and research collaborations? That will be a great help for professors and students working in the field of research. Thank you.
Yeah, in addition to this, the same question I have, we have a number of private university in India. So when we are seeing number of proposals are, accepted from the IITs and NITs already. So all the professors or the, faculties from the private universities are somehow demotivated, because, when they applied, mostly they haven't applied. So they tried, so they will be rejected. So we understand, is there any policy for private university, if you are in private university, so there are any chances to, not accept the proposals? So my question is this to the panel also.
So there are two questions, right? One question is that fear of failure, and the second, so I can actually elaborate on that and someone can chime in, then we'll come to that, because the policy issue, NIT versus IIT versus non-governmental institutes, that's not, I cannot actually answer that question. So, one has to take a risk. We all fail. If you think about our personal life, family life, research life, academic life, if you don't take a risk, we don't gain anything. Right? So, if I may quote Swami Vivekananda, what he said, the strength is life, fear is death. Right? Expansion is life, contraction is death. That means we have to take a risk. Right? That means we have to be bold. We may fail, but sometimes the boldness actually will lead to, and that is not only just in personal life, but also in research career, right? So we have to be bold. We may fail, but we should be committed, convicted, And we should have the passion, right? And we all went through the same passage. I was a young faculty before, right? So now actually, any of the other academicians can highlight Huzur as well.
The question was about international collaboration. I think you start with some domestic proposal first. You start small, you gain confidence from that, and then you start expanding your scope. And as suggested by the panelists here, you meet faculty at conferences where you have a paper, and that's where you start exploring with maybe a very simple student exchange, not even a formal proposal. And then once you start gaining confidence with that, you go to proceed further. Now, I don't think you want to take a big leap without any experience, so you go step by step. That is one way to deal with the fear. On the administrative side, on the second part of the question, on funding for private colleges, maybe Sunita ji can.
Yeah, we are open to funding and collaboration from the private colleges also. So it's so yes, initially we had started with the proposals or bigger projects funding to IITs because we saw the expertise there and expanding on it. But we have been working on the hub and spoke model also, where we are mentoring the other institutions with the help of our institutions which already have the expertise. And over the years, we have started, as the expertise is increasing in the private colleges also, we are supporting private colleges, and in this specific collaboration also, we are welcoming projects from the private institutions. So it is on the merit of proposal, it is not on the merit of the institution that the selection will be made. I can assure you on that.
Please.
I just wanted to add something because you brought up this, private new universities. I mean, in the US, there's, all kinds of institutions. And one thing you may want to consider and going and talking to your administration and have a proper, it's like a grant office, people who can help with proposal writing. And if your institution can pitch in some money and, help the PIs with proposal writing, I think that could also enhance your chances.
Yes, please.
I think the question of fear and risk, as Professor Das rightly said, that risk taking is required, but you can have the networking and mentoring from the similar kind of people who have already done this kind of research work, and you can learn from their journey, you can interact with them, you can be guided by the way they do their proposals, and these could be some of the useful this thing in getting the fear out of this proposal making. Thank you.
Yeah, I just wanted to add that, don't think that this is the last opportunity. The opportunity will come along. So start the research collaboration. Even if you are not able to submit the proposal to this MEITY NSF call, that is absolutely fine. You start the collaboration with the international partners, start generating the pilot data, do some pilot study, publish some joint work. You'll see the opportunity. Maybe next year there will be other opportunity from MEITY or GST or from other agencies. And that time we will be in a much better position to submit a strong proposal. So that's my advice.
Yeah, look for long-term sustainable collaboration. I think that's the key, right? Suddenly it went out, so.
Yeah, can I have one question?
Yes, please. No, please ask question, but the slide actually, we wanted to have the slide because we still have something more to show. You can bring the slide over there, please.
Yeah.
Yes.
Myself, Ashok Bandyopadhyay, I am from SIDAC, Kolkata. It's really a very enlightening session going on. Probably we'll be able to try out some good collaborative approach. But one just a small thing what probably can help us if your guidance can come up regarding the industry participation. That is the requirement coming from the MEITY side. The requirement is not there in the NSF side. As such, we have seen. Now, for the same project, like when we are going to formulate the project jointly with the NSF, means counterpart from USA, the research organizations, but particularly focused on research, they won't be able to help us in getting this kind of industry participations. We have to see from Indian side only. Now, if the approach is something like that to find out some more research content to the problem, then industry participation directly is not going to help us that way. They would like to go for some product at the end, and that we have to visualize from the beginning. So that makes a challenging thing in some particular areas, particularly the areas like semiconductor, these devices and all that. For that, you see, small industries and all that, they are not going to be participating in that. So any guidance like how to go about, if MEITY can help us or the forum can help us in getting some sort of list of companies or industries in some areas, some segregated lists, we can approach them and try to convince them this is a kind of problem we are going to take up. Can you come up with us or not?
Yes, so yes, the list is available with us for the existing collaborations that we have that can be shared. Alternatively, it is not an end product that we are looking as a deliverable under this collaboration. It can be something intermediate also, coming out with a patent or something which is or an IPR which can be useful for the industry, which can go on to for them to develop something for the market. So yes, so basically it is the impact, because innovation is the crux of this. This is how it will be measured. So the innovation has to be there, and that innovative solution, I'm not saying product, so solution, innovative solution or a patent is something which the industry also might be interested in. So there are few semiconductor, I'll not say there are bigger or more semiconductor industries, but there are few of them which can be approached to make them actually interested in what you are proposing.
So, madam, you mean to say that while approaching the industry, we will specifically mention that this could be the outcome, not the direct product, but these are the outcome, possible outcome, where the IPR and all that, which
it can be an IPR,
share.
it can be a patent, which can be commercialized or exploited.
But yesterday, I think, if I am not wrong, madam, regarding IPR sharing, there was some instruction. I think we cannot share the IPR that way straight away. Is there any guideline?
You have to license it. So the IPR will reside with the implementing agencies, which have to actually upfront decide on who will own the IPR for which activities between the two agencies that are collaborating, and the IPR will be licensed, or they will be to the industry. Industry will not hold the IPR.
Right. Okay, madam.
So is the industry participation mandatory or encouraged?
It is encouraged.
Encouraged. So
it is encouraged.
Okay. Yeah. Okay. That's another clarification. Thank you, sir. Thank you very much.
Any other questions? Yes, please. We are generating a lot of food for thoughts. So as I mentioned, your lunch will be cut short because this food for thought will actually make you half full.
So Sajal, these are not questions.
Right.
I will try to provide some answers.
Sure.
I'll make an attempt.
Please.
Number one, I think Professor Guha raised a question about visa. In the future, when you have a collaborative project, and if there are any issues with getting a visa for students who are working on NSF funded projects, please contact the Office of International Science and Engineering at NSF. Okay, and the US Embassy is also very helpful and collaborative in making this happen. So they will get in touch with OIS, OISC will get in touch with Embassy, and students' visa will happen. Rather, at least the visa interviews will be forwarded. That's what they can promise. Okay, I believe there is a 1 year wait now, but I was talking to the US Embassy fellows for the last couple of days, and they said they will help with these kind of things. Okay, so please bring it to their notice. I wanted to say many things. Let me try to collect the next one. And I have a suggestion for my MEITY colleagues here. I think we missed sort of an opportunity to have more local industry participation in this particular event. It was very refreshing yesterday to see Vrinda Kapoor talk, and I'm sure there are many such industries in India. I would encourage you to have some kind of a workshop in India, within India. You don't have to involve overseas organizations. Within India, to get university researchers and local industries come together in a forum like this, multiple, so that they can have exchanges and they can share each other's problems and challenges and establish or start these collaborations. Yeah. And the last point I wanted to make is, that may not be the last, but that will be the last for this session. I don't want to come between lunch and you, is about the peace. There's a lot of talk about writing proposals and partnerships. Please, and Nirmala very rightly said that this is only the beginning. Both US and India are very large democracies, and our leaders, both at the national level as well at the agency level, want this to happen for a long, long time. So we are looking at long-term goals and achievements. And these kind of forums we are creating is for you to start the partnerships, not for starting to write your proposal. Okay, the partnerships have to happen first. Nirmalya mentioned that he started the partnerships in 2013. Okay, and around 2018-19, he has been successful in writing the proposals. So he is one of the prolific researchers in the US. Okay, so you cannot imagine that you're going to write a proposal by starting a partnership today. Okay, so if you start a partnership today, you are likely to write a successful proposal in 3 or 4 years' time. So please remember that. So for proposal successful proposal writing and for partnerships, you need patience, perseverance, and persistence.
The 3 Ps.
So, right? The 3 Ps.
Very good. I think you brought out a very good point. So let us, we'll come to that. Let us take you raise your hand. So how many of you are from academics in the audience? And how many of you are from government agencies, let's say MEITY, CDAC? And if you just take a look at that, it's lopsided. Because the proposal will be written mostly by the faculty and the academics in collaboration with others, right? But we see about 2/3 or maybe more than 50% from the government side and less than, and how many of you from industry? I know yesterday, of course, been the couple, it's just few, right? So I think, more academic people probably in person would have benefited because they are the beneficiary of this proposal most often, right? Because government is not funding another government, right? So I think we should keep that in mind. So there may be a lot of obstacles, but in future, I think we should keep that in mind. I think there is a question.
But we are considering R&D organizations.
Right.
Yeah, so CDAC is one of the R&D organizations, CMET and CDAC.
Right. But still, I think more academic people would have been probably better, but
yes,
it's a little lopsided. Yeah. Yes.
Good afternoon. I am Abhishek Sharma. I am from industry, IoT industry. And I have presently also driving an EU-India collaboration on smart technologies, comprising of few academic institutions, including IIT Delhi also, and some industry. My first question about the last point which you are discussing is, what is the success formula for a successful collaboration? Now the thing is, what is your criteria of success? My question number one. What do you define as success? An efficient thesis with nice everything, or something which has been resulted into a product which has good features, or finally it has gone to the public and people have, it has a good traction in the public also and it has been utilized. What is it? That is my first question. My second question is, and it has slight variation from Professor Das to Professor Mohan Kumar. He said, see, and before that I would like to say, don't you think that the relevance of need is a very important criteria for a successful collaboration? One of the most recent example is development of vaccine for COVID. There was a need, burning need, life and death issue. So it resulted into a successful research and product. So don't you think that first we have the need identification and then we start the research rather than we previously start collaboration and then think of it? It is something, I may sound little strong, but something like putting the cart before the horse. So Is it not that the need should drive it? I'm talking about applied research. I'm not talking about fundamental research. Some gentlemen talked about semiconductor, etc. That's a fundamental research area. That is number two. Third is, does the government have some kind of a system by virtue of which it invites from the market, from the field, from the industry, in collaboration with organizations like CII, FICCI, etc., as to what does the industry need, the large corporate, these SMEs, etc. Because there are many, I have gone through many a drill myself, where there's a need, particularly MSME, but they don't have resources. They cannot hire researchers. They don't have that kind of a talent also. So is there a system? And if it doesn't, I would request you that you drive one so that you have a regular forums and workshop where you compile a list of requirements, what the industry needs, and then throw it something like, I'm used to the EU-India collaboration, they throw a call, number of calls, and the people come and pick up what do they want to do. And there also it's mandatory to have an industry collaboration. So this is my second point. Is there a system by virtue of which you create a list of various areas where there is a need for research? That is my second number question. Third is the point which he said is, if we are going in this domain, that is applied research, which is need based, he suggested that as you progress, probably something new may come up. Well, it may emerge, all right, but when it comes to a focused research which is started with an aim, there is a very famous principle of what they call it, selection and maintenance of aim. You select an aim and then you maintain that aim. So third point is half suggestion, half question, is that don't you think that you first have a requirement identified, then you throw it open to the people who are interested in it, along with that, whether they have a background and strength or not, and lastly, thereafter, progress with a matrix, criteria, milestone, etc., etc. So 1, 2, 3. Thank you very much.
Multifaceted questions. So lots of questions are there.
So
very good set of questions.
So Sajal, in the interest of time, because I think we have had food for thought, but we should not also completely deprive people of lunch. I think this question is very long and there are a lot of points there, but I think we can take it offline and, or very quickly, you want to, one of you wants to answer this? There's so many points, so I don't think we can.
One is measure of success, and is requirement, customer discovery, and the third thing is that how do you keep your.
You can answer two questions. What is the success criteria? And secondly, do you have a mechanism to compile the list of requirement from the market?
Right. So just trying to quickly answer. So first is that regularly we have the stakeholders meet in the ministry for the various areas where we invite the academia, the industry, the startups, the government agencies to give their need and requirement. So based on that, we invite proposals. So recently was just an example is a NAVIC receiver that we thought that India requires for the NAVIC satellites. We invited the proposal, we have the industry which is participating, 16 lakh deployment of the NAVIC receivers. We have done through the, we are going to do through the various industries which are developing, designing, developing, and then deploying these receivers. That is one example. So we look at the problem statement which is given by the industry. We then formulate the specifications based on the input, and then we float it for the call for proposal or a RFP. So that is one. So besides taking the niche areas, we are also looking at industry participation in this way. So we are already doing it. Second is the need. Yes, need and impact is what we are looking at. When we say that impact of technology, it is based on the need only. So when there is a need, only then the impact of technology can be seen. So what is really required, whether will it be useful or not. So that is the first criteria based on which we are hoping that the proposals will be carved out for the collaboration.
Yes, similar to the what Ms. Verma has told, we also in DOT having the different scheme technology development fund is there through which we call for the proposal. We have identified some focus area in which we want to develop telecom technologies, emerging technologies, and we call for the proposal. Recently, we have got almost 500 proposals that is under process. 8 to 10 proposal has already been approved also, and this is after identification of the area in which we want to develop those technologies. For individuals also we have another scheme called DCIS. So similarly what MEITY is having, DOT is also having this kind of projects. And in general, here we are measuring success in different format, but in general I will call the success which can really some solutions which can impact lives of the human and change their problems, resolve their problems. That is the actual success. But in the terms of in terms of the project, success parameters might be different, but actual outcome has to be that one. Thank you.
So,
Thank you for your answer. Basically, should the success criteria not be quantified, maybe in terms of how much of it has translated into a product and to what percentage has the public utilization has been, because everything has to be measured.
So Abhishek, I think your questions are very well taken, and I would say in a very good sense you have challenged the audience over here and the panelists with a very right set of questions, right? Which is very good. But one thing I must say, because MC is right over there, we need to finish. So sometimes, you know, the basic and fundamental research, sometimes research goes ahead of the technology, right? Sometimes the technology goes ahead of the research, but then they complement each other and eventually come to a sync, right? Think about just iPhone. When Steve Jobs started with the iPhone, it was more like music sharing, right? You see the use of smartphone now, all sorts of apps, right? So technology came first with one purpose, now it is a multifaceted purpose, right? If you think about some of the other things, right? In many different domains, you can show even relativity theory, information theory. When it was invented, nobody knew exactly what it would be used for. They had difficult time in publishing sometime, right? So there's no unique formula, right? I think with that, possibly let us just thank all the panelists for their, and thank you all for being so engaged and asking questions, not even thinking about the whatever is the next step or lunch or whatever. We really appreciate all of it. Anything else that you want to say? Okay.
No, I think thanks to all the panelists, and there was a very good participation from the audience, and many questions we can still write to the concerned panelist or to one of us, and we'll forward.
And also at lunchtime and rest of the day, let's follow up the questions. I think let's brainstorm and find a solution. Thank you.
Well, thank you. Thank you very much. I will take a moment to appreciate our moderators first. Can we appreciate them by putting hands together, everybody? And of course, our distinguished speakers on stage. Please appreciate them by putting your hands together, ladies and gentlemen. Now, may I request Mr. S.K. Marwa, sir, kindly be on stage in order to felicitate with the token of gratitude to our moderators and our panelists. I request our moderators, Mr. Huzur Sharan and Mr. Sajal Das, sir, please come forward. Heartiest congratulations. Thank you for this wonderful session. May I request Sajal Das, sir, please come forward. Thank you for this wonderful session. I think there should be a special round of applause for moderators for conducting it in such a spectacular manner. Thank you. Now may I request our panelist, Ms. Sunita Verma ma'am, please come forward. Nirmala Roy, Suchi Guha ma'am, and Prem Jeetal. So please come forward. Now we will proceed for a group picture. Ladies and gentlemen, post-lunch session will be all about sustainability and green technologies. So it's an again interesting session. Before we proceed for lunch, let's have a group picture together with our moderators and panelists. So before we proceed for lunch, it's a very humble request. Please be back by 2:15. We will have our next session at 2:15. The topic is sustainability and green technology. It's not 2:15, it's 2 actually. Very sorry. It's 2 p.m. We're going to proceed for our next session. And the topic is sustainability and green technologies. I request you all, please be back in the hall by 2 p.m. Thank you. Take your seat and please put your phone on silent mode. Thank you. So here we come for this very interesting topic for the next session, and that is sustainability and green technologies. In order to moderate this session, may I request Dr. A. Seema kindly be on stage, and I request you, ladies and gentlemen, please help me to welcome Dr. A. Seema on floor, please. Well, Dr. A. Seema is a senior scientist at Center of Materials for Electronics and Technology, Kerala, India. She did her PhD in polymer technology from Cochin University of Science Technology. She is currently working in area of 2D materials, sensors, actuators, energy storage. She has transferred several indigenously developed technologies to industries from commercialization. Ladies and gentlemen, now I hand over the stage to our moderator, Dr. A. Seema. The topic, which is very interesting, is sustainability and green technologies. I request you all, please help me to welcome this most awaited, interesting panel discussion. All over to you, ma'am.
So good afternoon to all, and welcome to the session 5 on sustainability and green technologies and on quantum. So here we on this sessions where we have 4 eminent speakers discussing on the 3 different topics, and because of the paucity of the time, I request all the distinguished speakers to keep their timing, just cut short 5 or 10 minutes and keep the timing for 30 minutes. So I would like to first invite the first speaker of this session, that is Dr. R. Radish, and he is the Director of Center for Materials for Electronics Technology, CMET, Hyderabad, and he is a well-established, distinguished scientist in the area of communication technologies, and he is the lead PI on the e-waste recycling, and we have a center of excellence on that, and he is a visiting chair on urban mining for sustainable and circular economy. So I request Dr. R. Radish to come on to the stage, please. The floor is to you.
Can you make the presentation visible? So good afternoon all. At the outset, I thank MEITY and NSF for giving an opportunity to share our research, especially on sustainability and green technologies. Thank you, Dr. Seema, for introducing. So I'm from CMET. We are under Ministry of Electronics and Information Technology. The vision of CMET is to become a premier R&D organization known all over the world for its knowledge base, innovation, and expertise in electronic materials. We do have 3 centers. Our headquarters is at Pune. Pune is mostly working on LTCC material, quantum materials, lithium-ion battery. And the laboratory from which I come from, we are into electronic waste recycling. We also work on high purity materials, also semiconductor materials. I'll just touch upon all those things. Whereas the laboratory at Thrissur, where from Dr. Seema comes, they are into electroceramic materials. So these are the thrust area of our laboratory. You can see that we do requirement-driven research at CMET laboratories. We produce, to be candid, we follow Fraunhofer model research at CMET. For example, the entire hafnium required for the countries manufactured inside our campus. This again is sustainable technology. You know that there is no definite ore for hafnium. We take the effluent of zirconium protection and we extract hafnium from that, which is one of the very best gate oxide material for semiconductor applications. We work on silicon carbide wafers, high purity materials for strategic applications, Navic antennas. We also into permanent magnet. Then the topic of today's discussion, sustainability. We have a center of excellence on e-waste management. And going forward, if you look at the Thrissur laboratory, we are into IoT sensors. We also work on electronic packaging, renewable energy, and nanomaterials, especially 2D materials. I'll come back to it, whatever is relevant for this particular conference. And Pune, we are into rechargeable battery. We have a center of excellence on rechargeable batteries, especially lithium-ion battery. We also work on additive manufacturing, and the third CO is on quantum materials. And we also have the first foundry on LTCC at CMET Pune. Let me start with our material research, green technologies, and I'll see that how we make it in sustainable. So first, let me start with the semiconductor vertical. You know that we have 5 verticals here, and I'm happy to share with you that we are into all the 4 verticals except cybersecurity. Let me start with semiconductor material. So in the previous speakers has made my job very easy. They have set forth a very good platform for me because there was a lot of leapfrogging technologies has been discussed in the morning, like 5G technologies, MIMO antennas, then 6D technologies. But all this starts with materials. The foundation of any technology is development of critical materials. So we do that. So I'm going to showcase you one of the critical materials where the technology is available only with handful of countries. This is semi-insulating silicon carbide. You know that silicon carbide, N-type silicon carbide is used for all EV vehicles and all that, but developing a semi-insulating silicon carbide for high mobility transistors was a very, very challenging task. And it's also used for 4G and 5G communication as radar antennas. This is the facility which we have created thanks to DRDO. We work very closely with DRDO to establish this facility. This is the first physical vapor transport reactor in the country. This has come from Germany, and we do have a separate building for that. And before coming to that, like the very essence of this kind of research is that you need to come out with basic research. Like, you need to do a lot of simulation to come out with establishing the process methodologies for, developing this kind of single crystal growth. We have a virtual virtual reactor program, wherein do a lot of simulation to arrive at the process condition. What is the temperature required? What is the pressure required at the core? And also what is the time which is required to arrive at? Because we do design of experiments. Because of the paucity of time, I am not going to that. Because the graphite furniture, its contour, everything is very, very critical to arrive at the optimum results. You can see that this is the silicon carbide ball which we have grown in our laboratory, and the wafers, the semiconductor grade wafers which we have developed at our laboratory. So you can see the properties of semi-insulating silicon carbide single crystals. We have got an electrical resistivity of 10⁶ ohm centimeter in a 2-inch bowl. We are going to ameliorate this technology. We are going to scale up this technology to 4 inches and 6 inches. Now the challenge is, what's the country requires? We need to go for device fabrication. Like as I've told you that we have reached at wafer stage. Now we need to think about growth of epitaxial layers, and we want to translate them into devices. So how to go about that? This again comes under semiconductor vertical. As you know that the country is all set for establishing India Semiconductor Mission. We have done a very important mapping of the input materials or material supply chain required for semiconductor ecosystem. We found that we require more than 240 materials which is required for fabrication of semiconductors. One of them are gallium, so very recently China has put a rider on export of gallium because 80% of the gallium is produced by China. So we are now trying to see that how we can mine the gap. So there are ways and means to do that. One is urban mining. We are also trying to see that how best we can extract gallium from red mud. But what is important is not the input material. We need 7N purity, ultra high purity gallium for this kind of work. So we have already developed a technology for purification of gallium up to 7N purity, and we are now going to translate them into gallium nitride epitaxial layers. And like that, we have developed number of products, especially zinc. We do have cadmium and tellurium. The cadmium and tellurium produced by us is going to, defense for night vision cameras. We also make 7N purity germanium for radiation detectors. Many of these technologies, including the equipment, is custom fabricated. Everything is indigenized, which is protected by IPRs. Now, this is what I was talking about. This is a Fraunhofer model research where we have taken the technology up to technology readiness level of 8. We cater to the entire hafnium required for the country. This is especially for aerospace application. Neobate alloy is used in rocket thrusters, and it is also used as a control rod in nuclear submarines. I'm not going to talk about that. I'm going to address how I can use hafnium for semiconductor applications. As you know that as the node size comes down, you need to have, other than silicon oxide as a gate oxide material, through electron beam melting, we have purified this hafnium, and we have made hafnium targets for gate oxide applications. And now morning we had an interesting discussion on 5G and 6G. And one important thing what we need to understand is that many of the base materials, especially printed circuit boards required for this kind of applications, are even today we are importing from foreign sources with exorbitantly high price. For example, the substrate which I have shown here, this is a proprietary product of one of the foreign companies, and the cost of 1 square feet of this material is $260. So I understand that for most of the 5G design, they are not using such kind of materials because its loss tangent is very, very less, but it's too expensive. So they are importing, some of the substandard base substrate from China and Korea. And because of that, their efficiency is not up to the mark. This is one of the things which I have noticed from one of the industries who manufacture 5G antennas. What we have done is, we have not only developed these materials, we have developed a different kind of products out of that. What you see here is a 5G MIMO antenna developed on an indigenous substrates. One of the things which we understand from this kind of substrate is that there are only 3 or 4 products available in the market with the dielectric constant. If you make an innovative design, copycat is very much possible. People can very easily duplicate it. What we are doing here is, we are developing proprietary printed circuit board, and we are making different kind of substrate with that. So, but the problem here is, why sustainability comes here is that we are now going from GPS to Navic. India is the 6th country in the world which is having local regional navigation system. So the estimated requirement of Navic antenna in the country is 80 million. When I start making such kind of numbers, I have the responsibility to recycle it or do it in a sustainable way. I'll talk about it a little later. So another very important thing which I want to bring to the August audience here is that so you don't need to have this kind of collaboration to come out with novel research outcomes. We are talking about 6G communication. One of the basic requirements of 6G is that we are not identified the frequency, we are not identified the materials required for that. Whereas, what we noticed almost in 2018, that many of these materials, whatever we use currently, when you reach certain frequency level, there is a dielectric dispersion. Its dielectric or loss increases with respect to frequency. That's the reason we are difficult to go beyond certain frequency level, especially in millimeter wave. Millimeter wave is not explored so far because of dearth of materials. You can see this research, which is initiated with the Oulu, University of Oulu, University of Warsaw, and Korean Institute of Ceramic Technology. What we have noticed is that irradiated silicon, if you can put in polypropylene matrix, its loss tangent comes down with respect to frequency. So this kind of materials can be used very well for 6G applications. You see the outcome of that. The NASA has called us for a discussion. By seeing this literature, NASA has called us for a discussion that how best we can utilize such kind of a technology for deep space application. And this product is also qualified by Fermi Lab for high power applications, high power solid state applications. This is another technology which we have developed by CMET. This is for space communication applications. Almost 1,000 numbers of BMT ceramics are used in every satellite, INSAT 13 onwards for X-band communication application. Now I'm coming to the last, but this is, terahertz, which is less explored. After millimeter wave, you have terahertz frequencies. You need materials to explore terahertz materials. So as I told you that we are one of the lead institutes in the country who develop high purity materials. What to do further with these high purity materials? What we have done is we have grown zinc telluride single crystals, which is a very good terahertz generator as well as a detector. So you can see the Lavoie pattern, and this is grown across 1 on 0 axis, and it can be very well used as a terahertz generator, and it can be used as a terahertz detector. And the graphene materials, which is developed at CMET Trishu, that also can be explored for terahertz generation. Now we are also into permanent magnet production, because most of these NDFUV magnets are being produced by China, because rare earth, most of the repository of rare earth oxide is with China. I'll come back to you why I'm projecting all these technologies, because we need to find solution for sustainability of them also. Another technology which we have developed at CMET Pune is on lithium-ion battery technology. We have developed variety of batteries, including flexible batteries for automobile and other applications. And coming to the sustainable technologies, additive manufacturing is one of the sustainable technologies wherein most of the plastics which we have used, which can be utilized for making filaments for additive manufacturing. Again, this work is being done at CMET Pune. And we have a National Center on Quantum Materials Technology at Pune, where we are working on different kind of materials for developing qubits for quantum computing, diamond, SNSPD, 2D materials, so on and so forth. So this is the India Innovation Center for Graphene, which is in line with this Graphene Institute at UK, where we are trying to see that how best we can utilize graphene for different kind of high-end application, including terahertz. So we do work on IoT sensors, we work on plasmonic sensors. So I think you got a feel for it, what's the kind of technologies we develop. Now the thing is that how we can make this technology sustainable. Like as you know that UNS set for the goal 2030, the agenda for sustainable development. So what we noticed is that almost more than 6 of these goals, whatever is set forth, are falling under this kind of sustainable technologies, especially on recycling of this material. So now I'll take you to the fascinating world of resource efficiency and circular economy. We have been asked to set up a center of excellence on e-waste management, which has 3 key pillars: industry ecosystem, innovation ecosystem, and capacity building. This is not a government-sponsored project. This is a private-public partnership wherein 40% of the stake comes from MEITY, 40% from government of Telangana, and 40% from main industry. And we have to develop a variety of technologies to address the entire needs of electronic waste which is generating. So fortunately, we got world's 3rd largest renewable energy producers, Mrs. Greenco, as our industry collaborator. This is a 10,000 crore company, turnover company located at Hyderabad. They have 10,000 acres of solar cell installation in Kurnool. So what they want to do, currently we follow a linear economy, take, make and dispose of technology. I always tell that, loot and pollute Mother Earth. Like, from there we need to go to a circular economy model where everything will come for further production, because India is the 3rd largest, raw material users in the world. So until otherwise, the secondary raw material comes in the production chain, we cannot go further with further development in production. So I am going to, because now, so far I talked about different kind of technologies. You will see in these 5 verticals, most of them: lithium and battery, permanent magnet, printed circuit board, solar cells. All these things are now put under these verticals, because now we are finding solution for recovery of value chain from that. For example, if you look at the lithium and battery recycling technology, China produces more cobalt from recycling than mining, because this ore of cobalt is only available at Congo. So the first and foremost thing what we noticed is that this is a very viable technology. Sufficient raw materials are available. You can recover 98% materials through recycling, and its purity is 99%. So that means we are recovering, electronic or battery grade, secondary raw materials from that. And last vertical is also very, very important. This is skill development. We have more than 12 startups working with us. And one of them is a very young boy from Indian Institute of Science, and he is developing a technology which I showcase you a little later. We also started an MTech program with the Indian Institute of Technology, Hyderabad. The first technology which we nurture is on PCB recycling. I've told you that my expertise is on PCB development. So, but at the end of the day, I need to find solution for recycling of that also. We have developed an end-to-end solution. If you go for a hydrometallurgy technology, I wouldn't call it as a recycling technology because you are getting only value chain from there. All the contaminants, including silane coupling agents, furans, everything is lying on the base material there. This is an end-to-end recycling, wherein this is a smelting process through which we recover black copper from that, all valuable metals. And this technology is environmentally benign. You need to certify this from a CPCB approved agency. And this is one aspect. Recovering valuable metal chains from this is one aspect. But when you process 1 ton of PCB, you will end up with 700 kilograms of slag. What do you do with that? There also we applied circular economy. This is too grand challenge. We want to inventive ideas with immense impact. We have given this work to, this spin-off work to other institutes, academic institutes. This work is done with NIT Warangal. We have converted this slag into payment blocks. And interestingly, this can be used as a micronutrient also. We have filed 2 patents on this technology. Now, coming back, the sustainability, why it is not taking off, this because of non-availability of many of the machinery. We realize that we need to look at that also, because these smelting furnaces, top-load rotary furnaces are imported from mostly Italy, and it's exorbitantly expensive. We started developing. This is a equipment which is produced by us or fabricated by us through our own vendor. We do have the IP rights available with us. And we have also come out with automated depopulation system by artificial intelligence. Because when the PCB becomes obsolete, many of the components, semiconductors in it can be further utilized. So through artificial intelligence mechanism, we are trying to locate them like multi-layer capacitors, which contains a lot of palladium in it. We are recovering it, but because of the paucity time, I cannot explain it. What I want to tell you is that we have a turnkey solution for printed circuit board recycling. And next technology which we are nurturing is on lithium and battery. You know that we have a COE on lithium and battery. We have developed 2 different technologies. One is based on hydrothermal technology. This is meant for big players. Whereas we also developed a pyrometallurgical technology which is meant for SMEs. And we have filed 2 patents. You see, look at the mass balance, how beautiful it is. When you have 100 kilograms of lithium and battery, and you can extract 48 kilograms of black mass from that. And currently, what is happening is that tons and tons of this black mass is sent to Korea for recycling every day. That means the resources are going abroad, and we are again getting it back as devices from foreign countries. So what we do is, this 48 kilograms of black mass, we can extract 4.5 kilograms of lithium carbonate, 13.5 kilogram of cobalt oxide, 3.5 kilogram of nickel oxide, and 10 kilograms of manganese oxide. And we can make new batteries out of that. This is a complete circular economy chain as far as lithium and battery is concerned. This was a low-hanging fruit. See, we have started working on this only 2 years back, but in a single day, we could transfer this technology to 18 industries in the presence of a Chief Executive Officer of NITI Aayog. So we are now training till next March. We have industries which has already blocked our dates. Coming back to spent permanent magnet recycling, we are totally dependent on China for permanent magnet. When the concept of EV vehicle is going to come, you need to have more than 2 kilograms of permanent magnet in every vehicle. But neodymium oxide is very expensive. That is one thing. I'll also touch upon the environmental aspect of that. If you want 100 kilograms of neodymium oxide, you have to process 10,000 kilograms of monazite. So it creates a lot of environmental impact. So we realized that with 450 kilograms of permanent magnet, we are able to produce 100 kilograms of neodymium oxide, which can be further used for permanent magnet manufacturing. This is one approach which we are doing. Next is inland with a concept which is being implemented in Europe, which is called Sustainable Magnetic Program. You take the magnet as such, do hydrogen decryptation, then modify its composition and come out with a new magnet. We are trying to implement these two processes in our institute for permanent magnet production as well as recycling. And sustainability solar cell is a very, very important area. Thousands of installations are coming because we have a commitment of 2070 COP23 commitment also. So what we are trying to do is that we are developing a technology which is a mixture of both mechanical, chemical, and thermal processes, wherein we can recover all this value chain. We can recover silicon in the form of high purity silicon, because once we recover it, we will also purify it to almost 5 to 6 purity, so that if you have a plan to make silicon, especially electronics grade silicon, we can use this as an input material. Currently, almost 63% of electronic grade silicon is manufactured only by Japan. So this is another thing which we are working on. And I was talking about a startup who joined with a young boy who is from Indian Institute of Science. I offered him a PhD position, but he refrained from accepting that. He told that I have been put at sense for semiconductor fabrication. I realized that they are using many corrosive chemicals for developing that. I want to work in the resource efficiency or recycling area. So he came out with an innovative solution for LCD display. Our LCD contains a lot of valuable materials in the form of liquid crystals and indium. He has developed a technology for recovery of these liquid crystals for further utilization. Currently, this display devices are considered as hazardous waste. It is picked by hazardous waste recyclers and it is going for such kind of an disposal. Whereas this boy has developed a technology, he is going to start an industry in Hyderabad for recovery of this valuable value chain from our display devices. And another very important problem which we need to address is CFL recycling. Countries not taking any steps to address this problem, because CFL contains 2 to 3 milligrams of mercury. And if you dispose of 2,000 CFLs per day in a landfill, it can inject 50,000 liters of drinking water. What we found that the fish which we have collected from ponds in Hyderabad, the mercury levels are much higher than the allowed limit. So we need to find out a solution for this. We do have a recycling technology for CFLs. And as an institution, we work on ROHS complaints, because before instead of talking about hazardous materials, we need to come to reduce that. One of the themes is that we need to develop green technologies. If you look at the ROHS compliance of Japan and Taiwan, they have different kind of color codes. You can make a technology which is environmentally benign. They will give a green, symbol for that. Otherwise, it is orange and then, red. So we need to adopt such kind of technologies to make them green. And coming to human resource development, as I told you, I'm very, very happy with that, because we started the first MTech program in India on e-waste management. It is called e-waste resource engineering and management, jointly with the Indian Institute of Technology. This is the 4th batch which is going on, and all the students who have passed out got job in core industries. So I've finished my presentation, but I'll just take 2-3 minutes with the permission of the chair to showcase the work done by our sister organization, Samir, what they do on, I talked about materials, but what they do on energy proliferation. So under energy generation, energy storage, energy utilization, and power electronics, they're doing wonderful job. We have senior or head of the Department of Power Electronics here from Trivandrum, CDEC Trivandrum. They are working on national mission on power electronics technology, which is established with different stakeholders. You can see the number of stakeholders there. This is under the thematic area of NAMPET, smart grid solutions, PE devices, real-time simulators, e-mobility, power quality, and green energy. These are the things. And interestingly, they have already identified what are the present scenario, technology gaps, and what is that future roadmap in line with the National Science Foundation objectives. So I'll showcase you what are the technologies which they have developed. They have developed power electronics for distributed generation. This is a project funded by MNRE, and this is power generation with lower wind speed, power exports to USF and minimum TDD in grid current. You can see the digital controller and 250 kilowatt proto unit which is developed by them. And apart from that, they have also developed distributed generation for solar, kilowatt to megawatt scale for solar PV power plants. These are the features of that capability to ride through faulty and distributed grid conditions, voltage stabilization. You can see the devices which they fabricated under this scheme. And there are hybrid renewable power plants also is established at some of the places. This is in West Bengal, what I understand, and they are also into microgrids, different kind of microgrids. These are microgrids installation at Moshani Island in West Bengal. This is the installation wherever like you don't have power, like so like islands or forest area, they have implemented hybrid microgrids, and these microgrids are tribal settlements. This is off-grid microgrid at tribal settlements. This is LVDC nano grid for building and special applications. So if you have any queries, my colleague from CDAC will answer your queries. Thank you so much for your kind patience.
Thank you, Dr. Radish, for giving us a very scintillating lecture and walking us through many of the indigenous technologies. We will take the questions at the end because the next speaker is having already another assignment, so you would like to have that talk right now. So we are moving on to the third talk. So it is on the overview of the Center for Quantum Technologies, and it is being taken by Gerardo Ortiz, Professor of Physics, Indiana University, and he is also the Scientific Director of Indiana University Quantum Science and Engineering Center and Indiana University Site Director of this Center for Quantum Technologies funded by NSF. So I hope that he is connected already. Okay, so there is one more speaker. Yeah. So both of them together are walking us through this overview of Center for Quantum Technologies. So the second speaker in that is David Stewart, Purdue University, and he's the Managing Director of the Purdue Quantum Science and Engineering Institute. So I welcome both for this talk on this overview of the Center for Quantum Technologies.
Thank you very much. Can you all hear me okay? And screen showing okay? Okay, excellent.
We can see your
good
screen.
Morning.
You can continue.
Great. So good morning here from the United States. Good afternoon to you all there in India. We're very honored to be able to give this talk today. I'm David Stewart. I'm the Managing Director of the Purdue University Quantum Science and Engineering Institute. And I also serve as the Managing Director and Industry Liaison Officer for the Center for Quantum Technologies, which is an NSF-funded industry university cooperative research center. So I believe you got an overview of this program yesterday, but some of this may be a touch redundant, but bear with me, and I hope you enjoy information. So our Center for Quantum Technologies is a partnership with Indiana University, the University of Notre Dame, and Purdue. It involves both the Indianapolis and Bloomington campuses of Indiana University. So we got a planning grant for our center in May of 2021, and then we are awarded our full phase 1 center just over a year ago now at this time. So industry university cooperative research centers are a program that's been funded by NSF for over 30 years. They work to catalyze pre-competitive use-inspired research by enabling close and sustained engagement between industry innovators, world-class academic teams, and government agencies. And they really have three primary objectives, which I have listed there, which are conduct high-impact, use-inspired university research to meet shared and critical industry needs, to enhance U.S. global leadership in driving innovative technology development, and to identify, mentor, and develop a highly skilled workforce, which for quantum is critically important right now. So this is a little bit of work of how IUCRCs work. NSF catalyzes by providing funding, helping to bring folks together. The universities have the world-class infrastructure in place, human capital, technical expertise to do the research, and then the industry members provide funding for the research efforts and really help us to guide the redirection of the center. So our work kind of falls right there between early stage research and commercial deployment, and we hope to perform cutting edge pre-competitive basic research in quantum technology development. So this is our leadership team. Purdue is the lead site for this center, and our overall center director is Professor Sabri Kais here at Purdue. He's professor of chemical physics. Professor Ortiz is with us on the call, who will give a more detailed overview of the research efforts of the center at the end here today. He is professor of physics at Indiana University and the IU site director. And Peter Kogi is at the University of Notre Dame, who is a professor of computer science and engineering. And then I mentioned that our IU's Indianapolis campus is also participating, and Professor Ricardo Deca there leads the efforts at IUPUI, which is somewhat of a joint campus between Purdue and Indiana, but under the Indiana Board of Trustees at the moment. And then I serve as our industry liaison officer, kind of the connection between our industry and government members, and also manage the general operations of the center. So here's our timeline. We've been in this process for a while now. So we really came together starting planning almost 4 years ago now, late 2019, early 2020. I've held several workshops along the way, one in June of 2020, to really give us an idea of what our industry members were looking for. We submitted our planning grant proposal that fall, and that got awarded in May of 2021. And that gave us some funding to really do training and to do potential member discovery. So we learned a lot of best practices, and then also did interviews with over 80 prospective members in order to really learn what the needs and interests of our potential members were. So held a meeting that fall where we all came together, and then we submitted our phase 1 proposal based on the feedback we got from our prospective members at that meeting. So as I mentioned, that was awarded in August of 2022. We held our inaugural meeting where we had our project selection for the center in February of this year, and then finally launched projects in May of 2023. So it's been a long process. We are excited to now be officially doing research within the center. So you may have heard some of this already yesterday, but the IUCRC framework has members that include for-profit organizations, non-for-profits, and government agencies can also join. In our center, it's primarily for-profit industry, but we also have a couple of government members. The IUCRC has an industry advisory board with one representative of each of our members, and then they all sign a single membership agreement that's approved by NSF. And the really unique aspect of these centers is that the members fund the research projects and actually get to select the projects of the center in a collective voting process that's defined in our bylaws. So Our center has annual membership fees of $50,000 for a full 5 for an associate membership. Only difference in those is that you get a half a vote when it comes time for project selection as an associate member. And so NSF provides all the funding for our admin and management costs. That's for staff salaries, for conducting meetings and traveling. Our members provide all the funding for our research efforts. And with that, there's no overhead charge, which is great. We get to do about a third more projects than we would be able to do typically with a one-on-one sponsored project. So that's fantastic for us. And then the universities have the world-class infrastructure in place and the people to conduct the research. And out of that, our members gain access to the pre-competitive research results and our highly skilled workforce that we're developing. So there's significant value in these centers for the members. Access to talent is one of them. One great statistic that NSF likes to show is 25% of IUCRC students eventually become employed by the member companies. So there's lots of great interaction between our students that we're developing and our members. There's R&D risk mitigation because bring those risks of early stage research with your peers, the other members within the center. Lower research costs. We already have great infrastructure in place, and certainly much cheaper to fund a graduate student than to hire a brand new employee of your own. And then because our members are pooling our research dollars, there's significant leverage there on the investment. Networking opportunities to learn both from the academics, but also the other center members, the industry peers within the room. And then all of our members get royalty-free, non-exclusive licenses to any IPs produced in the center. But I mentioned the significant leverage on our investment, on the investment of our members, and I just want to expand on that a little bit. Our full membership level is $50,000 per year annually. We currently have 10 fully equivalent members, so that comes to $500,000. NSF puts $150,000 a year, so we have a really total center funding of $950,000 each year. So a $50,000 membership leverages $900,000 annually. So currently an 18-to-1 leverage, and we hope that continues to grow as we continue to add members. I also like to point out that there are several additional supplemental funding opportunities. One of those is through the NSF's intern program, where NSF will provide up to $55,000 per student for 6 months for our students to go work at our member companies. So a great opportunity, not only for our members to get students there, but for our students to really train in real world situations. So this is sort of our annual tempo of the center. And I'd like to sort of start at the bottom yellow square where we had our spring meeting this last fall. That's where our center members come together and actions will be funded. And so this first year we had 15 projects that were pitched to our IAB members, and then in the voting process they selected 7 of those to be funded for the first year. So those projects start. There's continuous dialogue throughout this whole year with our industry advisory board. Each project has several mentors assigned to it and government members who provide feedback and guidance to our researchers' meetings. And then we just recently, about a month ago, came together for our fall. We not only did a review of the projects currently underway and got feedback on those, but we also worked with our industry members to really plan for the research directions of the future of the center, and which will help define the project proposals that will be presented in our next spring meeting. So our projects were refined based on the information feedback we got from ours. And then these projects will be completed. They can be recompeted for funding, but we will also have new proposals come in. So throughout this process, as you could tell, there's constant interaction with our industry members. So they really help us to determine and drive the research direction of the center. So lots of words on this slide, and I don't want to read everything, but our center is addressing the needs of industry and government members. We're trying to foster the development of practical and impactful quantum systems that can be integrated into future technologies via collaborative interdisciplinary research. And so I just want to highlight that across our 3 universities, we have over 100 faculty working in some area of quantum information science. So we're really touching all corners of the field, which is great because it gives us extreme flexibility in being in allowing us to meet any specific need that our industry members have. So this is our roadmap that we developed for our phase 1 proposal. It may be slightly tweaked here as we continue to refine our research themes based on the feedback we got on our most recent meeting. But our center really focuses on these 5 key research areas. They are algorithms and architecture, quantum materials design and chemistry, quantum communications and networking, finance and business, and quantum sensing and hardware. And these fields are so intertwined, right, that doing research in one specific area may impact multiple of these different research areas. So that's just an inherent nature of quantum technology development right now. But really, you can see on the left there, we want our research areas within the center to overlap between where our faculty have expertise and what our member needs are. And out of that, we hope that our members really get world-class research results, get access to this highly skilled workforce that we're developing, and ultimately leads to state-of-the-art quantum technology development. So quantum is extremely important for the U.S. It's our center is going to directly follow several of the efforts that were described in the National Science and Technology Council's strategic overview for quantum information science, which was released 2018. So some of the key efforts that are certainly relevant to our center are listed here, which are to focus on a science-first approach, which is academic research institutions were certainly doing. They want us to build a quantum smart and diverse workforce to really meet the needs of this field. There's an extreme shortage in quantum talent right now, so we're helping to really drive workforce development in that area. And then, by the nature of the center itself, it encourages industry engagement and getting that use-inspired projects and research that's critically important right now. So we are growing a great quantum ecosystem, building collaborations and partnerships, knowledge, and helping to grow the next generation quantum workforce. So this is our list of committed members: AFRL, AWS, Cummins, which is an engine making company based here in Indiana. D-Wave is a quantum annealing computing company. Lilly, a large pharmaceutical. Entanglement is a smaller company focused on quantum AI and machine learning. Hewlett-Packard, the Naval Warfare Center at Crane, one of Navy's NAVSEA centers. Northrop Grumman, Quantum Innovative Solution, a niche quantum computer company developing quantum software and middleware. And then Crypt is a post-quantum cryptography company, and then Toyota. So we have a great group of members that range, from defense contractors and DoD to pharmaceutical to automotive industry to quantum computing software and hardware companies. So we really love the diversity of our membership, and we hope that we continue to grow here in the future years. So there are several opportunities for international collaboration within these centers. NSF offers international supplements. And so these foster collaborative work with leading international research entities. So the international partner obtains their own industry funding to support their proposed projects. Has to be at a level comparable to what's already ongoing within the United States IUCRC Center. And NSF will then provide up to $25,000 expenses related to this international activity. So these could be research visits by center faculty and students, for example. So these do have to be approved by NSF and both our industry advisory board, but there is a mechanism in place to be able to foster these international collaborations. And we can also have international industry advisory board members as well. It's easy if they already have a U.S. employer identification number, but organizations without these can be approved by NSF, and of course, any new member has to be approved by our industry advisory board. So with that, I just want to show these are our list of year one projects within the center. So you can see we have a good mix of representation from all our key campuses, as well as good representation from all the different research themes within the center. So we're very excited about the research projects within the CQT. And with that, I will stop sharing and hand it over to Professor Gerardo Ortiz, who is at Indiana University and is our site director there. And he will get into more details of the actual research ongoing in this center. So there we go.
So I hope that you are seeing the slides. Are you? Yes. Okay. So good afternoon, everybody. My name is Gerardo Ortiz, and I'm a professor of physics at Indiana University. And my goal today is to explain the science behind the Center for Quantum Technologies, and at the same time, illustrate how is that the industry-university interaction works, okay? So as David mentioned, I mean, this is a quite interdisciplinary field of research where expertise from, a broad spectrum of sciences are required. I mean, this science includes physics, chemistry, computer science, engineering, all kinds of engineering, mathematics, business, even psychology. Okay, so before I start telling you a little bit about the specific proposals or value propositions, that's the name that we give, let me tell you a little bit what is quantum information science and technology, and in this way you will understand why is that this is an important field of research. So this field of research, indeed, what it does is to exploit the fundamental laws of quantum mechanics, basically to solve problems in a more efficient way, if you want, or acquire functionalities that goes beyond what we have learned in classical physics, okay? So it turns out that some of these properties of quantum mechanics that are attached to something called, state superposition, meaning interference effects, entanglement, that entanglement is a key property of quantum mechanics, and this measurement itself, okay, this we can exploit to our advantage. And indeed, this is at the heart of quantum information science and technology that differs from other technologies. Indeed, I mean, this is something that started, a few decades back. It's not new. But, I mean, just recently, it has driven, a revolution in computing, in communication, sensing, and other fields. So having said that, what I want to tell you now is essentially how is that this industry-university interaction works. So first of all, as I mentioned before, I mean, this is a quite interdisciplinary field. And as you can imagine, these 4 universities forming the center, they have lots of faculty working on all these different fields. So our center is, covers more than 100 faculty working absolutely in every single aspect of quantum information science and technology. And as David emphasized, we cover almost the whole spectrum. Of course, it's not the whole spectrum that we can show to the industry, but the guiding principle is that we essentially have our own ideas, okay? So this is what is called pre-competitive research. We have, I mean, the university, the center has its own idea, and we try to select those ideas that are of shared interest with the industry. Okay, the industry have very focused ideas about specific things, like, for example, building a quantum computer, for example. Okay, and the whole point is that you want to find, pathways to apply in commercial research and development. So that's the whole thing. So you are not trying, I mean, to do fundamental research at the most fundamental level, okay, but you are trying to find, some sort of application to what you are doing. So the whole point of this is to create a community that interacts between industry and academic partners, okay? So the way it works, and this is the way I will illustrate the thing, is I will illustrate, I mean, in the last cycle, I mean, this past year, how is that this process has worked. So we had a meeting in the spring, and based on our interactions with the industry, we showcased 15 presentations, 15 projects, okay? And of course, there were other, posters that in some way were complementing or they were extending those presentations. So they were selected according to this interaction with the industry. And, we try to accommodate, I mean, the national labs and industry needs. So the point is that, as I mentioned before, indeed, I am not showing in, let me see. Indeed, we have, given the multidisciplinary character of the field, we have essentially chosen 5 kinds of categories that indeed these categories are not necessarily independent, okay? And they have indeed all kind of overlaps. Okay, as you will see in some of these projects, what are these overlaps is very important. So let me start explaining what are, the 15 projects that we presented in this spring meeting. These projects
Gerardo?
Yes. Yes.
You're in presenter mode. I don't know if you can make it larger screen for folks.
Okay, so let me then change. Is that okay? But the problem is, that you are not going to see the 15 projects.
Go to your full screen again, maybe.
Full screen?
Or presenter mode.
Oh, let's see. Let me see. So you're saying that's not working. So I'm a Keynote guy.
Maybe try swap displays up there.
You can put your slides in the PowerPoint mode, sir. At the bottom, you can see that icon for PowerPoint. Yes.
Yeah, but this is what he's saying is a presentation mode. Can you see the slide? No.
They're small.
We can see the slide, but it is in small size. So otherwise, you can go to the full screen mode.
Okay. Is that okay? So the only problem is that you are not seeing. Okay, but I can say what it is. So these 15 projects have been organized according to these 5 categories, okay? And there were essentially, some projects that are algorithmic or architecture projects, like, for example, quantum computing playbook, okay? I will explain a little bit more about these projects, okay? There is security and finance and business, okay? There is material design and chemistry, quantum sensing, hardware, and communication and networks. So there were 15 projects, okay? And I will explain better these things, these projects. And let me go through some of these projects. And essentially, I have colored those projects that are involving mostly software and the projects that involve hardware, I have a color in red. Okay, so then, as you can see, these projects are diverse, okay, and very diverse. For example, you know, the three algorithmic projects that are more software oriented, one of them is trying to essentially take all these NIC devices. NIC devices are, you know, what now they call, you know, quantum computers, but they are not quantum computers. They are noisy systems, okay? They don't have error correction. And essentially what this project is trying to do is to take all these different devices and is trying to benchmark, okay? Trying to benchmark like a sort of, you know, quantum top 500 thing, where essentially one is trying to compare all these different devices as a function of noise, topology, coherence time, you know, compilation, et cetera, et cetera. So there are indeed other proposals, but you know, in this line, but the one that has been chosen by the industry has been precisely this one. Okay. Now there are, you know, other proposals that are also software, but is the goal is different. The goal is applications in security, finance, and business. Okay, and for example, these two proposals here, one that is based on optimization problems, combinatorial optimization problems for business application, okay, for finance and business application, and another project that is based on security, on cybersecurity, post-quantum cybersecurity proposal. So there were other proposals that were in the context of material design, you know, designing smart quantum materials and chemistry. And I will just only highlight out of these proposals the one that have been chosen by the industry. And these two proposals are that have been chosen are of a different character. One is trying to define or develop some sort of single photon emitters, okay, out of ferromagnetic materials. So there is a need to generate single photons on demand, okay? And this is a potential technology that the industrial members are interested in. So there were also a different type of proposal that is trying to develop quantum sensors. And this I will explain a little bit more afterwards in such a way that you can see what is the interaction between industry and these centers. So then there were others on quantum sensing and hardware. I mean, and these are the two that have been chosen. And again, there is another kind of technology trying to develop single photon emitters, but in a different class of materials, that is in silicon nitride, for quantum communication, computing, and simulation. Okay, so having said that, I mean, there were these 15 proposals. These 15 proposals you know, have been analyzed and scrutinized by the industry, and they decided to choose 7 out of these 15. And these 7 essentially, as David already showed, involve different things. There is software, there is hardware, there is more something on, you know, communication, there is something more on materials, something more on quantum computing, etc., but there is a lot of overlap between them, indeed. So now, let me go through one particular project that I have highlighted here, that is materials for future quantum architectures and co-design, where I will show you how is that this works, okay, in reality. So remember I told you that there was a selection process in the fall meeting, and indeed we have of the order of 5 months, okay, to work before we have the spring meeting, okay? And in these 4 or 5 months, I mean, these different groups have been working together, and indeed, they have been essentially trying to develop the value propositions. So let me now go and explain how is that this process works in a very particular example. So this corresponds to the design of a new quantum sensor, okay? So this quantum sensor essentially is exploiting a particular property that is called a topological property, and in particular, something that is called a magnetochiral anisotropy. Okay, so the idea of exploiting this particular topological property is that we can tune our our quantum sensor close to a critical point, and when we are pretty close to the critical point, we get a high sensitivity. And a high sensitivity to what? A high sensitivity to very tiny magnetic fields and very tiny electric fields. So you can imagine how is that you can use these sensors. And the whole point is this is a very complex process where you need expertise in many different directions. You need expertise of people doing theory. You need expertise on people trying to construct these devices, okay? And indeed, this is an enterprise that involves something like 20 people, okay? So 20 people from 2 different universities in this particular case, and there are some people doing theory. For example, they are doing density functional calculations where they are trying to look at particular materials with high magnetochiral properties, okay, and isotropy properties. So, and then there is another group that is trying to grow this material and grow and construct devices. Of course, these devices need to be characterized, and this requires another set of skills. Okay, so during this 5 months approximately, I mean, these different groups have essentially already constructed advanced structures, selected the material, constructed these quantum devices, and indeed the characterization still is not there, but these results have been presented during this spring meeting, and we have interaction from the industry. So the industry saw these results, and the industry essentially interacted with us, and the industry essentially told us, okay, it would be nice that if you want to characterize this in a particular way, we have some industries, okay, we have some machinery that you can use. So you can come to our labs and you can essentially use our machinery to characterize your material. Okay, so this is an example. I mean, I think that my time is already over, so I will stop here, but I hope that I gave you just a broad picture of what is the science and the exciting science of quantum information science and technology. Okay, thank you very much.
Thank you so much, Gerardo Ortiz and David Stewart, just walking us through the Center for Quantum Technologies. So we can take at the maximum a couple of questions. Just one question I have, that you have told that so you have an IP sharing on royalty-free and non-exclusive basis. I just want to know that whether that industries has to pay only membership fee or they have to give any one-time fee for getting this IP licensing.
No, that's provided as part of their annual membership fee they pay, that they get access to that.
Yeah, thank you so much for enlightening us, because in India also we have established 1 or 2 centers on quantum technologies. So we're looking forward to fruitful interactions between these centers. Thank you so much for joining with us.
Thank you.
Thank you.
No, we can have it, you can write because of paucity of time. Oh, okay then, okay, please.
Hello, can you hear me?
Yes.
In your center of excellence, in your center of quantum technology, in what implementation technology you are working for implementation of quantum computer, whether it is a superconductor or it's a Japan, or which one?
Okay, so we have different, we have different technologies. I mean, we have superconducting qubits. Yes, absolutely. These superconducting qubits are not, for the moment, they are not used for quantum computation, but they are used for quantum communication. So there are special protocols and special chiral networks that are constructed at Purdue, indeed, with superconducting qubits. So, but we have other technologies. We have a unique 2-dimensional ion trap at Indiana University that is two-dimensional. You know, most of the ion traps are one-dimensional. I mean, there are several companies like IonQ, you know, Quantinuum, et cetera, that they are working with that technology. But in our university, in our center, we are working with this two-dimensional thing that for the moment is not a real quantum computer. It's more a kind of niche device that is a quantum simulator, but it's an extremely powerful simulator. And it turns out that, you know, you can simulate, you know, systems of interest, you know, in material science and in chemistry, or like chemical reactions, for example. But most importantly, we are getting closer, okay, to the full control to have a quantum computer using this kind of technology. So I am not sure, but these are essentially, I mean, I have to think a little bit more because there are too many, you know, too many technologies in these 4 universities, but these are the two most important ones. I mean, ion traps and superconducting qubits.
In which area you are focusing on, whether or not designing of the qubit or the development of control electronics or for the dilution refrigerator?
All of the above.
All together.
All of the above, yes.
Thank you.
Yeah, thank you once again, Dr. David and Dr. Gerardo, for joining with us. Thank you so much.
No problem. Thank you very much.
So we will go to the last speaker of this session. That is Dr. Anand Padmanabhan, the professor at the University of Illinois, Urbana-Champaign, USA. So he will be talking on harnessing the geospatial data revolution of the advanced convergence research for sustainable solutions. And he is currently serving as the managing director of the NSF Institute for Geospatial Understanding through an integrative discovery enforcement iGuide. Over to you, sir.
I'm waiting for the connector. Yes. Sorry. Yeah, Type-C. Okay. So maybe I need to switch this. Okay. Good afternoon, everyone. My name is Anand Padmanabhan. I'm a research associate professor in the Department of Geography and GI Science at the University of Illinois, Urbana-Champaign. And I also serve as the managing director for the NSF iGuide Institute, which stands for an institute for geospatial understanding and harnessing it's part of the harnessing data revolution. So this is the iGuide team that we have. We had just our annual meeting just last month in New York City. And this is kind of the whole team. And this is from last year that we had in Chicago. Can I have a hand mic, please? I like to know. I guess the motivation for iGuide is we want to do convergence science, and we believe that geospatial data and software is kind of key to doing this convergence science. And this convergence science is important for various areas of social and challenges that we are facing, scientific, social challenges like health and well-being, disaster management and emergency response, environmental challenges and sustainability, and so on. So I mentioned last month we were in New York City. Just the week before that, there was a huge flood in New York. With these kinds of events, can we use this geospatial data and geospatial understanding that we are doing and the processes we are generating in order to help with emergency evacuation? So that's kind of one of the questions that could be addressed. Similarly, I was looking at the newspapers on the past 2 days when I was here, and I see a lot of things mentioning about the pollution problems. This essentially leads to health risk, not just to the people in Delhi, but even in the surrounding areas. It's not just about like how the tourists view it, but it is a serious health condition for the people living in this kind of area for a long time. And this impacts kind of the productions and I guess what people could do in this area, the challenges people are facing. So these are kind of the challenges that we would try to address in kind of our project using convergent science. Convergent science essentially is integrating knowledge, methods, and expertise from various different scientific domains in order to solve certain scientific problems and to enable innovation. And doing convergent science is not easy. It is actually quite hard because you are, in a sense, building or bringing together various disciplines of people. As part of this, doing this convergent science, through the harnessing of the data revolution projects funded through NSF, iGuide was one of the 5 institutes that got funded. We just completed our 2nd year now as part of this project. And we have 11 collaborating institutions. So you can imagine how difficult this is in order to make this kind of institute run and function in a cohesive manner and in order to produce science. Not just like the institution involved, but the diversity of domains. We have people who are doing environmental engineering, environmental science, economics, social behavioral things, hydrological studies, computer science, artificial intelligence, political science, all those kinds of things. So we are bringing together such diverse expertise. So that is really a great challenge that we are trying to address, like bringing together all these people in order to work on such a convergence problems that we are tackling. So just a quick overview of our team here. But the basic mission we have on iGuide is transform convergence and geospatial sciences for holistic sustainability solution. So that is kind of our mission statement. And our vision is to use digital technology and innovation through harnessing the geospatial data revolution. And using this, we want to lead to our mission. So if we were to look at the perspective of NSF, intellectual merit and broader impacts, we have 3 core teams that are working on the intellectual merit side, which is our convergent science catalyst team, the geospatial AI and data science team, and the core cyber infrastructure capability and services team. That's the team I'm also leading, co-leading. And then on the broader impact sides, we have the education, workforce development, the engagement and partnership, and evaluation and knowledge transfer. So together, all these teams work for doing the convergent science and even translating this convergent science into knowledge transfer and into the broader impact side of things. So when we started, it was really a challenge. When someone asked us, what were we doing? I cannot say we are doing geospatial sciences. I'm doing geospatial sciences and cyber infrastructure. I can say I'm personally doing. But we as iGuide we are not just doing that, we are doing much more than that. So we went through a process in order to try, and with our external advisory board, and try to identify what can be kind of our identity. And one of the things that we as a team agreed on, that we could come up with 3 words that could kind of describe us, and in some sense is easy to communicate to people. So those 3 words were map, connect, and discover. That's what we can say we do as iGuide. So we do map, we map the worlds, we map the challenges, we connect the people, we connect using platforms, and we discover solutions, we discover resources, we discover talents, etc. So I'll briefly go through these 3 things, the map, connect, discover. Just going through them quickly, since I was told I have to cut short by a few minutes at least. So the various things in map, connect, discover that we are doing, we can say aging dams, problem that we are addressing, geospatial data hypercube, as well as telecoupled impacts. So I'll go through them briefly. So let's take the telecoupled problem. So for example, we have, if we have droughts in the Midwest region of the US. Midwest produces a lot of corn, soybean, and crops. These crops are getting imported by China. China is one of the biggest importer of soybeans. So for example, if there is a drought in the Midwest of the US, what does that happen? So China does not, or the price of soybean goes up in some sense because there is a less soybean in the market. So China is looking for imports from other places. So there is kind of a rush in other places to produce more soybean in order to take advantage of this market situation. And one of the places which usually this translates to is kind of Brazil. In the Amazon regions of Brazil, they start burning the forest in order to get land where you can produce more soybean. So in some sense, a drought in the Midwest is now causing China to import more soybeans from Brazil, which is causing deforestation and biodiversity loss. So this is kind of a telecoupled impact, which we are studying. In a sense, to do this, we have to bring together people who know economics, people who know, I guess, global trade kind of things, as well as biodiversity loss, ecology people. So we are working on this, one of these problems. The second problem is kind of the aging dam. This is a problem that we have been working on for, I guess, a year and a half now. Most of the dams in the US were kind of built for a median average life of 50 years. Many of the dams there, and the average median age of those dams is now over 50 years. And some of these dams are federally owned and are maintained well, but a majority of dams are actually privately owned. And there is no record of their maintenance or what's going on, and we have no idea about the conditions of those dams. So in some sense, this is a real challenge for people to understand. And so we are trying to estimate, for example, if there is climate change, if there is a climate change and this causes kind of impacts for weather in terms of more flooding, more precipitations in a certain region, what is the risk of these dams getting breached, overflowing or overtopping, or are forced to release some of these waters? What is the impact downstream? Who gets impacted? What are the social impacts? Are those schools impacted? Are there secondary impacts in terms of power stations and things which are downstream? So these are kind of the solutions that we are working. And some of the things that we discovered is it's not even like one major flood event which triggers this. That could be like a long, like 30 days of wet period, which might trigger this event. You cannot say, hey, it's a one-time event like a hurricane or something which is a huge event which is causing this, but it might be a lot of small events which might trigger these kinds of things. So doing this for one dam, easy. Doing this for 80,000 dams, that's tough. So we have to use scalable solutions, computer technologies in order to do this. So this is one of the things that we have been working on to try to run this on scale for many of the dams in the US. I'll skip through some of these for interest of time. The other thing that we are working on is on geospatial knowledge hypercube. This is from our GeoAI team. So what they are doing is they're mining a lot of text data. So for this example in particular, they take a lot of text data coming from Google News. So they mine that kind of an information, and then they create this kind of a 3D or n-dimensional actually hypercube, which also takes into account of the location information. So it's not just doing this on keyword. So there are quite a bit of techniques, and this is published in AI journals by Dr. Javed Han and his team. So what they are doing is they're taking this certain keywords that experts provide. They are extrapolating from that. They are finding out what might be the related keywords, and they are trying to find which of these articles might be related to certain dams. And so as a scientist who might be interested in studying this data or studying this problem, they might be able to query this hypercube in order to get the relevant data set, get the relevant pieces of information out of this hypercube. So that was kind of a brief summary of the map things that we were doing. Connect, we are connecting with kind of the communities, we are connecting with data, in terms of partners. So these are various things that we are doing in the connect phase. And I'll talk about one in particular, which is the iGuide platform, which is something my team has been building on quite a bit. But there is another thing which I do want to highlight is we have a large number of industry partners within the project, which have all their logos are there. And we also have something called the iGuide Climbers. This is something which is very unique that we do, which is get our graduate students and postdocs who are working across all the community, all the projects within iGuide to come together and form a community between themselves. So it's like the professors and others are not in the room. They form the community. They tell us like, hey, we want to be working on this. That is something you guys can help us do. For example, they told us like, hey, we needed to host a virtual poster competitions, not just for us, but for some of our peers. And we will do kind of the legwork. You provide us kind of the support, and we are happy to do that. So this kind of helps us to build kind of next generation of our of the leaders who might be working in these areas and who are in a position to do convergent science. As I said, I will talk a little bit about our iGuide platform. iGuide platform essentially is what we are saying is the missing middle, which provides, hopefully provides a data on demand when it's completely done. So essentially what currently we have is we have ways of connecting to data sets, connecting to repositories, getting data from the repositories, allowing you to do computation in a platform. We call it is for people who know, it's kind of based on the Jupyter Hub environment. So it uses those kinds of environment in order to provide you with the software tools, the geospatial tools, the AI ML tools that are needed. And it also provides you, we have worked a lot on computational reproducibility, which we think is really one of the main challenges here. So how to do computationally reproducible research on using kind of this area. So the platform provides tools for doing that. So kind of the workflow within the research challenges, like people have challenges with data, people have challenges with compute. In many ways, they want to use like high performance computing in order to do reproducible research. So those kinds of support we do provide for them. This is kind of a basic, maybe an overview of what the iGuide platform you can think is doing. You have the users coming in from the left side here, and their main interface is a Jupyter interface, which is kind of significant because there are two things. One, it provides an easy browser-based kind of interface. So many of the researchers we work with, domain scientists, they are not very comfortable if you just give them a terminal to work with. So providing them with an environment, lowering the barrier to entry. So taking that as a Jupyter interface, and another significant advantage is like you don't want to build custom solutions for everything. The gateway model, the science gateway model that was there, you can build custom gateways for every purpose, but then it gets really people intensive in order to build these kinds of gateway, and you need a lot of software developer resources in order to do that. But with the Jupyter environment, it's much more manageable. Then we have a middleware layers where we have two things: the CyberGS compute service, which my team built, along with the GeoEDF team, which our colleagues in Purdue built. So the CyberGS compute essentially is able to manage kind of the computational workflow that you have, to run them on a high performance computing environment. And the GeoEDF connector is basically taking data from various sources and feeding into this the compute environment, so with these two kind of merged together, we are able to both get the data and the computation to the high performance computing environment and get back the results and visualize it within the Jupyter environment. Another view of the same thing, I would say, in a sense, the users, we have products, we have creative capabilities, and we have the CyberGS or the cyber infrastructure building block. And many of these, one of the key things that we have achieved through this product is integrating many of the NSF previous investments that were made in this area. So integrating these, talking with them together in order to make this seamless for the users. So existing capabilities I talked about, we are using the Anvil HPC, which is a high performance computer at Purdue. We are using the Jupyter environment. We are using the CyberGS compute and GeoEDF. All these tools that have been independently developed, now they are talking to each other. And if I were to characterize a workflow, just to give you an example of like, hey, how does this actually translate to doing convergence research? How does the platform get used for convergence research? Here's a simple example. Like say, I talked about the social vulnerability of aging dams that we were addressing. So we have inundation maps that are getting created. The scientists are comfortable doing this. Then we have like processing, raster processing, vectorization, and other steps which are more difficult. And then at some point you say, okay, now can you repeat this process for every dam in the US? So that becomes like, okay, I have to go to HPC, and then like, okay, I cannot do this anymore. So this kind of things, we simplify this workflow. I'll try to wrap this up quickly. So the third thing that we have is the Discover. The Discover environment, the map connect. So the Discover is the third thing that we have. So here I can say we have sharing of this scientific knowledge through our environment, the convergence curriculum that we have, and things. So here's a quick overview of what we do here. The resource discovery page that we have is kind of trying to help you find these resources, and this is kind of notebooks, data, and we are all constantly expanding this in order to make this accessible to people. The other important thing here is the convergence curriculum. This might be useful for people here as well. So we are developing, so we went through a lot, so our evaluation or the education and workforce development team went through a lot of effort in order to kind of identify key areas. So in order to do convergence research, it's not like, most of our people are expert in one domain, but they need knowledge in a second domain or a third domain. Everyone cannot become experts in all the domain, but they need to have enough knowledge in the domain that they are interacting with, that they can speak the language or understand the language and can make meaningful contribution. So this is kind of the model that we have developed in order to, we have like 3 sentences, 3 slides, 3 hour modules, 3 week modules, kind of like a level of things that build on each other. So like if you want to learn about something, you can read 3 sentences and get some basic descriptions. Then you do like a 3 slide, you get a little bit more knowledge, then you have 3 hours. If you have 3 hours, you can do a 3 hour module and then a 3 week module. So one of this example is for geoethics, which I won't go through, but similarly, we have the 3 sentences, the 3 slides. So geospatial sustainability or geospatial revolution for sustainability. We have these 4 layers that we have. You can think about the advanced cyber infrastructure layer, the middleware layer that we have for the cyber GIS and geospatial data science, and of course the user layer where you have the domain scientists coming in and with their problems and using the other technologies and solutions that we build are able to use the cyber infrastructure layer in order to solve the problems. I'll be happy to talk with any of you on details. I had to speed up a little bit for want of time, but I'll be happy to answer any questions. And these are some of the resources that we have on a related project that could also be useful. And I'm happy to take any questions or via email or here. Thank you.
Well, I request you please appreciate this interesting presentation by putting your hands together. Ma'am, please summarize the panel.
Dr. Anand, thank you so much for a wonderful presentation on most relevant topic. So we can take a couple of questions on both the speakers, and the first speaker also we didn't had any question. Any one of you have any questions? Just 1 or 2 questions at the most, please.
Hello, this is Prabhu from CDAC Pune. My question is for Professor Anand. Sir, I did see your iGuide platform. So how is it different from the Google Earth Engine, which also provides the WPS by accessing from different data sets across multiple providers, and it does the processing on the fly and it gives the results also. So now your platform, how would it be different from what it is?
Very good question, I guess. The Google Earth Engine is kind of it's more on a kind of a desktop related software, and where you can do the processing and you can get some data. Ours is based totally online environment using, I guess, Jupyter, and you could write Python code within the environment, and it has most of the libraries and geospatial libraries that you want to use already built in. So you could leverage that, as well as the connection to high performance computing, which is quite unique. So I talked about the CyberGS compute platform, or the code that we have, as well as the SDK that we have, which helps you connect to, for example, the Handle HPC, but in essence, it could connect to any HPC environment. Even within India, if you want to, the code is open, and the way we have developed it, it can connect to any HPC environment anywhere.
Thank you, sir.
Hello, this is Sarita Jhele from Maharashtra Institute of Technology, Pune. My question is for Dr. Atish. Thanks for the excellent presentation and information regarding all the various processes that have been developed for recycling. My question is regarding the environmental impact that is happening because of any recycling or recovery process. So whenever you develop a new product or a process, you need to look at how much energy or material is going on into it for the overall, like in a standard life cycle analysis method. Or so is anyone at CMET looking at that for the recovery processes?
Yeah, a very good question, ma'am. You know that we do have a MTech program on e-waste resource engineering and management, and many of the students, their long-term projects are on life cycle analysis of various end-of-life streams. We have done it for mobile phones, we have done it for lithium-ion battery, because recycling is not the final answer. We need to refurbish also. We are also trying to see that whether we can refurbish and we can reuse, and then only we will go for recycling.
Thank you.
Hello. My question is again from Dr. Atish. So this question is mainly regarding the graphene and its application, which you demonstrated on your slides. My question is in particular to have you or your center designed, fabricated some of the structures related to graphene and characterized in particular for terahertz band, or what type of circuits or devices have been fabricated by using graphene in your center?
Actually, Dr. Seema is the lead scientist in graphene. Oh. But before I hand it over to her, I just want to tell you that I have shown you zinc tellurides. there is a proven material. Zinc tungsten is one of the proven material for generation as well as detection of terahertz. Dr. Seema is working on, she has a national center on graphene, like she will answer that question.
That we will discuss in offline due to want of the time. So we would now going for the concluding remarks of this. Okay, one more, yes, please.
I have a small query on Dr. Padmanabhan. Your lecture was very much effective and very informative. I was just wondering, you have mentioned mostly on the aging dam problem. That's what you are looking after. But your platform, I believe, has got a vast applicability in other areas as well. Like where the kind of data science support, as you mentioned in the last layer, would be of very much use. Can you highlight one or two more application areas where we can bulge in?
Definitely. You're absolutely right in a sense that the aging dam problem is one of the examples. The other example I mentioned was the telecoupling so that was also using it. A third example we are looking at, one of our colleagues is looking at the shrinking of the Great Salt Lake a salt lake is in the interior of the US in the state of Utah. There is a Great Salt Lake and it has been shrinking over the past 30 years and it was lowest like 2 years ago. So that kind of problem is also being looked at. There is a colleague who was looking at economics problem in terms of like migration of people or the non-migration of people or the stickiness of people in terms of the jobs migrate but the people don't migrate as fast or are more hesitant to migrate in a sense. And so how does that impact, like say for example, if there is a global trade kind of agreement, jobs move from one area of the country or from one region of the country to the other region, and what are kind of the impacts of the people in certain areas. For example, in the Midwest, there has been a lot of loss in terms of industry. So what is kind of, how do you explain those kinds of things? So those are also being using the platform.
Yeah, that would be another very interesting application. Sir, here the kind of geospatial this environmental impact overall, how actually you can predict? Is there any pathway for prediction of that kind of problem? What you are saying that it can just increase at a certain rate, and so that some warning and all that stuff can be given.
Famous first law of geography which says that nearer things have more impact than the farther things. So essentially that's kind of the basics of the geography, but there are like various ways of finding out about the impact and assessing the impact. So again, that all depends on a particular problem. For example, hydrology problem, it might be totally different from an economics problem. So again, it is problem dependent.
Thank you, sir.
Yeah, so in this session, we have in fact two areas we have covered. One is on the sustainability and green technologies, and another is on the future technology of quantum technologies. So in the green technologies, and Dr. Radish was talking on the circular economy, and Dr. Anand was talking on the data harnessing. So these are all most relevant when we are considering that or the depreciation of the critical materials. So another area which we talked is on that, another session this which covered by Dr. David and Dr. Gerardo on the quantum technologies. So I thank all the eminent speakers for enlightening us with their latest research and more relevant topics. And thank you to all. We are going for the conclusions, and just give a big round of applause to these all speakers. Thank you all.
Well, thank you very much, ma'am. First of all, let's take a moment to appreciate our wonderful moderator. Please, a round of applause for her. And also our esteemed panelists. Thank you very much, gentlemen. Now may I request Mr. Mohan Kumar from NSF. So please kindly join us on stage in order to felicitate with token of gratitude. Well, I was expecting a big round of applause for this wonderful panel discussion. I request our moderator, ma'am, please come forward. Now, may I request, sir, please come forward. Mr. Anand. And let's have a group picture together. Let's have a group picture. Well, the next session, ladies and gentlemen, again an interesting and relevant topic, that is Intelligent Transportation Systems, ITS. Thank you very much. And in order to moderate this session, but before that we will have a very short tea break. You can proceed for the tea break. Make sure in next 5 minutes, please join us. We will proceed with the next session, that is Intelligent Transportation Systems. So this is a very short tea break. It's a very humble request. Please be back in 5 minutes. Thank you. The topic is Intelligent Transportation Systems, ITS, and in order to moderate this session, we have two moderators. Please help me to welcome them. Can you help me to welcome them, ladies and gentlemen? Mr. Satish G, CDAC, MEITY, and Nirmala Roy, sir, University of UMBC, USA. Mr. Satish, he has implemented many projects of national importance. Some of them to name include ATM-based plant, wide networking and power consumption, monitoring system project of Belai steel plant, data center in Kerala state wide network. So, ladies and gentlemen, his research areas of interest are related to the development of intelligent transportation systems, solution for smart urban mobility and connected and autonomous vehicle. So please help me to welcome Mr. Satish Ji, our moderator. Everybody, please help me to welcome him. Now please help me to welcome our next moderator, Mr. Nirmala Roy. He's currently a professor in the Information Systems Department at University of Maryland, Baltimore County. He directs the mobile pervasive and sensor computing lab. Before joining UMBC, he was a clinical assistant professor in the School of Electrical Engineering and Computer Science at Washington State University from January 2012 to June 2013. He did his bachelor's in computer science and engineering from Jadavpur University, India in 2001. So please help me to welcome Mr. Nirmala Roy, our moderator for this session, University of UMBC, USA. So all over to our moderators. The topic is Intelligent Transportation Systems. Please help me to welcome this panel discussion, ladies and gentlemen. I invite our moderators on dais.
Good afternoon, everyone. As Madam introduced, this is the Intelligent Transportation System sessions. Satish and I am going to moderate this session. We have two distinguished speakers, Professor Kaushik Choudhury from Northeastern University and Dr. Geeta Krishnan Ramadurai from IIT Madras. So Geeta Krishnan, if you could come and take a seat on the stage, that would be great. And Kaushik has 45 minutes to give his talk, and as Dr. Geeta Krishnan has 30 minutes to give his remarks, and then Satish and I will summarize about the intelligent transportation session. But at the end of the session, please stay, because Dr. Mohan Kumar is going to report on the summary of all session and probably invite all the breakout session leader, whoever are here, to summarize whatever insights they gain from yesterday's breakout session. So without further ado, I think Kaushik is online probably, so I am going to introduce Professor Kaushik Choudhury. Professor Kaushik Choudhury is a professor and vice chair of research in the Electrical and Computer Engineering Department at Northeastern University. He is also the associate director of the Institute for the Wireless Internet of Things, and he has specifically mentioned three research areas. First one is the applied machine learning for wireless, where he is looking into different deep learning application in wireless spectrum sensing, sharing, and management. He has also interest in multimodal sensor data fusion, where he is looking into multimodal sensor data from LiDAR, RGB camera, even millimeter wave radar, to see how those can be used for situational awareness and even digital twin application. And recently he has also been working in the area of networked robotics, where he is looking into coordination, computation, and communication of unmanned aerial autonomous systems. So particularly Kaushik has contributed in the intelligent transportation systems area related to multimodal fusion for vehicular beamforming with datasets and code releases. And he is the co-director for the operation of a Colosseum, a big research institute in US. He is also the co-PI for the Platform for Advanced Wireless Research Project Office, a joint 100 million public-private partnership between the NSF and Wireless Industry Consortium. He has multiple achievements. He is the finalist of 2023 US Blavatnik National Awards for Young Scientists. He is the winner of the US Presidential Early Career Award. He is also the winner of NSF Career Award, Winner Award, and as well as DARPA Research Award. And he has multiple best paper awards from the top conference. Without further ado, I would like to invite Kaushik to take the online virtual stage and provide his talk on the establishing high bandwidth connection with autonomous car using multimodal data fusion. So Kaushik.
Thank you. I just want to see that. I just want to hope that everybody can hear me and see me. So we'll get started. All right, wonderful. So firstly, thank you for your kind invitation. I'm very appreciative of the opportunity to speak to this august audience. I just want to, let me see. Hopefully you can all see me and hear me. So today I'm going to talk about how data can be used to drive intelligent communication systems for vehicular scenarios that require high bandwidth connections. And this is an exciting area because more and more we are, or at least we're going to see autonomous cars on the roads. We are going to see intelligent systems that require that massive amounts of data need to be relayed to a central cloud. And how will communication systems support such intelligent mobile environments is what's going to be the topic of today's talk. So, all right, so let me get started with this. I just want to introduce by saying that I work on a number of these different topics. Some of them are very relevant to the next generation wireless networks. So for example, I'm trying to make networks ultra secure. We have methods in which we can identify devices using their transmission parameters. We can do ultra reconfiguration where the environment changes and adapts to the devices. For example, we can do so by controlling the actions of reconfigurable surfaces. Then there's ultra space where future connectivity between vehicles and roadside units need not be limited to just terrestrial environments, but you could imagine there is a layer of UAVs, and on top there's a layer of satellites, and there is a continuous exchange and handover as you go across the vertical planes, as you go across the horizontal space. Then there's ultra low latency. Most vehicular environments involve some aspect of mobility. So how do you ensure that there is a timely delivery of packets in that situation? This is the topic that I'm going to focus more about, ultra sentient. That means we want to gain a contextual awareness of the environment by using a number of different sensors that typically these new and emerging vehicular devices already come with. So if you're going to buy one of these EVs today, most of them have LiDARs and cameras and radar, which can also be repurposed for establishing a better communications link. And so that is something that we're going to explore in this talk. So diving deeper into this, the specific technology I'm going to talk about is how to harness multimodal data for vehicular beamforming. That means, how do I fuse context from all these other sensors to establish high bandwidth connections between the vehicle and a roadside unit in a way that is better? And so just to give you a sense why this makes this is a natural evolution of the way in which standards could be designed. Now, when we try to walk into a room, we are watching things with our eyes. We are picking up audio sounds. There is a multiple number of senses through which we are consciously trying to make sense of the environment. And that's what the vehicle also needs to do. Now, one of the things that just want to give you a sense of a number of other large-scale testing facilities that exist and which can also use researchers interested in smart transportation networks. I just want to give you a sense of where these resources are and what unique capabilities they have. So the first one is an emulation environment, and I'm going to talk about the NSF Coliseum here. This is an NSF investment which is supported through a community infrastructure award. What the Coliseum allows us to do is to create virtual worlds. So we can create, we have user accessible 128 X310 USRP radios, and you can place these radios virtually as if in downtown environments or in an indoor space or in a park, and create realistic channel interactions between any to any transmitter receiver. So we have actually some scenarios where there are vehicles moving along a straight line in a grid-like city environment, and each vehicle's transmissions will affect or will interfere with the others depending upon proximity, waveform, etc. So you can emulate very interesting mobility conditions and in various kinds of environments using the channel emulator of the Coliseum. For actual testing facilities, I am part of the NSF AI Edge Institute, where the NSF has made significant investments in advancing the state of AI and machine learning, in this case for wireless. And one of the use cases of the AI Institute that's funded by NSF is this aspect of ubiquitous sensing and communications using autonomous cars. And in fact, this is the example I'm going to talk more about as to how these cars with these sensors will be able to establish high bandwidth links. Now, if you're interested in at-scale experiments, NSF has funded the platforms for advanced wireless research, and this is a 50 million cash investment from the NSF, kind of 50 million cash and in-kind investment from an industry consortium. Now, there are 4 of these platforms already awarded and at different stages of maturity deployment. So here's this example. What you see here is the NSF Powder Power Platform in Salt Lake City, Utah. Now, here are these base stations that you see as in icons, and there are software-defined radios that can run 5G, Open RAN stacks, and then there is also massive MIMO deployed on the top of the roofs. But interestingly, there is also a shuttle that is moving across the campus, and the shuttle can become a URI or a user equipment connecting with the fixed base stations that are deployed in the campus. So you can also do a lot of interesting experiments by logging in remotely and making use of these other NSF investments for intelligent mobility transportation systems. The last one is something that is a snapshot of a large anechoic chamber that we have at Northeastern. So we can run large swarms of UAVs in a completely RF isolated environment. There's also another NSF platform called AirPower, if you want to use a publicly accessible platform where you can program UAVs which can move around, connect, and establish links with roadside units. Again, this is NSF AirPower in Raleigh, North Carolina. All right, so just one thing to note is that the few pointers that I'll give today, there's a lot of data sets, and we have made these data sets publicly available through another NSF investment called the RF Data Factory. So please feel welcome to go into this portal. You will find a categorization of data sets that you see on the top left. You'll also see standards compliant metadata generation and representation of these data sets. So we are big on SIGMF so that everybody can understand and interpret those data sets. There's lots of software APIs that allow that basically democratize the goal of collecting data sets for your own use. And finally, we have a bunch of tutorials as well where we explain to you, like, how do you go and set up an experiment, let's say on powder, and collect data from the field, or how do you set up your own lab test bed and where you can collect data on the field. So we are big on data, and here are some investments, again, by NSF that you should feel free to take a look at. A lot of these are all publicly available. All right. So then let's go down into a little bit more of what we are trying to do in this particular talk. Again, I'm going to focus on this ultra sentient and by using all these sensors to form good directional beams. So the question is, why do I need all that sensor information? What is so hard about forming just a communications link in a vehicular environment. So I'm looking at the millimeter wave band, and as you may imagine that the lower frequencies are incredibly crowded, and there's an incredible opportunity at these higher frequencies to fully utilize large channel bandwidths, thereby being able to relay massive amounts of data up to a central link and reduce contact times. Now, the problem with transmitting at these frequencies is that although we have more spectrum than all the sub-6 gigahertz put together, the problem is that these links are highly directional. And that is because there is high attenuation in these bands. And to ensure that you are able to make that connection with the proper link budget, you create directional beams. So fine, right? So what? What's the big problem? The problem is that these directional beams have to be swept across. You need to explore sector by sector and figure out where should you be pointing to. And that takes time. And you don't have that time in a mobile environment. So that is why we are using multimodal sensors to guide the beamforming process. Now, so these sensors are fairly going to be commonplace in the days to come. So for example, if you look at the state of autonomous cars, the projections are that you will have millions of such cars in less than 5 to 6 years. And each car will generate around 40 gigabits per second of data if you combine all the kinds of sensors that are being that are deployed on it already today. Now, there is a version of the story where a lot of this data needs to be relayed to a central pickup point or a central assimilation point. And so how do you relay these high bandwidth data in a short amount of time is a question for such autonomous cars. And then again, you only have a short amount of time. If you start to sweep the beams and start to establish, explore beam by beam, it's going to take a while for you to establish and have the full sweep, which is really prohibitive in terms of time. All right. So then let's talk about the scenario where we are going to establish these beams and how we're going to do this in the vehicular environment. And I just want to acknowledge a couple of papers from which I'm drawing this material from. And there's also all these data sets that we have released, and you're very welcome to go and retrieve these data sets for further research. So our goal here is that here's a vehicle. The vehicle wants to connect to a roadside unit using a millimeter wave link. And there could be obstructions like this bus on the way. There is a control channel that exists between the vehicle and this base station, which is in sub-6 gigahertz. However, the actual high bandwidth data transmission from sensors occurs in the 60 gigahertz millimeter wave band. And so you can imagine there are multiple directions at both ends. How do you find the right one so that you can establish a robust link? That's going to be the problem, right? Okay, so one way to do this is to use all these different sensors. So in this first example, I'm going to place my GPS and LiDAR on the car, and I'm going to place my camera on the base station. This is because I'm using a data set called realm of time, in which data set is created in this manner. And soon I'll show you another example where I have all three on the same car. All right. So given the fact that I'm generating all this data, I can't relay all of it in its raw form and send to a central mobile edge computing venue, because it is considerably large and heavy, especially the LiDAR point clouds. So I need to do a little bit of pre-processing. Now, what pre-processing am I doing for the camera? So the first one is to take the camera images and remove background features that are not exciting or not important for choosing the actual beam. So if I can identify that, hey, I want to transmit to a car, but there's a truck, then maybe those are regions that I should not go exploring. Or if there's a background, like for example, the sky that really has no bearing on my directional beams, then that piece of the image is not important. So I'm going to extract features that are important and then send it up to the next layer. Now look at the car. What is the car doing? So there's LiDAR point clouds. Now the problem of LiDAR is that it is unclear how you would be able to generate a fixed point set, because in LiDAR you're bouncing off these lasers and you are getting back a reflection, and all of this could be several range from hundreds to thousands of such points, and they could be high variance. And the way we design these machine learning based models, especially neural networks that I'll show you in just a bit, I can't have variable number of inputs feeding into these models. So I need to have a fixed set. Now to do that, what we do is we create some kind of a quantization scheme that you see on the top left. And so this is something like a three-dimensional cuboid region. And with this region, and so with this compact representation, I'm seeing that, are there LiDAR point clouds in any such cuboid block? And if there are, and if it is, let's say, the locations of the end receiver, or if there are obstructions, I appropriately mark each block with a certain index. So all I need to feed then to the next layer after pre-processing is just this block with these encodings for each of these smaller rectangular units. So that is the way I feed in some of these quantized and pre-processed information to a fusion network. Now, what the fusion network is doing is essentially it is taking in the GPS coordinate, the pre-processed LiDAR, the pre-processed images, and trying to extract features. So when I say features, it is, imagine that I have a deep neural network, and what I'm going to do is I'm going to extract the outcomes of these latent embeddings before the final decision layer. Okay, so these are latent embeddings that have captured some unique characteristics of these sensor inputs in some high-dimensional plane. So I'm going to take in these features, I'm going to concatenate them together, and I'm going to run a couple of more layers for finding the final beam prediction. So ultimately, this is going to say that, given the LiDAR camera and GPS, go point or go choose beam number 5. So that's really the outcome of this fusion process. So the fusion network that you see at the end is nothing super novel in a sense. It is basically a couple of convolution layers, couple of fully connected layers, and we are using some basic concatenation of the features on the top. So now the thing is that how would you concatenate sensor data from multiple different sources? Because they were never meant to be combined in the first place. Your LiDAR was never meant to be combined with the camera. So there are a number of different fusion strategies, and I show some of them here. This is a simple concatenation. In fact, this is what we have followed ultimately. But if you're interested, and if you wish to pursue this further, there are lots of open research challenges on how to do this concatenation. So for example, could you scale in, could you combine first the image model with the LiDAR, and once you do that, can you then add on the coordinate model? So sort of it's a feature-wise, step-by-step combining of these features. There's another approach of low-rank tensor fusion. And then there is a multiplicative interaction, so these were more like just simply appending them to a larger vector. These are more multiplicative examples. So as you can see, the image is then combined with the LiDAR, the camera and the LiDAR are being combined, and so on. So there are various strategies of this sort, again, of different levels of complexity. We have explored and used the one on the top left. Clearly that shows there's a lot of avenue here for future research. Now, the challenge here is, if you have a vehicle that is moving in and is quickly passing a roadside unit, and you have to find the best direction for transmission, there are two things you can do. You can say that, for example, in this case, can I have a subset of the top candidates where that best beam might lie? Okay, instead of saying that just go with that one beam, what if I say that give me your top K beams and then I will make a selection in that set. So here's the total number of beams candidate options possible, of which let's say that the method that I'm proposing gives you the top 3. So k equals to 3 in this case. So it could happen that your best beam actually lies in that set that you identified, in that shortlist. You see this green beam, which is the best one, is in this set. Great. But if k is quite small, then it is possible that your best beam might not lie. I mean, at the end, these are all probabilities that of selection of a beam. So there is going to be a push and pull where k determines whether, or at least the likelihood that your best beam is going to lie in your selection. So how do you choose the top k, right? So the simple way to do this is at the end of your neural network that is making the beam predictions, each such class, that means each class represents one choice of a beam, is represented using a softmax score. That means it gives you, in a sense, a probability that exists, or your best beam is that particular beam. So if you take the softmax scores and if you rank your beams based on the softmax scores, then there is one way to say that okay, here's a ranked order of possibilities where the best beam may lie. But now the question is, where do you stop that list? Okay, in the ideal case, you would send the whole list over, right? But or in the other case, you would only send k equals to 1. So what should k be ideally, so that there is high likelihood of your best beam lying in it? So that's the question that we need to answer. And as you can see that as you increase k, the probability of the best beam lying in that set is increasing. That's intuitive. But on the other side, if you look at 2 examples, for example, k equals to 3 and k equals to 5, if I give you k equals to 3, you still need to use a standards defined sweep, each of them turn by turn of these 3 ones, to identify the best beam. And here it is 5. So you're going to take more time to explore this set of 5 than this set of 3. Now, so what I'm saying is that you have low reliability, but also low latency, because I'm exploring fewer options. On the right side, you have high reliability that the best beam will lie in your set, but you have higher latency because you're exploring multiple options, many more options than k equals to 3. So if you look at the fractional time in which a beam is actually being utilized, is your total contact time of a vehicle on the road subtracted by the time to complete this end-to-end fusion and beam selection, and it's sort of normalized over the whole time, right? So this is the time you want to maximize, because you want to maximally utilize the time for the best chosen beam, and not just spend time in choosing that beam. You want to reap the benefits to a greater extent. So if I just remove all these other pieces that you just saw, there are only these 2 equations that matter, right? One is, how do I increase the number of beams so that my reliability is enhanced? That's the top equation. And the bottom equation is, how do I increase the fractional utilization so that once I choose the beam, I can fully extract the value out of it? So these are the 2 push and pull pieces. So as k increases, this first one increases, right? The contribution of this first equation increases. But as k increases, this also decreases, because the lower the fraction utilization decreases. So how do you find k is essentially an optimization function. And what we have done is we have shown for different conditions how should you choose k in some of the papers that I've found. So I'll not go into some of the details there, but this is really the decision that you're making in this particular question. So let me show you what this looks like in a synthetic data set environment, and then I'll show you an example with a real car. So in the synthetic environment, imagine that I have a virtual tool, and this tool is actually been designed by Heath and his colleagues, where they are using the OpenStreetMaps to create a virtual representation of the map of the environment. Then there's the mobility simulator through Sumo, and then there is LiDAR provided through Blenser, and images, camera images provided through Blender. And then the ground truth is provided by wireless inside that performs ray tracing and says that here is the signal strength if you point your beam in so-and-so direction. So that is the ground truth, and these are the inputs. And here is how it looks like. And I've just taken this example from the work by Heath. As you can see, as these vehicles are moving and this roadside unit is trying to establish these beams, these are directional beams. And sometimes there are occlusions for which you have to actually bounce off the walls. And it is better to actually bounce off of a nearby building than be occluded by some other vehicle in front of you. So this is really the kind of the data set, the visualization of the data set that we use for this particular work. Just to show you again, here's the roadside unit on the side, and the vehicles are moving, they're establishing these links, and you can see the base station is sometimes actually preferring to bounce off the walls, and sometimes it is establishing direct links. All right, now, does this multimodal fusion work? Okay, so here is the first result where you see that as I increase K, now my K means that how many beams is my model predicting, and then you can do a more fine-grained sweep on them. So as K increases, so from just to top 1 or K equals to 1 means that I'm telling you just go with this one beam, while top 50 is me saying that here's a 50 short list of these different beams, and then go explore them. So as you can see, as I increase K, my joint, by using my GPS camera and LiDAR is actually increasing. The probability of the best beam lying in that set is increasing. And I'm doing fairly well for some of these higher numbers, or even like top 10, it's above 90%. Now, there is also great benefit in using some of these multimodal ways in which you are able to shortlist the beams, is because if you look at that beam selection time, and this, I'm comparing this with, I believe, different kinds of, so here's the 5GNR, this is the baseline. So it's going to take me 145 milliseconds to sweep all the possible beams that are there in the data set. Instead, if I use the proposed approaches, I am able to reduce this to around 4.6 to 5.71, 6.47 milliseconds, considerably lower, massively lower. But my throughput hit, because I chose a suboptimal beam, is not much. It is about 15 to 20%, about around 5 to 10% of the maximum, in case I'm using, but the cost of this is that there's a dramatic 96% reduction of this total time that is taken by the 5GNR standard. Now, there are some other analysis that I could share here, but the question is, and I won't go into too much depth here. The question is that, can you still do all this capturing the data, sending it to a central mech, analyzing and running inference, and then choosing the best beam? Can you do all that in finite amount of time, right? Because still, I am using my backend control channel to do some sort of a pre-processed data transmission to the mobile edge for selection of the beams. So all I'll say is that we have broken down the time cost of each of these different functions. For example, data acquisition and pre-processing, it takes about 1.3 milliseconds. Sharing features between the vehicle and the mobile edge computing center takes around 1.32 milliseconds. Then sharing the selected beam and the inference, running this whole thing is about another 1 millisecond. And then sweeping the beam, following the 5GNR standard, you choose one by one the options given to you by the inference model. That depends upon how many beams you're choosing. And so that gives you some sort of a cost time. So overall, we find that our total time end-to-end is much lower than what is currently possible through the 5GNR standard. right? And we are using, for the back control channel, we are assuming A2.11p. We have also shown timings for LTE as the back-end control channel. All right, so with that said, I'm just going to skip this and I'm going to move to another use case of the same environment, but this time, now I'm going to have a real car, a real autonomous car with a number of sensors deployed on it. So this is what we have deployed at Northeastern. And just to give you a sense of what kind of sensors are here. So here are camera sensors that is producing 30 frames per second. I have LiDAR, both 16 and 64 Velodyne channel LiDAR sensors that are deployed on the top. Then we literally have, as many experimental work happens, like duct taped a millimeter wave Talon router on top of this car, and then we have a similar kind of a router on the roadside unit so that we can establish a millimeter wave link between these routers. And then at the bottom, we have the GPS, which is inside the car. So this is really the car environment that we are going with. So one thing to note is in this particular example, what I'm going to do is I'm going to show you how this multimodal data fusion model could be trained. Okay, and how would you utilize multiple vehicles that are capturing this data, and how would you over time use federated learning to create a robust model using local knowledge learned by these individual vehicles. I'm going to restrain my number of classes of that means I can only have 34 options of the beam. Instead of 64 into 64, because 64 options are available at each end. So the total combinations is quite large. But I'm only restricting this to 34 because of the Talon routers. They are only giving me these 34 feasible classes for that experiment that we are going to run. Now, my goal here is to train local models and then take these local models to the central cloud, do some sort of a federated averaging, and then send back the models to the cars so that this time there is no further back and forth from the mobile edge computing center, but the car can itself make a local action. So what I'm going to do is I'm going to have separate models for each of them. So there's a GPS, there's a LiDAR, there's a camera. Each of them is a convolutional neural network. And as I said earlier, there's a fusion layer that fuses all this information in. So I'm extracting latent embeddings as before from each of these three sensors, and then I'm integrating them here, as you can see on the right-hand side. I'm combining them all into one inference decision. So now the question is, what is the overhead of relaying all that sensor data for federated averaging? Turns out, I can either send my entire model, which is all these weights, or I can send a specific model. So for example, I can only send a LiDAR, or I can only send the image model and only average that branch instead of all the branches. So as you can see on the right, if I send everything, it's going to be a huge amounts of weights that I'm sending for each. So each of these thetas represent one of these branches, so LiDAR, image, camera, and the integration layer. That's quite large. And then I have number of iterations, number of vehicles, so plenty of uplink traffic. So instead of this, the goal is, can I choose one of these branches for each round and then pick which branch is the best one to do? And if I do that right, then as you can imagine, if I'm only averaging the LiDAR, there's a significant reduction in the uplink traffic where the LiDAR weights or the models of the LiDAR branch are sent by the vehicles for averaging in the central cloud. Now compare this with average weights in a single branch versus the average weights of the entire network. And this is, as you can see, considerable. This is the number of vehicles here and with the full network here versus only the LiDAR branch. So that's what I want to explore. I want to explore in this example, what is the benefit of using only a partial branch for federated averaging versus the entire full model. So here are some actual vehicular deployment scenarios that we have. So as before, we have the vehicle and a roadside unit, and we have a number of obstructions. These could be parked cars, these could be moving pedestrians, static pedestrians, moving cars, etc. And we have different categories where each of these different sort of scenarios are explored. And so what we have seen is, and in the interest of time, I'll move some of the other results in. What I'm trying to get to is that if I update the entire model, that means if I send all the LiDAR, camera, GPS, and an integration layer, that's what you see on the blue line on the top. But instead, if I send pieces of it, if I send randomly one of the branches, I'm doing reasonably well. I'm not there at the 68.17% here, but I'm still fairly close. Versus if I do a more, let's say, a greedy LiDAR method, that means I'm only sending LiDAR all the time, I'm not doing that well. So here is another open challenge, is in such multimodal fusion methods, when you're trying to fuse these different branches, under what conditions would you take in would you take in one sensor over the other as part of the averaged model, and when would you take in the entire model? So it also depends upon your channel conditions on the uplink, how well a certain model is trained, how deep is the model. So there's a lot of exploration space here possible where we can extend these sort of results. Now, just one thing to note here is that there is a lot of, how good is this whole federated averaging approach compared to a centralized approach if, for example, you had all the data centrally collected, right? So imagine there is no individual vehicle that is sending data, but somehow you were able to aggregate everything in one place at the start. So that is what you see here. You're getting, for 10 vehicles, you're getting around 87%. And with this federated averaging method, the maximum you can get is 68%. So there is some hit. And here is, again, an opportunity to make better federated averaging models so that you get closer to this global, this maximum combined accuracy of the global data set at 87%. Now, what are we doing in this space forward? So moving forward, what we are trying to do is, now, as I showed you, I can create the same environment using Blender, Blender, and using ray tracing tools in a virtual environment. And I have a real car in a real environment. So what we're trying now is to take our trained models in a completely virtual environment and then port it into the real world. And for that, I don't have, in the interest of time, I can't show you all those results here, but we are using techniques of meta learning, where, and in fact, this is an interesting example where, if you're given an exam, and I give you a bunch of practice tests, you would try to ace all those practice tests with the hope that when you reach the exam, you will outscore in the final exam, in the final test as well. There's always a problem of overfitting and overlearning those highly parameterized situations. So what if the better approach is to not ace all the practice tests, but to get to a point where, given some new or given one question in the final exam and the answer to it, you're very quickly able to pivot and learn from that one example and do extremely well in the remaining 9. So that is, at a high level, what I mean by applying meta learning. So we've been applying that kind of techniques where we have all this synthetic data. We are using meta learning on that synthetic environment and then applying it into the real world. And by doing a little bit, about a 1% new live data collection, and you can do fairly well. We've shown you can do way better than just completely relearning the model all over again. Okay, so just to give you a sense as to the overall sense of the conclusions is that we have looked at how do you find the top K beams given this multimodal environment. We have also shown you how to create models that are, how do you learn these models using inputs from multiple vehicles so that you can find the best averaged model and then send it down. There are many open challenges here, as I said. How do you find, how do you select this K? How do you do a better federated averaging? Which branch do you send for averaging, and so on? And finally, I just want to touch just one slide on other stuff that is that could be of interest. So there's a lot of interest in this whole air and space networks, and it's an open question as to how we will leverage this layer of mobility in the air and also in the sky above. So here's an example where we have drones. Here in the first situation, you can the drone is able to transmit and the receiver is able to receive. But as the interferer steps up, you see the frame error rate shooting up too. And then other drones come together and jointly they coordinate their transmissions as form of a distributed beamforming array and able to overcome the interference of this interferer that you see, and the frame error rate goes down. So how do you create these distributed call it base stations, and then call it distributed arrays of transmitters, which can flexibly provide you with signals and high signal strength at certain pocket locations on a need basis. We can emulate, as I said, vehicular scenarios in the Colosseum. Here's this example. This is called as the Alleys of Austin scenario. There are a number of vehicles that are moving, and there are sort of vehicles that are hovering, or UAVs hovering in the air. And you can set up links between any of these vehicles to any of these ground-based vehicles. So lots of interesting scenarios there as well. You can shape environments. Yes, sir.
Kaushik, can you hear me? Okay, can you wrap up in next couple of minutes?
Yes,
okay,
yes. Yeah, this is the last one. And then, all right. So here is the reconfigurable surface where your environment can adapt as you are moving. That means so depending upon your movement, your reflections are able to, you can program reflections to track your vehicle and make sure that the vehicle is receiving strong signals. I'll leave this one. And the last one is really when you're sharing spectrum, how would you do so in a robust manner? For example, we have shown that you can have you can detect weak underlay signals behind existing waveforms. So you can have a radar waveform behind an LT waveform. The benefit here is that your whole fleet of cars is now a spectrum sensing network, which is able to tell you at different points of your city what is the spectrum occupancy, who is interfering, and thereby be a distributed monitoring network in the environment. All right, with that said, that's all I have, and thank you very much for listening to me, and I'm happy to take a few questions if you have.
Thank you, Kaushik. Let us thank the speaker. So probably for the sake of the time, we will take only a couple of questions. Any questions from the audience to Dr. Chaudhary? Any questions from anyone? Yes, go ahead.
Yeah, thanks, Kaushik. Fantastic presentation. So what is the end goal here? What are we mapping eventually? What's the output we are looking at?
So for the works that I was showing here, we are trying to find the best connected or how to establish high bandwidth and the best links in the millimeter wave band for connected vehicles. That was this example that I was covering for most of the talk. And how would you do so? By using sensor fusion. Okay,
so you have this multimodal data. How do you what beams you select to transmit this data to get maximum efficiency? Is that right?
Yes. So basically, you have maybe a few milliseconds of contact time, and the vehicle has to uplink a massive amount. So you're generating around 40 gigabits per second of data. So how do you send all that data out in a very short contact time with the roadside unit? You won't have time to sweep through options. So for that reason, some method like this that uses contextual environment to do this.
Thanks.
Okay. Thank you, Dr. Chaudhary, for taking time so early in the morning to present your research to us. Thank you. Thank you so much.
Thank you.
now the next speaker, we are inviting Dr. Geeta Krishnan Ramadurai. So he's a professor in Transportation Engineering Division, Department of Civil Engineering, IIT Madras. His research interests include sustainable and safe transportation systems, data-driven modeling and optimization of transportation systems, vehicular emissions, public transit networks. His contribution to ITS include the development of algorithms, and also he has contributed to the theories of traffic and transportation science in highly heterogeneous traffic by explicitly accounting for varying network, roadway and technology characteristics. So his notable achievements include establishment of connected intelligent urban transportation. Now I invite Dr. Geeta Krishnan to have his presentation.
Okay, good evening all. I thank Satish for introducing me, and I thank MEITY for having me over here. My name is Geeta Krishnan, and I'm from IIT Madras. So what I'll do is I'll initially give some introduction about ITS research at IIT Madras, and then I'll talk about the Mobility and Intelligent Transportation Collaborative that we are proposing to set up at IIT Madras, and then a few sample topics of interest that we are looking to submit as part of the NSF MEITY call. So we've had a fairly long association with MEITY, along with CDAC Trivandrum. We've been working with them for the last 13, 14 years. It started with the Intrans Phase 1 project, in which we developed an advanced traveler information systems, which was implemented in Chennai. And this was one of the first projects of its kind in India, where we're getting real-time data from the field, fusing this data and then giving information back to the public through both a website as well as through what we refer to as variable message signboards, which are placed on the roadside. So this was a successful project which we demonstrated in the field, and subsequently in the Intrans Phase 2, we took up multiple projects. Just briefly listing the projects here. So this one is on improving road safety through driver assistance and warning systems. And the idea here was to have some kind of a sensor system which can detect the traffic surrounding the subject vehicle and give warning in case there are dangerous situations that the vehicle is getting into. And so this was done in collaboration again with CDAC, developed the millimeter wave radar systems, and Mahindra from the industry side, one of the leading automotive manufacturers in the country. And this system was also developed and demonstrated both in Chennai as well as in Trivandrum. I had a short video, but I think because of time, we will skip the video. Another project that we worked on is bus priority system, basically providing priority to buses at signalized intersections. And so the key here is we need to consider, what Satish also mentioned, the Indian heterogeneous traffic system, right? Before we optimize for priority for buses, we need to keep that in mind. And in this particular study, again in collaboration with CDAC, the devices were developed, the algorithms were developed and implemented and demonstrated in a particular corridor in Chennai. And this project had multiple outcomes, including research publications, patents, as well as a product which has been, the technology has been transferred to the industry. The third project that was recently taken up was on coming up with a departure time planner. And if you look at predictions for travel time, as we go into the future, these predictions become more and more uncertain, right? The ranges that they give you are fairly large. So how can we improve on these predictions, make them more accurate, was the idea here, right? And most models tend to use historic data, but we need to have more real-time data to have accurate predictions. And often this leads to a lot of wasted time, productivity loss, and so on, right? And in this particular case, what happens is, we used sensors that are deployed in buses, and we use this data from the sensors in real time to be able to predict things accurately, even few hours into the future. Right? So essentially, we deployed this in a couple of 3 corridors in Chennai again. Right? What you see here in the red is where the airport is. So we're looking at connection from central Chennai and then northwest of Chennai, as well as southwest of Chennai to the airport. These are 3 major corridors in Chennai, and this is example of images from the bus where we've deployed these units, and you can see that we also have roadside units deployed where you have the signal controllers, and we get about 5 to 9 minutes accuracy for these corridors. So this uses fairly sparse infrastructure. It is very easily scalable because it's modular, right? And it's been customized for Indian traffic, right? And this also had patents and copyrights developed. A fourth project under this Intrans Phase 2 was to look at public transit systems and coming up with data-driven models to provide personalized route guidance for the users, right? So typically, when we look at Google Maps, you get information about what is the least travel time path, right? So here, users could choose other objectives like minimize my walking time, right? I want to have less transfers and so on. So this is one particular project that we did, and we kind of benchmarked it with some of the other existing applications out there. And in terms of features, we take multiple boxes compared to what is already there. And this was demonstrated with both Chennai and Bangalore data. We also developed an app for operations, bus operations control, more focused on scheduling. So if you had waited at a bus stop in some of the cities, you would find you'll have multiple buses, the same route coming together, right? So this is referred to as bus punching. So we develop algorithms by which you could minimize the bus punching, right? And this is a tool that the operators can use to optimize their scheduling in real time. So these are examples of projects that we've executed at IIT Madras with support from MEITY and CDAC. So I'll now briefly talk about future plans as well as some ideas for this NSF MEITY call. In particular, we are working on a very ambitious idea called the Mobility and Intelligent Transportation Collaborative. So this is you can refer to it as a center where you're bringing in multiple stakeholders to the same platform. We saw the quantum computing center sometime earlier, right? It's somewhat similar, but the idea here is to make it more collaborative, right? So the future of mobility is not going to necessarily be shaped by the government alone or the industry alone or academia alone, right? So it requires, the stake is fairly large that we leave it to happen in silos, right? We need to come together and solve problems. And with that objective, we've launched this collaborative. So you have government, public agencies, you have academia, you also have the industry taking part in it, right? The core of this is going to look at human factors, but we also look at multidisciplinary perspectives be it environmental impact, having a systems approach, looking at policy factors as well. Right? Eventually, we want to be a preeminent global initiative that builds digital mobility infrastructure, right? And address at least 3 of the sustainable development goals that deals with mobility, right? And for India, we are setting this goal of achieving 50% reduction in emissions, 50% reduction in fatalities, 50% of all transport using net zero modes by 2050. Right? So that's the kind of goal that we're setting for this collaborator, right? And we already have had some initiatives. We had a roundtable at IIT Madras where we brought in the industry and we brainstormed on important topics. What are some of the things that we need to take up, and some of the vision and other things I shared came out of that. And you can see we are well represented by different industry categories. You have automotive companies, you have automotive part manufacturers, you also have infrastructure companies, as well as two-wheeler companies and IT players, right? So these are some of the companies that we are looking at. Right now, we are signing MOUs with some of these companies to make them founding partners in this collaborative. We are also engaging with government agencies as we speak. Right? The thesis of this MINT collaborative is to kind of build on the success that India has seen in the past 10 years, right, over a decade, starting from biometric identification, that's Aadhaar. We kind of built the infrastructure for UPI, right, Unified Payment Interface. And now we are having ONDC, which is kind of revolutionizing the e-commerce system as well as the mobility, right? So we are saying we need to build a similar mobility stack, a digital mobility stack, right, which can build on these existing stacks that we've already built, right, what we refer to as a digital India stack, and then enable seamless mobility, right? Make mobility more accessible, make mobility more sustainable, right? So that's the overall essence. And what we're going to propose as part of this collaborative is to develop this Bharat multimodal mobility stack, right? I know Kaushik used multimodal from a certain perspective where he looked at different data sources. But here, when we say multimodal in mobility, we mean multiple transportation modes, right? And combining them in a seamless way is what we refer to as multimodality. And that's essentially what we are proposing. So this is a quick schematic of how this multimodal mobility stack will look like. So that is terabytes, petabytes of data as we speak that's being collected across the country today from the mobility sector, right? And I was just having some conversations earlier today as well on how a lot of this data is not being used for value addition, right? So one of the goals of this stack will be to develop some kind of APIs, some mobility protocols through which government agencies, industries can transmit data as well as take data back, right? And that's going to be a repository of a rich data source, a real-time repository of data source. And of course, we'll have to ensure privacy and we'll have to ensure data quality. So there will be several filters we apply so that we can understand this data better and archive this data. But the repository doesn't stop there. It's not just collection of data. We want to make available models, digital twins that can be used by different sectors to make use of this data, to build applications, to build solutions on top of this data. And we also would like to use this data to measure impact, right? Finally, you want to make changes in the field, right? So you want to reduce air quality in Delhi. What would happen if you implement a certain policy? Can we use the data? Can we use the model and then measure the impact of what that policy would be in terms of, say, improving air quality, right? So that's the kind of goals that we are aiming for as part of this stack, right? The value propositions are quite varied. There are multiple stakeholders, as I mentioned, and we believe there is significant value each of these stakeholders can derive, right, from this kind of a system. We are looking to also engage with government agencies. So we already have a multimodal mobility research proposal as part of the Institute of Eminence scheme that's been approved at IIT Madras, and we are now talking to multiple ministries to see if we can use the same multimodal mobility stack to come up with specific solutions. For example, to railways, we are proposing a freight planner. To Mohua, we are suggesting some kind of a green mobility initiative, and similarly for improving safety to Morth. These are separate proposals that kind of build on the capability of this mobility stack, right? And the industry as well can have several projects that can again build on this mobility stack, make use of the mobility stack to validate, design, optimize the solutions, right? So a few examples have been listed here in terms of what this can enable. At IIT Madras, we are setting up this connected intelligent transportation lab. As part of this, we are proposing to set up a test bed and a smart track. The smart track would basically have all these sensors embedded in the system itself. So we could use this as a sounding board for future technologies, right? So that's the idea here. And we already have a 5G test bed that's been set up at IIT Madras, and we would like to collaborate with them and see if we can combine their setup with this mobility smart track that we are setting up, so that we can leverage on what we've already got at IIT Madras. We would like to propose several projects. I'll briefly touch upon these. One is on developing digital twin for smart cities. The other is developing remote driving of trucks, right? Basically look at semi-autonomy before we go to full autonomy. And a third idea I'll talk about is how do you get to Vision Zero or eliminate road fatalities. And in particular, we'll talk about how we would like to use unmanned aerial vehicles to do this. So digital twin, many of you may be familiar with what a digital twin is. It's become kind of like a buzzword today. But one thing I want to just highlight here is we've been doing a lot of simulation, we've been doing a lot of modeling with real-time data and so on. A digital twin kind of goes beyond that, right? It allows for a two-way flow of information. A digital twin is like a living twin of the physical world, right? And we can use it to react in real time to come up with operational solutions, not just planning and strategic solutions, but also operational solutions with the digital twin, right? And why are we talking about it now? There are 100 smart city projects across India, right? And they have executed over 5,000 projects, right? And each of these smart cities is sitting on, terabytes, petabytes of data, right? And they're not yet deriving optimal value from this data, right? So that's something that we really need to look at. And over 2 lakh crores of investment has been, earmarked for these projects, right? And in mobility, there are multiple ITS projects, right? These again generate a lot of data. There are also several metro and public transit projects that are underway. And we are also seeing a lot of action in terms of EVs, charging stations, and so on. And we are all experiencing the issues of air quality, right? So how can we leverage all of these data in coming up with solutions? And in order to do that, can we develop a digital twin that these smart cities can make use of in policy and planning, right? So that's the idea here. In the interest of time, I won't go into a lot of these details, but essentially, again, we are looking at representing the physical mobility network in a digital way, right? We want to leverage on existing data sources. There are already a lot of data available. It's just not pooled in a central place, or it's not useful right now. We need to see how to make use of that. And there is also other sources of data that's becoming available. For example, cell phone tracking data, right? So telecom companies, they know where we are, how long we are there, and where we are moving, right? Continuously. So can we get access to this data so that we can do better planning, right? And eventually integrate this with digital twin and have visualization platforms so that better decisions can be made, right? So again, multiple stakeholders can benefit from this kind of a solution, right? So this is one project that we are looking to propose. The second one is on what I refer to as semi-autonomous truck driving. So this is a problem that is worldwide, but there are articles in the United States, there are articles in India as well that highlight the severity of this problem, right? So truck drivers are not available, right? It's not a very attractive profession. You have to be away from home for weeks together, right? And people don't like that kind of a job, and that's leading to a huge crisis in the trucking industry. Right? And same problem in India, and in India it's also paid very low, unlike the US, where I think truck driver salaries are reasonably high. In India, the truck driver salaries are also very low, right? And it's turning out to be very difficult to find truck drivers. So the objective in this particular project is to kind of demonstrate a remote truck driving technology using 5G, right, and sensors. So there are some technology demonstrations worldwide, right? But Indian traffic, heterogeneous traffic, how do you make it work in such a situation is definitely going to be challenging. And we want to demonstrate this in the test track that we are proposing to set up in the satellite campus of IIT Madras. Right. So this is again a proposed work. It's not yet started, and the work will itself span TRLs levels 2 to 5, and it'll have, of course, multiple sub objectives as part of it. Right. This will include coming up with sensors, coming up with ways to fuse all of this data that the previous speaker also spoke about. Right. Using 5G for communication. Right. And then testing it out with a desktop simulator and see how well they're able to control, right? And also come up with AI models which are responsible, right? How does it behave when you have to take important decisions, strategic decisions, right? How do you behave? So those are things that we look at as part of this. So again, there are multiple end users for this. People are waiting for this kind of technology. So I think if we are able to develop this, it will have huge impact for this industry. So this is the connected vehicle that we already have at IIT Madras. This is the driving simulator that we already have. So we want to leverage on some of these. This is a test track that we are setting up about 40 kilometers from the main campus in Chennai. Right. So we'll leverage on these for this particular project, demonstrate these. The final quick project thing that I would like to update is on I talked about Vision Zero. One of the key things for that is emergency response. We've already been working with the state emergency response system, the 108 system, and we collaborate in this particular project with Professor Lavanya Marla. So she's at UIUC, right? Same as what Dr. Anand is from, right? So she's from the Industrial and Enterprise Systems Engineering Group. So in this particular project, we worked with traditional ambulances. How do you locate? How do you dynamically allocate these ambulances? How do you optimize it, and so on? I think since time is limited, I won't go through the details here. But we did demonstrate that using state-of-the-art algorithms and methodology, we are able to improve both placing ambulances as well as optimizing these ambulances. Right. And one of the key ideas behind this is in prediction of when you need ambulances, how you need ambulances. So we develop some deep learning models to improve on these predictions. Right. So that's what we do here. And in this particular proposed project, what we're suggesting is you already have different types of ambulances in the field, what you refer to as basic life support, advanced life support. More recently, first responders and two-wheelers have been introduced. Right. Now, to this mix, if you add drones, if you add unmanned aerial vehicles, which can even lift passengers, right? How would you optimize this entire system taken together? Right? So that's another project that we are interested in proposing as part of this NSF MEITY collaborator. Yeah. With that, I'll stop. The questions, I'll be happy to take questions. Thanks.
Please take a moment to appreciate this beautiful presentation, everybody. Very interactive, interesting. Thank you very much, sir, for conducting it so well. And I will also take a moment to appreciate our moderators for moderating this session flawlessly. Can you just put your hands together in order to appreciate our moderators also?
I think we can have one or two questions to Dr. Geeta Krishnan.
Any questions? Yeah.
So, hello, Professor. Swaminathan here from IIT Indore. Yeah, very interesting presentation. And just one question is, are you using this 4G networks as a part for your intelligent transportation systems, whatever you have tested? And what you are expecting from 5G, basically, how it can improve your performances of whatever you are speaking. Can you just comment on that?
Yeah. I mean, we use mobile technology for this GPS data that we've been collecting, right? So that we've used 4G networks. Also for some of the video image processing, we used 4G networks. I think what 5G is going to enable is the low latency, right? The applications with respect to connected vehicles. I think that can, we'll see the light of day only with 5G with low latency, right? So that's what we would like to test out, work on.
So 5G is already on, but have you been using that?
Not yet, not yet. We have the 5G testbed that's been set up at IIT Madras. So we would like to leverage on that for some of these projects.
Thank you.
We can take one more question.
So my question is, you have to have all antennas around the vehicle, right? When you talk about autonomous vehicle, whether you require radome to protect that? This is first question.
Do I require what?
Radome. Whether you get transmitting structure to protect, like a.
I'm not an expert in that. I'll have to, of course.
Fine. Second question is that we are traveling from our GPS to Navig. Whether have you thought of it, like instead of, because it has got more accuracy. Perhaps it may be beneficial for autonomous vehicles.
Yeah, so I think, if you can get better localization, that can definitely improve several of the algorithms that we have already developed. So, we would be very happy to collaborate if somebody is working with Navig. We would like to see, how that can improve. I do know recently, one of my collaborators was in China, and he was mentioning how their GPS is much more accurate than what we get with our, the traditional GPS devices. So, I would be very interested in exploring, collaborations there.
Well, thank you very much. So,
Thank you.
So please, everybody, appreciate this beautiful, wonderful, exciting panel we had here. All thanks to our moderator and esteemed speakers for conducting it in such a spectacular manner. Now may I request Mr. Mohan Kumar from NSF and can you please help me to welcome everybody? Mr. S.K. Marwa, sir, please come on stage in order to felicitate with token of gratitude. And after this session, there is a summary report for all the sessions by Mr. Mohan Kumar. Yeah, after this, please, sir. I request our moderators, please come forward for the felicitation. So please come forward. Ladies and gentlemen, a round of applause for our moderators. Now may I request Mr. Geeta Krishnan, sir, please come forward. Thank you very much for this wonderful session. Well, now let's have a group picture together.
I would like to invite Kamlesh here.
Mr. Kamlesh, sir, please come on stage. Please help me to welcome sir on stage. A big round of applause. It really helped us in order to conduct this whole workshop or 2 days. So I believe we should have a special round of applause for Mr. Kamlesh. From briefing the anchor to the team, he has done it all.
So, Kamle, all the arrangement, this workshop that you have seen, and the preceding webinars have all been organized by Kamlesh. Right from the concept to the agenda, everything, along with the discussions, of course, with the NSF team. And he has been instrumental. And I think there is always a teamwork, but there has to be a leader to make any gathering like this a success. So, big round of applause for him. Yeah, thank you.
Thank you, Sunita. I would request Kamalesh to facilitate another special person for the last 2 days. That is Ashita, our MC. She has been wonderful over the last 2 days. Thank you, Ashita.
So now, thank you very much for this honor. Let's have a group picture together, gentlemen. Sunita ma'am, please join us on stage. So now, ladies and gentlemen, I hand over the mic and the stage to Mr. Mohan for the summary report of all the sessions. He's a very right person, the veteran himself. Please help me to welcome Mr. Mohan Kumar from NSF. Everybody.
Thank you, Ashita. Actually, I will not be summarizing, but I will be requesting my colleagues here to summarize the various group discussions and sessions we have had for the last 2 days. Let me go in alphabetical order, and you can come and sit here. You don't have to use PowerPoint slides. You can just say what are the outcomes of the group discussions that you have had last evening and since last evening. Let me call folks in alphabetical order of the areas: cybersecurity, Tarun Pandey and Nidhi Rastogi. Sure, okay. Okay.
Thank you. So we had a good discussion yesterday evening. So I think we passed 7 p.m. So it ended 15-20 minutes more than what we have planned for. And we had few questions which were given to us. Only 5 minutes. Okay, so quickly coming to the questions. There was first question, 3 key research challenges in the area of cybersecurity. So we got a lot of inputs, and there were input on post-quantum cryptography challenges in semiconductors, network security including ISP level data, perimeter level, packet level security, pattern matching, IPv6, and also identify vulnerability actively from Indian cyberspace. Next generation security, authentication protocol in 5G, IoT devices to devices. Blockchain, we got some good research challenges in blockchain, including threat intelligence sharing in blockchain, knowledge sharing for threat intelligence, decentralized threats. There was some challenges regarding to digital signature, including a root of trust, PKI, digital trust. You want to continue or?
I can do it.
Yeah.
So these were the research challenges. If anybody kind of resonates with these keywords but didn't really follow, you can let us know. I think a lot of the information is in our heads. And then, and we also kind of noted down the names of the people who proposed these ideas. So if you want to collaborate with them, we'll be able to share those names with you. And then the other question was about what were the 3 key challenges to establish collaboration. It was reiterated by several participants that the list of potential collaborators from both India and the US be shared so folks can reach out to them, and not just the names but also their areas of interest. So that was one thing that people wanted to have, and then the other challenge was a very short time period to collaborate, essentially find collaborations and then come up with a research idea that they can propose. And then difficult for Indian PIs to understand whether this is a research, what will be the outcome? Is it research? Is it product? Is it a mix of the two? If it is product, then how would the IP be shared between the industry folks and the Indian PIs? Moving on to positive comments from the workshop. I'll just go over this and then we can wrap it up. So folks were very excited about this workshop. Everybody was extremely happy that this happened, and people took away a lot of ideas that they would be sharing with their students, having class discussions, and also encouraging a lot more discussion amongst their peers. Some researchers were thinking about green cybersecurity. They found that these sessions, especially the final panel discussions and then the breakout sessions, they found them both to be very stimulating. And some of them even went ahead and said that these are one of a kind and very interactive. So that was a big positive. And then heard new perspectives from experts from US and from India. So that was one key highlight. And then also that even though there was some concerns about we don't have specific ideas, in our discussion, in our breakout session, folks thought that because the scope of the research topics was broad enough, they could, that gave them wider possibilities for collaboration. And then the final one is any comments to improve the organization of the workshop. I will leave that to my MEITY counterpart.
So there were more positive comment, I should say, but there were of course some things which need to be improved as given by us to us. There was like one major was like they are not clear whether there should be a research outcome as a product or they are looking for a basic research. That was the question put up by most of the people who joined online as a physical mode. Then there was a question from PIs from India about productization of research, and one suggestion was like if we can put something on Excel, WhatsApp, or on website where the participants can see each other work what they want to do, and this may help them to collaborate with each other. One from our moderator, the timing of the workshop was not favorable in US collaborations from point of view, I think university exam and all those stuffs are going on. So they are facing maybe if it have been 2 weeks later on, some more people may have joined. That's a comment from the so there were 2 more questions. Number of participants. I hope that the most of the participants was on cybersecurity. So it was total 39 people. 19 were online and 22 in person were there over here. There were few, last question was how many many in the group have collaboration partner? 1 or 2 from yesterday, the people who joined physical were already having some potential collaboration with a US counterpart. So they already have 1 or 2, but most of the people were searching for for collaboration from India and US. Thank you. So that's
Thank
all
you.
from our
Thank you, Tarun and Nidhi. You have done a wonderful job. Please give a round of applause to Nidhi and Tarun. By the way, you please share those with us by email. And myself, the NSF folks and MEITY folks will work together and create a frequently asked questions document so that people can take a look and before they write us a proposal. Kiran Kochi for communications. He has a flight. I had to drop my idea of going in alphabetical order. So please go ahead.
Yeah, thank you. We had more than 35 people yesterday evening participating in the discussion on communication and networking technologies. There was a lot of discussion and debate. I will jump right to the 3 key research challenges that came out of this discussion. Ubiquitous connectivity using a combination of terrestrial and non-terrestrial systems. This is one of the topics that came prominently out. And the second topic of importance is energy efficient communications. This was discussed. And the third key point is AI and ML in RAN network optimization, radio access network optimization. These are the 3 key points that I think this group has identified. And there are questions on expectations on the collaborations. NSF has made it amply clear that advancement of the state of the art is a priority for the NSF side. And from MEITY point of view, translational research is expected. This was communicated to the group so that there is clarity on what's on the expectations. Like in the other group, many people have requested to make the list of participants available to them so that you can do some hooking up, talk to each other on both sides. This is a brief and short summary. Thank you.
Thank you so much, Kiran, and yourself and Sajal worked on this together. Thank you so much. Appreciate it. And please share those comments with us sometime in the next week. Thank you. Next would be ITS. Nirmalyo and was it Dhruv? Nirmalyo, okay. Satish and Nirmalyo. If the comments on the general parts are similar to what others have said, you can skip those. Focus on the areas.
Okay, good afternoon, everyone. So we have a very good discussion in the intelligent transportation system breakout session. We have close to 12 in person and about 17 online attendees. And we discuss the challenges of ITS with respect to cybersecurity and next generation traffic incident management and the role of multimodal data collection and decision making for ITS, and as well as for transit asset management and predictive maintenance and the Vision Zero, mostly in terms of US context. Then Satish also pointed out some of the context in terms of Indian environment, mostly related to traffic regulation and management, traffic adversary information, public transport system, electronic payment, and road safety. Then we brainstorm about some of the grand challenges. So one of the grand challenges pointed out by the participant is multimodal data fusion and how it could be used for different applications like collision avoidance detection systems or maybe for driver behavior detection systems. And not only application, there are fundamental research questions we also discuss. Some of the participants brainstorm about how low latency, high fidelity advanced communication systems could be used to provide just-in-time information such that those collisions could be avoided. The driver behavior monitoring could be more reliable and accurate. We also discuss about the application of digital twin, how digital twin can be used for various applications, including the battery health monitoring and how they are dissipating their charge from the battery in terms of electric vehicle. Those could also be looked upon. And also another point raised by the participant is standard and interoperability. How the standard and interoperability could be addressed across these ITS. Anything else, Satish, you want to point out? And about the concerns, it is common, so I'm skipping, like how to find the active collaborator from the US side. We suggested go to NSF Active Award site and search over there about the professors who has active research award in their common interest research areas. So this is a brief summary of the ITS. Satish, any point you would like to add?
Yeah, apart from that, I think there are a lot of data that is generated by the sensors. So I think big data and its analytics is one of the main area how to bring in for the sustainable transportation. So that is one more area. And also before going into autonomous, maybe we can have the connected signals kind of thing where in which we already can have used the existing infrastructure and then pulling the data into the vehicle so that the drivers are provided with the in-vehicle information for so that can be done immediately. So I think these are the areas which we have discussed, and I think which we find it very potential for the Indian market. Thank you.
Thank you so much, Nirmalya and Satish. We really appreciate your contribution. So the next is green and sustainable technologies, Ratish and Anand.
Good evening, all. We had a very proactive session. Almost 40 plus participants attended. At the outset, I thank NSF for arranging a breakdown session because many of them were confused by seeing a MEITY call. Many of them came with a product-oriented research. So thanks, Dr. Anand, because he was also attached to NSF. The initial phase itself, we made it very clear that it should have intellectual output and broader perspective. This was made it very clear to them. In fact, we nailed down 3 projects, 3 ideas. One is green energy generation and storage. Next one is converters for microgrids, CVs, solar inverters, windmills. The third one is resource efficiency and circular economy through recycling and climate change impact on natural resources. These are the areas which we have nailed down. Most of these problems associated with was identifying, suitable partners, defining synergy among them. These are some of the challenge which was proposed. Then, of course, I have already talked about most of them came with a product-oriented research. They have to change their school of thought or framework to come out with that. So, over to Dr. Anand for you.
Yeah, Ritish, you have covered. Ritish has covered everything. I guess we discussed. I think one of the main things that we also had was a lot of interest. We had over 30, 35, 40 people. Yeah, so there is a lot of interest in this area, and I think the synthesis went really well, as Ritesh put. Like, we were able to synthesize like all the 30 odd comments that we got into these 3 areas, and there was a general agreement with the areas identified. So I think it was a great job with Ritesh.
So the other thing is that we could interact with every participant. We noted their names, their area of interest, and all that. We'll share it with both NSF and MEITY. Thank you.
Thank you so much, both of you, Satish and Anand. So the last one, Semiconductor Research, Ramana, please. Ramana and Suchi, I think Suchi has gone. So it would be Ramana. So you have the distinction of making the last presentation of the.
It was a fantastic discussion about the research challenges, priority areas, and so on. And similar to all other teams, we have had issues about the IP and so on. So let me summarize briefly. The priority areas are how can we push the boundaries of electronics by means of organics, printed electronics. That's the first area that we discussed. And of course, Suchi Guha is expert in that area, and she has ongoing collaborations with the Indian Institute of Science, Bangalore. The second area that we discussed was how can we take the advantage of the CMIT capabilities in areas such as graphene-based semiconductors and quantum dots, and integrating them with other oxide semiconductors for energy storage and conversion applications, which is also of the priority area for the United States at this moment. So there is a clear synergy, and we identified that as a second priority area. And the third one was wide bandgap oxides or ultra wide bandgap materials in general. When you say semiconductors, you always think that like only silicon, germanium, and so on. But right now, things are changing quite a bit. And United States, European countries, most recently India as well, identified the gallium, germanium, hafnium, and all these compounds as critical elements and slowly reduce the dependence on rare earth elements in China and so on. Sorry to say this, but we want to eliminate the dependence on China as much as possible. So that can be possible by identifying the projects related to these gallium oxide, germanium oxide, hafnium oxide, gallium nitrides, arsenium, gallium arsenide, and so on. So these kind of semiconductors for high power electronic applications and so on. That's another area. These are the 3 potential areas that we discussed quite a bit, but there was 4th area. I had to say apologies to Dr. Sunita Verma. We were able to offer excellent resources for all other topics, but the last one was equipment side or fab side towards semiconductors. And how can we facilitate that? Perhaps like down the road, we might think about it. Really good to know. The breakout session gave us an opportunity to learn what the India side is needed and so on. But however, I myself took the responsibility to connect to a few companies around in Texas as well as Seattle. So we'll see if we can help in that direction. But that one was identified as a most critical area, but for sure, this call, we may not be able to do anything. Then the critical challenges, again, unfortunately, only 2 teams were with already existing collaborations. And IP issue was a big issue for everyone. And since I got the opportunity, I'm going to take 1 more minute with your permission. Last night, when we were not getting sleep, I digged out all the information through Nation Science Foundation and also clarified. The good news is for proposal submission, you don't have to have IP or memorandum of understanding in place. You can count on that. You can count on me. And it's given fact that NSF in the latest guidelines clearly mentioned for this joint collaboration program with India, you don't have to have one in place before the proposal submission. Proposal submission can be happened without that. However, if you are selected by the National Science Foundation and MEITY for the award, before that award takes place, then you have to execute IP agreement, MOU, and so on. So since that was of very, very particular concern among almost all the teams, I think like this will help all the teams to put together their excellent proposals, forgetting about IPs, MOUs, and then we can think about that later on. And the second one was how to approach the US professors or investigators for the Indian side. That was discussed quite elaborately. That was another challenging problem and so on. And similar to all other teams, that we have also had a challenging issue of how to approach the industry. Again, like Indian side. Perhaps like US side, it was very easy and so on, but unfortunately, on the Indian side, everybody expressed concern, like how can we get the industry component into the proposal and so on. And then the number of participants were about 20, 25 in person, and some of them, like 9 were online. So similar number, 30 plus in the semiconductors area as well. And did I miss anything? The last one?
It's pretty good. Thank you.
Okay.
Thank you.
That's
Thank
all
you,
from my
Ramana.
side.
Thank you so much. So that is it, we are done. Thanks everyone for staying here till what, 5:51 on day 2, which is great. The number of people present in the workshop or conference room on the last day, last minute, is a good indication of the success of the workshop in this case. So we do have more than 65, 70 people here. Thank you all so much for staying. Thanks for your patience. Please show the same kind of patience when you start your partnerships with your collaborators and write quality proposals. It does not have to be immediate ones. As I said, these are 2 strong democracies, and our objective is to create long-term partnerships. So if it does not happen this time, it will happen after 2 or 3 years. So, but continue to have the partnerships, and in the end, you will be successful. Thank you again.
Thank you all the participants in this MEITY NSF call for proposal. I think this is the first call and the first workshop that has happened. And there'll be many more calls after this. As it was said yesterday also and today also, this is to be continued. And this is just the starting beginning. And maybe this one we had required a few things we have learned is that we needed more of academia participation and industry participation. We'll see from MEITY side how we'll be able to connect, have maybe one more workshop to bring together the industry and the academia for the collaborations. And also we would like to have more online participations, and we can also have some webinars if it is required. So if there are any such requests, we'll just look into it from the India side if you want for the proposal formulation. And I would like to thank the complete team, Dr. Mohan Kumar and his team from NSF, Kate, and the various team leaders from the different schemes who were not able to be here in person, but they had been regularly in touch with us for the discussions. Several rounds of discussions have happened before we could formulate this call for proposal, our MEITY NSF collaboration, and also the workshop. So I would like to thank all the team members from NSF to make it a success, and all the in-person attendees from US, our researchers, a very big thank you, because I know this is a very crucial time for all the academia participants who have come sparing their very precious time for this workshop to make it a success. So I thank all the US delegates as well as the Indian participants. I think there has been very keen interest, lots of questions, interactive sessions, which have been, I think, very useful for all of you, and will be based on these different queries that have been received. We'll go for the more posting of the FAQs.
And I think that's all from my side. Thank you to the media who has been taking care of the photographs and the press briefings. And thank you to my team from MEITY, all the officers who have tried to make it a success. This is just the beginning. Now we'll be getting the proposals and actually examining it. So, and that's from my side. Yeah, thank you.
Okay, thank you. Special thanks to Dr. Mohan Kumar and all the participants from US who have physically made it here. It was indeed a wonderful interaction these 2 days. And in case, we request all of you to get connected. You can be in touch with us. Any suggestions, any further suggestions, they are most welcome. And whichever way the ministry can help you out in formulation of high quality proposals, we will be very happy to do that in coordination with the NSF. So with that, we come.
I would like to just point out that, as Sunita madam said, it was at very short notice because the number of participants from US were very small. We initiated requests to a number of my colleagues in the US, and they accepted the invitation and came here to present, to be here in person at very short notice. Not only the persons who are here in physically, I can see Dhruv Sheshadri from Leha University, Ramana Chintalapalli from UT El Paso, Nidhi Rastogi from Rochester Institute of Technology, Nirmal Roy from UMBC, that stands for University of Maryland, Baltimore County, and Sajal Das and Suchi Guha, who are not here today. They have all come here at very short notice and contributed immensely to this workshop. And also would like to thank, though they are not here, all the remote speakers. And as was said by the MC this earlier in the day, some of them got up at 4 a.m. and some of them were awake till midnight, 12:30 a.m. to give their presentations. So we really appreciate their contributions. And all of you as well for being here and participating in the workshop till end of the second day. Thank you.
Thank you. Thank you, everyone.